Natural language processing is known as NLP. It is a branch of artificial intelligence that deals with the interaction between computer and human using the natural language. The ultimate objective of NLP is to read, understand and make sense of the human language. And in today's tutorial, we will learn about what is NLP, that is Natural Language Processing, and then we will have a look at some of the data manipulation using NLP, and then we will have a look at bag of words in the naive bias, and then we will jump into what is sequential data and where we can use the NLP concept. Then we will have a look at recurrent neural network, that is also a part of deep learning, and we will have a look at long short-term memory.
Okay folks, so I am Manish Gupta. I work as a senior applied scientist at Microsoft. I also work as adjunct faculty at IIIT Hyderabad. So I guide a few MTech and PhD students there. And I also work as a visiting faculty at ISB. So recently I have started teaching a few courses there. Today I am going to talk about natural language processing. So this is about a 2-hour talk. So unlike the 4-hour torture that you have, this is a shorter torture. So, but it's not going to be as mathematical as that. It's going to be fun. So I deal with a large variety of people. So essentially, from folks who can do as mathematical and more mathematical stuff like that, to folks to kids also, right? So essentially, just ask questions as you have, and just make sure you understand and make the best use of your 2 hours. Okay. So we will start. So natural language processing. So how many people have heard about this phrase earlier, natural language processing or NLP? NLP might be more common than natural language processing, right? About say 1/4 or 1/5 of you guys, right? And has anyone worked on any natural language processing system? Any text processing? Any natural language processing? No? Okay. So that's like a perfect thing, because these slides are also going to introduce the thing. Okay. So so this is going to be pretty much the agenda. So we'll start with what is NLP. I'll talk about a few things called as tokenization, normalization, stemming, and so on. Then we will talk about sentence segmentation, phrase identification. Then something called as word sense disambiguation, and finally talk about parsing. So I usually do slide stuff. So I did not. So basically we could also do some sort of hands-on R stuff. But more or less today it will be more of slide stuff with a little bit of demos here and there. So let's start with what is NLP. So anyone wants to take a try? What is NLP? So, or what system would you call as an NLP system? Trying to understand human language. That's right. So that's called linguistics, right? Which is very close to NLP, right? So trying to understand human language is linguistics. Very close. Anyone? Interesting. So Google search can be considered as one NLP system, which does some sort of. So basically, any search engine is a NLP system. In that sense, you can call it an NLP system vaguely. Text mining, yes, some system which does text mining is an NLP system, right? Yeah. Huh? Artificial. So all these words, right? Data science, data mining, artificial intelligence, deep learning these days, or information retrieval are all related. Okay? But there is a machine learning. They are all related, but there is a slight difference in all of them. Okay? So an NLP system is any system, as it says, natural language processing. So it's a system which takes natural language and processes it. As simple as that. So anything that takes natural language as input and processes it is called a natural language processing system, practically. Okay? So by processing, it means, of course, the system should be of some use, right? So if it produces another transformed natural language, or it produces insights, some insights out of natural language, it's a natural language processing system. Okay? So a search engine is also a natural language processing system because it takes natural language queries, right, or queries that you put in, and gives us insights in terms of results. Okay? So, but practically when people talk about natural language processing systems, they talk about a large umbrella of tasks which fall under this umbrella. Okay? So I'll start with a few examples, the interesting part in this slide. Of course, I'll not read everything on this slide. So NLP is the process of taking natural language text as input and output some insights on natural language from it, transform natural language. Okay? So, why are we having this lecture? Mainly because this course is so focused on applied stuff. So it's a natural language processing systems are critical components across various verticals or various segments. So whether it is finance or insurance or media, e-commerce, retail, oil and gas, anything and everything sort of has data these days and requires natural language interaction. So it's basically a critical component across all of those. So whether it is finance search, so search for various news about companies and therefore try to predict stock market prices and so on, right? Entity matching, call center analysis, or any of those applications, they all require natural language processing. Okay? So one of the applications is say e-commerce, say Flipkart, right? If they want to figure out what are people saying about a particular product, or they want to figure out what are people saying about their service. Right? So what the Flipkart can do is to really look at the reviews that they have and parse them, try to figure out sentiments of people in those reviews, and then figure out what particular aspects people are happy with, what aspects people need improvement, or Flipkart needs to do improvement as people are suggesting, and so on. That is also text processing or natural language processing. Right? It's so important to Flipkart to know what to improve on. Right? So basically it's a critical component across various applications, right? So in the next few slides, I'll show you popular natural language processing systems. So basically, things that have proven to the world that yes, NLP is required, and if NLP is done nicely, it can do a lot of things, a lot of interesting things. Right? So how many of you know about IBM Watson? IBM Watson? So for others who do not know, should go back and search for it. Okay, as simple as that. So I mean, and this is my usual advice to people. To learn anything, if somebody is saying things that you can't understand, then you just go back, and fortunately we have search engines, right? So just search for it. Okay? So IBM Watson is this big natural NLP system that IBM came up with. Okay? And IBM Watson became popular in 2011 when it won this particular game called Jeopardy against the best guys in the world. Okay? So what is Jeopardy? So Jeopardy is this quiz kind of game. So where you know, typical Britannia quiz kind of things that you saw on TV at some point. It's a quiz kind of competition, where there are like many participants and the quiz master asks various questions, and whoever can answer fast is the one, and correct is the one who wins points. Right? So IBM Watson is the system which can take questions of this form. William Wilkinson's An Account of the Principalities of Welsh and Manchuria inspired this author's most famous novel. So who is this author is the question. Right? So now, of course, it's a quiz question, memory-based questions in that sense, right? And computers are very good at storing things, right? At memorizing things, right? It's just about figuring out a nice way of querying those memories or those facts and then showing up the right answer. Right? In this case, the right answer happens to be that guy. Right? So IBM Watson actually won this game against the best people in the world, and that's when people started realizing, oh, there is a good potential for automated NLP, automated natural language processing system, and these systems can do something significant. So another example of a natural language processing system are information extraction systems. Okay? So information extraction systems are a group of systems by themselves. So they are things which take unstructured text, as it is called, and transform it to some structure. Okay? So let me show you this example of an information extraction system which will make it clearer what is unstructured text and what is structure out of it. Right? So this is a typical email. Okay? So this is an email, there's a subject, there's a date, and there's a to in it, and there's the email body in it, right? So, hi Dan, we have now scheduled the curriculum meeting. It will be in gates 159 tomorrow from some time, right? So now, I mean, what can we extract out of it? What kind of structured stuff we can extract out of it? Anyone? Meeting, place, time, yeah, awesome. So we can actually imagine, so I don't know what all email clients you use, but imagine an email client which takes an email of this form and automatically suggest creation of a meeting entry in your calendar. Right? How about that? So essentially, it automatically understands that there's a calendar entry here and automatically extracts those things. So what is the event? What is the date? What is the time? You know, date. So it's not really very trivial. It says we have now scheduled tomorrow, right? So it sees the date of the email and then infers that tomorrow is Jan 16, 2012 in this case. It puts that in there, start, end, where, and so on. So these are information extraction systems which take unstructured piece of text and come up with some structured stuff which is useful, right? So information extraction systems are a form of NLP systems. So if you think of it, still again here you have a natural language input, an email, right? And the output is some insight out of it. So the insight here is the calendar entry. It saves time for a lot of folks who have frequent emails and get many of those emails. frequent meetings. So another kind of application for such NLP systems is in sentiment analysis. The same case, the Flipkart case that I talked about, right? But a little bit on more in detail. So consider this case where people write a lot of reviews, right? So for a camera, say for example. So I want to know how good this camera is doing in the market, right? So what will I do? I'll go to its Amazon's webpage, look at various reviews, try to see what are people talking about. Of course, as a human, I can do it very nicely. I can figure out, oh, people are talking about its weight. They're saying, oh, this is so light in weight. Awesome, right? But imagine an automated system trying to do that, right? Trying to read sentences, figuring out what aspect is being talked about, and then for every aspect, try to look for sentences which talk about that aspect, and try to sort of extract whether they're talking positive or negative about that, and therefore come up automatically with good or bad about that product, and therefore come up automatically with the rating associated with that aspect of the product. Now, such a sentiment analysis system is a NLP system because it basically takes natural language review text and outputs something of that sort, an insight, a structured insight, so to say. So, well, then there are other systems like machine translation systems which take which take natural language input and then transform it to another natural language. Okay? And then there could also be semi-automated machine translation systems which take natural language input and then suggest next word that can be used by a human translator, right? So sort of help the human translator to come up with the next possible word. Okay? So all of those systems are like very awesome systems. Now you won't learn how to build those systems in 2 hours, okay? But these are the things that can be done using an NLP. So if you know awesome NLP, you can actually spend time and build such systems. Okay? So these systems depend on some basic tasks. So basic tasks in the sense things that have applications in those systems. Okay? So what I have done here is on this slide sort of try to capture as much as I can about text-based NLP systems. Okay? And these are grouped into 3 parts, right? So so there are 3 parts. There is this green, yellow, and red parts, right? So the green part is the one where systems exist, NLP systems exist such that they perform really well. So they perform like 90% accuracy and they can actually be used nicely. There are commercial softwares to do those tasks and so on. So the yellow ones are the ones where there are some commercial softwares but the accuracy is not very high. It's like about 70-80% accuracy. And you can use those systems for a larger system, where this thing is going to be used as a signal, but you cannot depend completely on these systems. And the last ones are the systems which are in research. So basically saying that there's no commercial software available for them. And even if there's commercial software, it is not general software. So basically it can work for certain restricted domains, but it doesn't work generally. Okay? So we'll just go over them one by one in brief. So spam detection, all of us have seen how powerful spam detection is in our Gmail boxes, on your local Outlook clients or any of your email boxes. Right? So spam detection sort of works reasonably well. Junk is classified as junk and good emails go to good emails, right? Inbox. So then there is a task called as part of speech tagging. So all of us have struggled through this task in schools, right? So essentially the teacher would give us a sentence and ask us to figure out parts of speech in it, right? What is a noun, what is verb, what is adjective, and so on, right? And then there were certain things which are always confusing. We didn't know what to do. So imagine an automated system doing that. So automated system taking a sentence and then automatically saying, oh, this particular first word is an adjective, second one is also an adjective, maybe third one is a noun, and so on. Okay? So it's called a part of speech tagging system. Has anyone used any part of speech tagging system? So I'm sure you guys have kids in schools. You could probably try one to solve one of the assignments of your kid. Okay? Yeah, it's fun and it's not very difficult to do. I'll show you a demo today and anyone can just do the demo very easily. Okay? So that's that. Then there are systems which build on top of part of speech tagging and are called as named entity recognition systems. Okay? So these are systems which try to figure out named entities. Now what are named entities? Objects, real world objects. So things like persons, organizations, locations. For example, Einstein met the UN officials in Princeton. So Einstein is a person, UN is an organization, United Nations, right? Princeton is a location, so on. Okay? So these systems are reasonably good. So these systems are like 90% accurate, and so on. So while there are these systems which are not very accurate, but they are interesting things that one can do with language. Okay? So for example, sentiment analysis. So all of us sort of know this thing, right? Everyone has heard about sentiment analysis somewhere or other, right? Everyone has vaguely heard about it, right? So, and it can be used to automatically figure out ratings given a particular review text, right? Or it can be automatically used to figure out how good a product is faring when it is recently launched, right? If the company has recently launched a product, you might want to see what people are talking about the product. So essentially, are they happy with the product? They're not happy with the product? What aspects of the product they're happy with? They also do comparative analysis. So what is the feature compared to the competitor that people are happy with, and so on. So that all falls under the sentiment analysis bucket. Okay? So then there is an interesting task called as co-reference resolution. So this is really important when you want to really understand automatically a piece of text. Okay? So imagine you are reading some Harry Potter story. Okay? And there are many references like he, she, and it, and all those pronouns. Now sometimes it gets confusing as to, even for a human, as to what he is meant here, right? Basically which person is meant here. Okay? So imagine doing that task automatically. So automatically trying to figure out this pronoun refers to which person, which was mentioned earlier. Okay? So that's what is called as co-reference resolution. So for example, in this particular case, Carter told Mubarak he shouldn't run again, right? So now he could actually stand for Carter or for Mubarak. So, as humans we can figure out easily it stands for Mubarak, but for an automated system to figure that out is a little tricky. Okay? So that's called as co-reference resolution systems. Okay? Then the other one is word sense disambiguation. So word sense disambiguation is important, again, when you want to understand text and you want to sort of make use of this understanding somewhere. Okay? So for example, I need new batteries for my mouse. Now, what does mouse mean here? So of course you can go back to a dictionary. Dictionary will give you two senses for the word mouse. It's an equipment or it is an animal. Right? So which particular sense of the word is meant in a particular sentence is what is captured under word sense disambiguation. Okay? So where is word sense disambiguation useful? Any uses that one can think of such a system? If you have such a system, where can you use it? Okay, can you elaborate more, as in what can you do with it? So how good or how bad, that you can sort of probably decide based on sentiment somewhat, or by looking at the syntactic structure and so on. Oh, I see. Yeah. So that's a good use case. But here, I mean, when I say word sense disambiguation, right, it's not going to explain more. And what it is going to do is to really figure out senses that are available in a dictionary, and then figure out, which particular sense is being used here. So what you are trying to say is that if you can figure out some elaboration of that particular word, right, which is not the task here actually. So it's a little different. Yeah. Correcting your sentences in online help. Well, we'll come to online help. How do you correct the sentences using word sense? Yeah. But no, I mean here actually the interesting part is both mouse have the same spelling. So I mean it's again not going to be, so that's good that you're pointing out these related things. So it's still different from a spell corrector. Okay? So it's not going to be similar to a spelling correction because whether and whether will have different spellings. But here both the kinds of mouse have the same spelling, right? So now imagine reading a newspaper, right, where somebody says Gandhi went to Bangalore and made this speech. So now you want to figure out, I mean, so you want to figure out which Gandhi is meant here. Now it could be like Rahul Gandhi, it could be Sonia Gandhi, and so on. So I mean, of course, Gandhi does not exist in a dictionary, but you can then consider Wikipedia as your dictionary, right? And then try to disambiguate, which Gandhi is meant here. Okay? Now, if you can disambiguate that one, maybe you can give the user a functionality that while he is reading a web page, right? You can possibly say, if you basically want to know more about any of those things mentioned in this document, you can just right click and say, highlight Gandhi and right click, show me more insights. You can show a nice visualization there. Oh, Gandhi was born here and this and that. So in fact, a related app is a Google Now and Tap. Has anyone used Google Now and Tap? No? So it's a nice app where you can sort of download the app. If you download the app, right, and say you are discussing with your friend on WhatsApp about a recent movie, okay? You're discussing, let's go and watch this movie. Okay? So you have the movie name, Ae Dil Hai Mushkil. Okay? And now what happens is, if you long press the center button on your mobile, Android phones, right? So what it does is to capture whatever is being visible on your phone right now. And then what it does is to really take that particular entire content, figure out what is the most interesting entity there. So for example, the movie name is most interesting, And then it'll show you more insights about the movie. Oh, who is the cast, where it is being showcased right now. It will get data from bookmyshow.com and show you next time slot available where you can book the tickets and so on. So this is where these things could be useful, right? So essentially, if you can do word search disambiguation, if you can, suppose there were like 2 movies with the name "Ae Dil Hai Mushkil." Now you don't know which one is the right one, right? So figuring out the right one based on the context, if you can figure out the right one, then you can actually show timings for that movie and so on. Okay? So that's that. The next one is parsing. So parsing is a task where you basically take the sentence and try to figure out the entire grammar structure out of it. So in the sense, of course, the first level is part of speech tagging. So you basically figure out what are the parts of speech of each word in the sentence. But then you also try to figure out phrases. So hey, this and this word, the window, can be combined together to come up with a noun phrase, the window, right? Or from the window, can all 3 words can be combined to come up with a prepositional phrase and so on. Okay? So that's called as parsing. Okay? So the next two we already talked about, machine translation and information extraction. So these are all systems where there exists some of those commercial softwares, and you can sort of use them, but they are not like 100% accurate. So they work reasonably well, 70-80% accurate. And so for example, if information extraction systems were 100% accurate, they'll take your emails and automatically create calendar entries for you. They won't ask you, hey, can I create a calendar entry? Right? Because there's a chance that you'll do some errors while getting any of those fields. So that's that. So the last one are quite interesting. So, and these are really challenging problems to solve in general. Like there are some question answering platforms, for example, systems which are very good at a particular domain, but not in general. So what is a question answering platform? Anyone? What is a question answering platform? No, not that. Huh? No, not Apple Siri kind of things. No, not code. No, okay, yeah, I mean, not Apple, Siri, Cortana, Google Now kind of things. No, not chatbots, exactly. Those are all chatbots. The question answering platforms, I'm talking about Yahoo Answers, or I'm talking about Quora and OpenStack Exchange and things of that sort. Okay? So, I mean, if everything was solved by Google, nobody would really go and ask questions there, right? So they would essentially get answers directly. And I mean, just search, get answers. Nobody would ask questions there. For example, if you have a question of that kind, how effective is a particular medicine in reducing fever in patients with a particular kind of illness? So, if you just search on Google, especially such long queries, you will really not get good results. Okay? And that is why what you do is to really go to, any of those platforms, Quora or Stack Overflow, and ask those questions. Right? So, imagine an automated system automatically answering such things. So, in the sense, now, of course, nobody can, I mean, the system does not have knowledge, so it cannot create knowledge, but it can at least use knowledge which already exists. So say, for example, if somebody has answered a similar question, can it figure out a similar question and automatically show the answer that somebody has given there to the guy who is asking now? So such a system, now, there exist some systems, there are efforts in that direction, but they are not very effective still. Still, you depend on Yahoo Answers or on Quora and so on to really ask interesting questions. And just hope that some human would come, some guy would come and answer that question. Right? So then there are chatbots. Okay, so let me go to the last one since a lot of people talk about chatbots. Right? So there are these systems which are interactive in nature. Okay? The difference between question answering and these chatbots is that question answering systems are not interactive. You ask a question, somebody answers it. That's all. So chatbots are interactive in nature. So where is Citizen Kane playing in San Francisco tonight? Okay, so and then maybe this chatbot will go ahead and tell you where it is, and then also ask, do you want a ticket? And the conversation can go on. So in the sense, the guy can ask, can you please book a ticket for 2 for me, right? So and then this guy asks, what is your credit card number and so on. So conversation can go on. So those are chatbots. And of course, you have your, the current chatbots that we have are quite restrictive in their capabilities, right? So if you have used Siri or Cortana or Google Now, you can ask simple things like weather, or you can ask them to play a song or sing a song or tell a joke and so on. But that's it. They really cannot keep the conversation going, right? So it's very easy for you to just fool around with that, and then in 1 or 2 steps you can automatically figure out what are the limitations of these systems. Okay? So that's that. So the other 2 are paraphrasing. So remember, in colleges, we would basically copy assignments from one another, right? So one guy would solve the thing, other guys would just replace the variable names and then submit the stuff, right? So the teachers are also not very competent, so they would not recognize it very well. or they anyway knew that you're copying, so they didn't bother to do any detection, right? Plagiarism detection, anything of that kind. But now imagine a system which sort of looks at a sentence, XYZ acquired ABC yesterday, and then says that, well, there is another sentence, ABC has been taken over by XYZ, and says, oh, by the way, both of them mean the same thing. Okay? So basically saying that in a class of 50 people, if I ask you to write an essay on Independence Day, right, and if all of you write similar things, right, they may not exactly have the same words. In fact, the words could be different. So acquired actually also means has been taken over, right? So the words could be different, but if it is exactly the same in meaning, I could figure that out using paraphrase detection systems. So paraphrase detection is that task. So given two sentences, automatically figuring out if they mean the same thing or they entail the same thing. Okay? So that's that. And the last one is summarization. So of course, there are many summarization systems. In fact, there used to exist one in Word also. So Microsoft Word had a summarization system. So given a large document, just summarize it for me. Right, so where you could really specify, oh, summarize in 10 sentences, in 50 sentences, and so on. Okay? But these systems are pretty limited. Okay? They do what is called as extractive summarization. Okay? The kind of thing that the teacher would tell you not to do. Okay? So if you remember going back to school, when teacher would ask you, here is a bunch of paragraphs, summarize them, right? The teacher would tell you, don't copy words and sentences. You have to understand the meaning and then write it in your own words. Right? If you remember from those days. So, but the current systems can only do extractive summarization. So they basically look at sentences, figure out which of them are important, okay? And then they just put out those sentences. Okay? Of course, there is a little bit of more intelligence in it, in the sense those sentences should be coherent and so on. Okay? And there should be some linkage between the sentences that you output and so on. But there's still extractive summarization. Okay? But what would be very nice to do is something called as abstractive summarization. In the sense, understand the meaning and then write it in your own words in short. So for example, in this case, the Dow Jones is up, the S&P 500 jumped, housing prices rose. All of this really means that the economy is doing good. Okay? So now this one really requires an automated system to understand what it means behind all of these things and then conclude that, well, the economy is doing good is the shortest summary that I can provide, a very nice abstractive summary. So overall, this is what is studied under the umbrella of natural language processing. So essentially, if somebody says they're building a natural language processing system, practically they must be touching one of those tasks. Okay? So besides those, there are also other tasks, okay, which are related to natural language processing. Okay? We will not go over all of them, but one comment that I have is natural language processing tasks don't just relate to text. They could also relate to images and also to speech. So for example, if I go outside and take a picture and then tell you that, hey, give me all the names of the shops that I can see outside, right? Give me a text file which contains all those names. So now that is also a natural language processing system. You have taken a natural language which exists on those images, all the shop names, right? Maybe done a OCR, optical character recognition, and then gotten the inside, the names of the shops. So that's that. Similarly, speech recognition is also a related system. So where you take input in the form of speech, and then output the transcribed text. Okay? So all of those are also interesting systems, but for today we'll just stick to text-based natural language processing systems. Okay, any questions so far? So it depends. So of course the tools exist to handle various kinds of things, but the way you use the tool is important. So for example, CT scan and MRI scan or even eye scans, right? If they don't have text, then it is not applicable, right? So it's basically understanding something from the images is a separate thing then. So it's basically then image processing or computer vision people guys do. Right? So if it contains text, then it pertains to natural language. Does that make sense? Okay. So now why is processing, so now we talked a lot about various applications of natural language processing systems, right? So now we need to really go into a little depth, right? And sort of understand, if somebody asked us to build one such system, what is it that we need to know at least, right? So this slide just captures what are the challenges in building such systems. Okay? So also before going into those challenges, one thing to note is natural language is the language that we use. English, Hindi, Marathi are all natural languages, right? Or Telugu and so on, right? Versus formal language, which is the code that we write, right? For example, C, C#, Python, Java are also languages, but they are formal languages, right? And the biggest difference is that formal languages follow a particular code. They have a rule set, right? And they have a limited set of keywords and so on. So basically, you can easily find patterns in a formal language, right? But in a natural language, by the definition, if there are rules, then it will be like a robotic or a formal language, right? So therefore, there must be things that break rules. Right? So there must be things, that make it natural, really. Right? So and that is the problem when dealing with natural language. So if there are things that break rules, they cause issues when you're building systems on top of it. So and these are the various challenges that sort of break rules. So for example, when you are writing a for loop in C, for I is equal to 0, I is less than 10, I plus plus, it means the same thing. I mean, it cannot have two different meanings. It has just one meaning, that I is a variable. You have to go from 0 to 10, or 0 to 9 if it's less than 10. But language is often ambiguous, right? Natural language is often ambiguous. For example, read these and read it from a mindset of trying to figure out other meaning, right? So teacher strikes idle kids. Okay? So this guy is doing nothing and strike. Okay? Or I could also read it as teacher strikes idle kids. So teachers are on strike and therefore kids are idle. They are doing nothing. So let's take another one. So hospitals are sued by 7-foot doctors. Okay? So it's not the doctors are 7 foot. It's just that they work on foot-related diseases. Okay? So I mean, the way you read it conveys a different meaning. Right? So essentially, there is ambiguity in natural language, which causes issues when you are trying to do various kinds of tasks on top of them. Then there is also this concept of non-standard English, right? So not always when we write English, we mean English, we write English, right? So essentially, so of course news articles contain English, but if you look at the SMSs that you send or the tweets that you write, they are not English, right? They are the semi-English. They are often code mixed, so to say. Many times they contain Hindi and English, or Telugu and English, or in other countries Spanish and English, and so on. Okay? So and many times they have various kinds of short forms like you taught us to, and so on. Okay? And of course emoticons, right? So but when it comes to natural language processing tasks, now imagine doing sentiment analysis on top of tweets, right? So which is a natural language processing task. It's challenging. Why? Because now you really need to figure out what this symbol means, right? So the symbol has some meaning, and and now there are so many smileys that you want to sort of decode those smileys, convert them to actual natural language text, and then figure out, oh, there is a positive sentiment here, or there's a negative sentiment here, and so on. Okay? So then the next one is segmentation issues. So when processing any natural language piece, right, you have to work at the word level. You need to extract words out of the text. Okay? Now, and that is called as usually segmentation or tokenization. Okay? So in English, the usual thing is that you just look for word separators in terms of spaces. If there is a space, you separate and get a new word. Okay? But the problem is that apostrophes and hyphens are culprits in English. Okay? So basically, these guys cause a lot of problems. So for example, look at this particular phase, the New York-New Haven Railroad. Okay? So now, the right segmentation is here, not this one. So basically, you don't want to keep New and York separately. But what happens, I mean, if you just look for spaces, then this is what happens, the first one. So therefore, I mean, which is another challenge. So it's not just with English. In fact, in English, it is much easier to do segmentation. For other languages, it is much more complicated. Okay? So, and we will look at that later. So then there are idioms in a natural language. There are no idioms in a formal language. So in a formal language, if there is a higher level construct, it sort of uses the lower level basic constructs, right? So, but in a natural language, there are things which are composed of words, but they don't mean the words that are contained in them. Okay? For example, throwing in the towel doesn't mean throwing in the towel. It means giving up, right? So if you paid attention to idioms in school, again, you would sort of appreciate that idioms are things which are beyond the words that are used inside them. So how to understand them and process them, especially again for sentiment analysis kind of thing. So if you are depending on words for analyzing whether the sentiment positive or negative, then would you call this thing as negative sentiment? You would not. Throw in the towel has no negative word in it. But it's a highly negative thing because you are giving up. So it's basically negative sentiment stuff. Okay? So then there are neologisms. So in a formal language, when a language is defined, you have set of keywords associated with it. Right? But natural language, it just evolves over time. New words keep coming in the language as the language evolves. So then word knowledge. So in a formal language, when you write something, it basically means exactly what is written, and there is no other knowledge required. Okay? So for example, if your Java code is compiling, it must be correct. Okay? It is just perfectly doing fine. Okay? But in a natural language, right, there might be sentences which are perfectly okay with respect to part of speech tagging and so on. Okay, I mean, if you want to compile an English sentence or figure out whether it is written correctly or not, you would look for English grammar. I mean, well, these verbs go together. These, look for part of speech tags and so on. Okay? But there could be sentences which are perfectly grammatically correct but make no sense in the real world. So, for example, Mary and Sue are sisters of each other is perfectly okay. But Mary and Sue are mothers of each other is not okay. I mean, although it makes perfect sense from a syntactical perspective, right? From English grammar perspective, it's completely okay. Mary and Sue are mothers of each other, so it's fine. I mean, there's a noun phrase, there's a combination, and so on. Subject, verb, object, all are in place, right? But based on the world knowledge, we know that it doesn't make sense. That's another challenge, that when you're doing NLP, you have to also incorporate world knowledge somehow. So there must be some knowledge base which you should include so as to understand that these facts are possible and these particular combinations are not possible. And then the last one is tricky entity names. Okay? So for example, if this was not italicized, right? If I had just written it as "where is a bug's life playing," what would you get out of it? Nothing, right? I mean, who knows? I mean, what do you mean by a bug's life, right? So, but if I italicize it right, it sort of means, oh, it is probably some play or a song or something like that. A bug's life is probably some entity name. Okay? So these tricky entity names make it very difficult to parse this language and try to figure out, oh, what it means here. Okay? So, a similar example I can give you about the same app that I described, right? So let's recall this app on the phone, which sort of looks at your current thing on the phone, tries to figure out the most prominent entity. So remember I told you about WhatsApp example, and there is a movie name there and it turns up at the top. Right? So now we were doing this and we're building this kind of app, and what happened was now two guys are talking to each other, right? There's a guy named, let's give some name. What's your name? Rajesh, okay? There's a guy named Rajesh who's talking to Shahrukh, okay? There's a guy named Shahrukh, and they're talking to each other. Now what happens is, now Shahrukh is Shahrukh Khan. I mean, the point is that the system automatically tries to figure out and sees Shahrukh mentioned many times, because Rajesh said something, Shahrukh said something, and so on, okay? And then it just triggers for Shahrukh, saying, oh, Shahrukh must be the most important entity, and then links it to Shahrukh Khan. Now that's problem, because there are tricky entity names around. Okay? Similarly, imagine somebody talking about the movie called The. Now there is a movie name. Now, how do you even figure out that they're talking about that movie? I mean, it's so difficult to figure out that there is a movie name based on whatever is written automatically. Right? So these tricky entity names cause a lot of issues when you want to do automated stuff on top of these, on top of this text. Okay. So that said, are there any questions so far? Any questions? Any discussions? No? If not, then we'll get to some little serious stuff. Okay? So most of these steps you have to do for all such applications. And then, of course, you have to build rules on top of your specific application. Okay? So that's the thing. Okay? So we'll go one by one. So we'll start with tokenization. Okay? So as simple a task as figuring out words in a paragraph. Okay? You're given a paragraph, give me all the words in the paragraph. Now it's a very simple task for humans, right? And just look at various words, and I mean, or even automatically, if I ask you to write code, you will basically try to figure out wherever there is a space, right? and tokenize it, right? But as I mentioned, these apostrophes and these hyphens are the big issue. For example, Finland's capital. Now, if I ask you how many words are there, you will probably say Finland, Finlands. You can write it like Finland's capital and so on. This apostrophe is not a big problem, but these apostrophes are a problem. So what are is two words, not one word. So similarly, I am, isn't, is not, right? These are all two words rather than a single word. So when you have apostrophes, you need to be careful. You need to figure out whether this is a two-word apostrophe, or automatically figure out that I would or I am, all of them expand to two words rather than a single word. Now with the hyphens, there are multiple issues. Like many times these hyphens are used to combine two words which never go separately. They must go together. Hewlett-Packard. Okay? Now you cannot get rid of that hyphen and then just write Hewlett space Packard. So essentially they are not two words. It's just one single word. Okay? But many times it's okay to remove the hyphens, like state of the art, right? State of the art, even if you store that as 4 different tokens or consider 4 different words, it's completely okay. And many times these hyphens just happen to exist because of formatting issues. Like at the end of a line or at the end of a page, these hyphens exist and you must remove them so as to get the entire word. Okay? So that's that. Now the last case is when the spaces are also ambiguous. So in the sense, lowercase is in general a single word. But many times there are these compound words which you want to split and store as lower space case. So there's not just one word, there are actually two words in it. Okay? And oftentimes it is important to do so. So for example, you are analyzing tweets about demonetization, okay? And you want to figure out public sentiment about demonetization in Hyderabad. Okay? How would you do that? So any ideas if you want to figure out public sentiment about demonetization in Hyderabad? Yeah, survey is a way where you can take 100 forms, right, and go to Gachibowli, stand there, ask them, and I'll take one form here. I don't want to get all the forms filled here because you guys represent a specific type of population, right? So if you have to do a survey, it must be random survey. So it must be done on road, on places like this, in hospitals, in offices, in wherever, right? So that's one way of doing it. What is the other way? From Twitter. Yeah, we'll come back to that. Huh? Adjectives, so where to get the data to analyze the adjectives? That's right. So basically sentiment is carried in adjectives mostly. That's right. But the data you can get from social media, right? So you can basically look at all tweets originating from Hyderabad, right? And it's not very difficult to do that because users put their location on Twitter profiles or they have GPS enabled mobile through which they tweet and so on. There are all the tweets which originate from Hyderabad and have demonetization in it. Okay? So now some of the tweets can contain #hate Modi. Okay, so so now and of course that's and demonetization also in it, right? So now if it basically says #hate Modi, now it's a single word hate Modi. Okay, now hate Modi is not a word in your dictionary. You don't know if it's positive or negative. But of course, if you can break that word hate and Modi separately, you can figure out, oh man, this guy does not like demonetization. It's a negative sentiment tweet. So basically, it is for these reasons that you need to really split these compound words many times. Okay? Hashtags or otherwise such compound words. You can't just store them as a single word and just be okay doing various NLP tasks. Okay? You have to split them so as to be able to get those basic words and then make NLP sense out of it. Okay? So that's that. So similarly, there are words like San Francisco, where there is a space, but really you don't want a space, right? I mean, you don't want to store San separately and Francisco separately. They don't mean anything without each other, right? So they have to be as a single token in that sense. Right? And lastly, there are these acronyms. So miles per hour, PhD, where you might want to store only the acronym part, but for some applications, you might also want the full form of it. Especially for sentiment analysis, you have a lot of slang which is written in acronyms form. Right? You might want to expand and then get the sentiment carrying words out of it. Okay. So in English, things are reasonably easy. Spaces usually work nicely. Okay? And we know that we have to deal with hyphens and apostrophes somewhat. Okay? But in other languages, life becomes more difficult. For example, in German, noun compounds are often written together. Anyone knows German here? German? No German? Then I know German, right? so basically, I know some things, I don't know German. But anyway, okay? So German noun compounds are not segmented. So for example, if one has to write life insurance company employee, the way it is written in German is this big string without any spaces. Okay? So but if you have to support any kind of application, any NLP application on top of it, you must get these four things separately out of that word, right? Out of that long thing. Therefore, in such languages, compound splitter is a real must. So you really need to figure out how to really divide this particular long thing into 4 different chunks. Okay? So far, life is good, but it becomes difficult with other languages. Okay? So like Chinese and Japanese. Okay? So in Chinese, there are no spaces at all. Okay? So people don't write spaces. Okay? So basically, a Chinese paragraph would look something like that. There are no spaces at all unless there's a comma or a semicolon or something of that sort, after which you will find a space somewhere after the full stops and so on or comma, but otherwise there is no space at all. Okay? So now, our first task, I mean the first thing that one has to do, the smallest thing that one has to do any NLP is to get words, right? How do I get words in such a situation is a problem. Okay? And the interesting part is Japanese is even more complicated, where of course there are no spaces at all, and there could also be multiple variants of Japanese in the same sentence. Okay? So imagine writing Hindi, a Hindi sentence which consists of some part in Bhojpuri, some part in Rajasthani or Marwari and so on. Okay, so basically it's like a combination of various dialects or various variants of the language in the same sentence. Okay? So without spaces. Okay? And that makes it even more difficult to get words out of such things. Okay? So now imagine you have this problem. So essentially you have this kind of sentence which actually should be written like that. It actually should have been written with spaces like that, so that, and then it means Sharapova knowledge in US Southeastern Florida. Okay? But what you have is a sentence at the top. This is the thing that you have. So what do you do? I mean, if you were given this task of figuring out words, how would you figure out words? Any idea? Yeah, you have a dictionary, say for example, which lists all the words in the language. One by one. Right. So for example, you have this, right? And let's say in English, because we know English, right? So what would you do? You have this kind of thing, and you go to the dictionary. A closer word to this one. So what would be the closer word to this one? A T would be there in the dictionary, by the way. But yeah, but THE, okay? And then do what? Right, but then there is no search. I mean, essentially say you have, as I mentioned, tweets basically, right? And you have hashtags and you want to break them, right? So there is no search at all. So somebody has written in his tweet, demonetization is killing me, okay? #hate Modi, okay? Now what do you do with the, I mean, there's no search there, right? Okay? Okay? Right. Yeah, that's right. So basically, what do? You basically, and in general, so what you try to do was to start from the beginning. In general, oftentimes what makes sense is max match segmentation, in the sense that you start with the entire thing first. Okay? It doesn't exist in the dictionary, so you remove the last T, okay? And then you search for the entire thing. It doesn't make sense. You remove the last A, and then you are left with whatever you are left with, right? And then you search until you get a word. So the largest sized word that starts with T and is there in the dictionary is what you want to figure out. Okay? And then say if you have figured out THE, then you move your pointer or you go to C, okay? Or basically whatever is left is what you do the same thing with again. Okay? You start doing that again with the remaining part. Okay? That's called max match segmentation algorithm. Okay? It's a very simple algorithm. You basically just try to figure out the maximum match in the dictionary. Okay? So this gives you this thing. Okay? But it turns out it may not always work. So for example, the table, this thing, right? I mean, what would you want to read out of it? The table down there. Right? So that's one possibility, right? But if you do the max match segmentation, right? I mean, of course, if you do what he said, I mean, you start with the smallest one, you would probably get that, right? But the smallest one will also have its own issues. Okay? So I'm showing an issue with the largest one. Okay? So then, what would happen if you start with the max match segmentation kind of thing? Anyone? The tab is a word? I don't know. Theta is a word. The tab, I don't know if there's a word. Okay? So this is what happens. Okay? So now, I mean, you get something, but it doesn't make much sense. Okay? So now the question is this. Now what do? You have two things, right? And which are syntactically correct splits of the original word. Okay? What do? How do you choose the right one? Yeah, it could be based on the context. So for example, if a lot of tweets were also referring to Modi somewhere here and there, you would basically say, okay, #hate Modi. Basically, if you're splitting it into hate and Modi, that sounds more correct because it is talking about, I mean, the tweet has Modi somewhere or the user has used Modi in some previous tweet and so on. So another way of doing the same thing is something called as n-gram models. Okay, so let's not go by what it is called, but let's go by how it is used. Okay, so what you do is to really take like a in a offline setup or in a somewhere in the background, you take last 1 year Times of India corpus. Okay, so in NLP literature, corpus is a set of documents. So last 1 year's Times of India articles. Okay, and then you figure out how many times a phrase occurs as is. Right. So for example, Narendra Modi will occur many times. Okay, but Narendra Mittal may not occur many times. Okay, I'm sorry if one of you is Narendra Mittal, but yeah, I just made up some name. Okay. So basically saying certain two-word combinations are going to be much more frequent, okay? But most of the two-word combinations are not frequent, okay? So for example here, the table, down there are going to be much more frequent than theta, bled, on there, okay? So and that tells you that the probability or the possibility of seeing this in usual English is much more than probability of seeing this stuff, okay? So based on this probability computations, you can basically choose the best one out of various possibilities. Okay, make sense? Yeah. I mean, you can. So I mentioned 1 year of Times of India articles, but you could essentially crawl, or by crawl I mean just download n number of web pages, English web pages. Oh, there's usually not a tie. I mean, yeah, if there's a tie, then basically you can't do much. I mean, if there's a tie, it basically means both are equally probable. So there is nothing much that you can do. Unless you have some context. If you have some context, you can resolve it based on the context. So if you have a tie, you randomly choose, that's all. You can't do anything. If you can't do anything, you can't do anything. So if you have a context, sure, you can break the tie using the context. You can choose the first one. Yeah, randomly choose one, or you can choose first one, which is also random, but anyway. It's not. I mean, usually nobody calls a crawler as an NLP tool. Crawler is a crawler. Yeah, but I mean, it doesn't give any insights. It basically just downloads the pages, right? So that's just like a software. It doesn't give any insight out of what it crawled. You could, okay, so how do you come up with two options? That's a very nice question. Okay? So basically, to come up with multiple options, what you do is to search for all possible words that start with T, okay, and fit here. So it could be the, it could be theta, it could be whatever. And then say you have two words which start with T, right, the and theta. So then you expand more on that. So after that, what are the words that are possible? So you come up with all possible things, right? So rather than using min or the math that I was talking about, you use all, right? And then come up with all combinations. Okay, so this doesn't work nicely in English, but of course you can, as I mentioned, you can use probabilities learned from a large collection of documents to be able to figure out which one is correct. It doesn't work in English just by itself. Okay? But interestingly, the way people write Chinese, they have evolved such that there is no prefixes. The Chinese is a prefix-free language, okay? Which basically are reasonably prefix-free. What does that mean? That basically means that one word is not a prefix of the other word. So everyone understands prefix. What is a prefix? So so for example, the is a prefix of theta. In a sense, if a word starts with another word, it's basically called a prefix. Yeah? So in Chinese, it turns out that there are not many prefixes, which basically makes sure that this kind of algorithm, a simple algorithm as that, works reasonably well for tokenizing Chinese sentences. Okay. So that's that. So now the next step. So essentially, we have done tokenization. Nice. We have gotten the words. Okay? But many times words exist in various forms. Okay? So for example, USA is the same as U dot S dot A dot is the same as America is the same as United States of America. All of those mean the same thing essentially. Okay? So normalization is the process of normalizing terms. Okay? So basically, for information retrieval or even for search engines, right? If you're searching for USA, right? You also want a page which basically has U dot S dot A dot, right? It contains what you are looking for. Okay? So therefore, you must take care of doing those kind of things. So essentially, if somebody is searching for USA, it should just be able to match U dot S dot A dot. Okay? then we implicitly define, so basically to solve that problem, what we can do is just delete whatever periods or whatever these dots we see, right? So as an alternative, sometimes what we also need to do is to do asymmetric expansion. Okay, so before going into that, what happens is, if somebody is searching for u dot, s dot, a dot, still they should be shown a page with USA. So the both ways it is equivalent. If somebody says USA, it means u dot, s dot, a dot also. And if somebody says u dot, s dot, a dot, it also means USA. Okay? But not for everything. Okay? For certain things, this relationship is asymmetric. Okay? What does that mean? So let's take an example. Okay? If somebody is searching for window, okay, just window. So it's okay to show window as well as windows. Okay? Somebody is searching for Windows, then it's okay to show, of course, the Microsoft Windows and somebody to fix Windows or buy new Windows for a house and so on. But if somebody is searching for capital Windows, it's really, really bad to show a web page which the furniture Windows. Okay? Because if somebody has written a capital W, they mean Microsoft Windows there. Okay? So therefore, certain expansions or certain alternative expressions hold one way, but not the other way around. So they are asymmetric in nature. So therefore, when you're doing normalization, you must make sure that you are doing it in a nice way. So that's that. The next part is case folding. So many times, so when you are doing this text processing, right, people will tell you that, well, lowercase everything because cases cause an issue. So many times you don't want to really make any difference based on the case. Okay? So which helps in making sure that you can sort of correlate things that mean the same thing. Okay? Since users tend to use lowercase. So if you are searching for something, say for example, you're searching for International Institute of Technology, Hyderabad. Right? First of all, nobody writes that big thing. They will probably type only IIIT Hyderabad. But even if they type International Institute of Technology, they are not going to type I capital, and then T capital, and so on. So most of the times, queries are all in small letters, right? Small characters. Okay? So therefore, many times what people do, as a rule of thumb, whenever some text comes to you, you usually lowercase everything. But that fails in certain cases. So in some cases, if you are searching, so when do you write capital letters in your queries? Have you ever written capital letters in your queries? When do you write capital letters? In your query. So can you give me an example of a query where you have written capital letters? Yeah, when you're searching for some error, right, in your code or some error message, right, you basically copy paste stuff and then you have capital letters. But in general, when you have typed queries, have you used capital letters? Manually typed queries, have you ever used capital letters in your query? No? No? Have you searched for acronyms? So for example, so essentially, say if you are searching for General Motors, okay, just try searching for without any capital letters. Now, General Motors can mean anything, right? But General Motors with capital G and capital M means a company. Right? Similarly, if you are searching for SAIL, Steel Authority of India Limited, right? I mean, if you so there are certain cases when you are dealing with them. There are certain cases which you should not lowercase. So if all the characters in the word are in uppercase, it could mean an acronym, and if you lowercase, it could mean completely different, right? SAIL, Steel Authority of India Limited versus sailing a ship, right? So it could mean completely different things if you just lowercase things. So when you do case folding or lowercasing things, it's important for certain applications, but you should be cautious when doing that, is the point. Okay? So in fact, for certain cases like sentiment analysis or machine translation, case is actually very important. So for example, US versus us, right? If you just lowercase things, the USA will not remain USA, it will become us. So that's the thing. So the next interesting, so these are all tools that you sort of need to know if you build any natural language processing system, because they help simplify your text. They help simplify and help you understand or extract meaning out of your text. Okay? So this one is called lemmatization. So has anyone done lemmatization? Knows what is lemmatization? Okay. So in language, there are so many interesting things, right? So consider any particular word, right? Say run. Okay. So there are various reasons why you transform this word. So for example, you make it running, you make it ran, right? And why do you do that? So why do you transform words? from their base form? Tense, basically, right? To reflect the tense is why you basically modify them. To make it a gerund or a verb, right? You modify things, right? To make it plural, you modify things. Cat to cats, dog to dogs, right? Why? What are the other reasons why you modify words? Good, better, best, weak, weaker, right? And so on. So basically for degree or intensity, you modify words. What else? For making the antonym, right? So important, unimportant, you modify the word. So you modify words for a variety of reasons, right? So for example, authority can be modified as, not authority, but authorize, authorization, authorized, authorizing. All of them are forms of the same word. Now, when you are doing search, right, say if you search for something like form to authorize my wife as whatever, okay. So now, if there exists some document which says authorization form, do you want it to match or not? Of course, you want to match in the sense that if you're searching for some authorization thing, you do want to match that authorizing with authorization. Okay? So therefore, many times it makes sense to lematize things and to bring them to their base form. So lemmatization is the process of removing these inflections or variant forms, okay, to the base form. Okay. So for example, this is what a lemmatizer would do. So it is like a piece of code which will take various words and then get to their root form. Okay. So for example, the boys' cars at different colors will become something of that kind. But interestingly, one nice thing about lemmatization, it always tries to find the dictionary word. So in the sense, it will basically convert cars to car and so on. Whatever it does, the final word should be present in a dictionary. So that's the nice part about a lemmatizer. So now lemmatizer is good on search. So for example, for search-based applications, it is very important to have a lemmatizer so that things that should match will match because they have a matching base form. Okay? But in some cases, it is bad to use lemmatizer. So for example, for cases where these where these changes, or basically where these inflections as they are called, are important. So for example, while doing machine translation, so in Spanish the word quiero means I want, quieres means you want, querer means want. So if you lemmatize them, they will all become queer, and then they will lose their inflectional meaning. So they will basically, this particular variation happens because you want it to say I want. So therefore, if you do lemmatization when you are doing machine translation, that's bad. But if you are doing lemmatization while you are doing, say, matching or web search or any search in your large collection of documents, it's good. Okay. Make sense? So that's called lemmatization. Okay. So the next one is stemming. Now stemming is very similar to lemmatization, but stemming is actually very crude. In the sense, it basically just takes a word and then chops off the last few things. So for example, if I asked you to lemmatize things, what would you do? You would basically take running and then remove ing for most of the things. Right? The simple rule is remove ing from the end and you will get the base form of a word. Right? It's a very simple rule. Right? As you mentioned, ed, right? Remove that ed from the end and you will get the base word. Okay? So for example, automates, automatic, automation will all reduce to automat. So it's basically just going to chop off last few. Okay? So this thing would become that if you sort of run a stemmer on top of it. Okay? So the nice part is that you do want to do stemming for large words so that things can match, so that your query can actually match to a relevant document. Okay? But then the problem here with stemming is that you may not always end up with a word which exists in the dictionary. So that is a little bit of a problem, because you cannot really then give out the stemmer output to users. If you want to build a system which uses a stemmer, you want to sort of output things by reverse mapping them. Okay, so basically saying in a lemmatizer, it's good in the sense that the output is human readable, because all the words exist in a dictionary, but not in case of a stemmer. Okay. Okay. So now how would you do stemming in general? I mean, any kind of interesting rules that you can sort of talk about to do stemming? So we already talked about ed, removing ed, right? What else can you do? Any other rules? Huh? Right. Yeah, so basically you can remove ER and then make weaker to weak and so on. So there's a guy called Porter, okay? He's a linguist, and what he did was to come up with a set of those rules to do these things. Okay? And then that algorithm is called as Porter's algorithm or Porter's stemmer, a very popular stemming algorithm. In fact, the most popular stemmer for English. Okay? So what it does is to come up with rules of this form. So it applies those rules one by one. So like caresses will become cares, cats will become cat, and so on. And then, you know, he suggested that let's not remove ing every time it occurs, okay? Because then king will become k, okay? And that's not what you want to do, okay? So therefore, what he said was to really remove ing only when there is a vowel in the remaining part of the word, okay? And that was a very good observation. So I don't know if you have observed this thing, that usually ing is added for words which have a vowel in them, okay? So that's that. And then there are other kinds of rules that he proposed. So basically like relational to relate and revival to revive and so on. Okay? So there are a series of these rules which are usually used to do stemming, and then whatever is left is basically called the stem of the word. Okay? So now, I mean, you would ask that why did he propose stripping out ing only when there is a vowel and so on. So what he did was to do an experiment. So of course, this is what is expected. Walking should become walk, but sing should not become s. It should remain sing. So he did an experiment. So he took Shakespeare's plays, right? So there are like around 30-35 Shakespeare's plays. He took all of them and then figured out all words that end in ing. Okay? And then he sorted them in a descending order. So in this sense, figured out top 10 words that end in ing. Okay? He looked at them and then he said that, well, so ignore that text, that's Linux script to figure that out. But anyway, you know, if you look at words, top 10 words which end in ing, right, he saw that if I remove ing, only 2 of them make some sense. If I remove, can help me get to the root form. So being to be and coming to com. Now come, but it's okay to even say com as a root stem form. Okay. So therefore, then he tried all sort of combinations, and then he said that, well, let me really look at only those which basically end in ing as well as have a vowel in the remaining part, and then sort them in descending order. And then he realized that, well, 7 out of 10 actually makes sense when I actually, remove ing. Okay? And that is how he came up with this rule. And that's how, he has designed all of those rules, which basically help us get to the root form of the word. Okay. So, stemmers are good, but they have their own issues. So in the sense that stemming is not really context sensitive. So for example, if I was, imagine a scenario where I was searching for Microsoft stock price, okay? And, the web search engine is using stemming, so it will stem stocks, Microsoft stocks price or Microsoft stock price, right? So it has stock. And let's imagine there is a web page on Flipkart, right, which is selling stockings. So now, interestingly, what this guy is going to do, what a stemmer is to really convert stockings to stock. And then it will match. Okay, it will basically say, oh, it talks about stock. Okay, and that is a really, really bad match. Right? I'm looking for stock's price, and it matches some stock, but it's not the stock that I want, and it's like stocking. So those are issues that can happen if you are doing stemming. So in a context insensitive way. So it's basically not able to take the context and then act accordingly. Okay? Well, lematizer does that. So lematizer, what it does is to really look at the context. So lematizer tries to look at the context, tries to understand why a particular variation occurs. So for example, consider a case about, say somebody is using the word saw, right? So if the word is used in the verb form, the lematizer will try to really figure out, oh, it is the verb form, therefore it should lematize to see. But if it is used in the noun form, the lematizer would really keep it as saw only. It will not really lematize and reduce it to any short form. But a stemmer would really just use the rule, remove the W or AW at the end, and then just always return an S. So that's how stemmer is more or less a dumb algorithm, but it's useful for longer words. But lematizer is much more intelligent, but then it is also more complicated to write. Because lematizer has to really depend on context analysis. It has to look at the context. It has to figure out what is the tense or what is the part of speech in which the particular word is used, and so on. Okay, so that's a lot of discussion. Any questions so far? Any questions? Has anyone done anything of that sort in lemmatizing, tokenization, anything like that? This is basically a demo hosted by Stanford University. Okay? And let's hope it is working now. And then you can type in whatever you like. So, so can you suggest some sentences? So I can type in, I am teaching at Avasa in Gachibowli. Okay. What else? So what is the time right now? It is 3:33 p.m. on 19th November 2016 right now. Okay. What else? Okay, we are in, oh, so maybe we can do some more thing, some more interesting thing. Okay, let me just put it as, yeah. So what do I put it in? We are in a hotel, okay, in Hyderabad, okay, in the, of course it is not USA, but I just want to tell you one of the things, and that is why I basically do that. Okay, so let's see what happens. So what this guy does is to really take that stuff and do a lot of natural language processing, as we talked about. Okay, some of the things we have talked about, some of the things we will talk about. Okay, so hopefully it will load some things soon. Yeah, still waiting, loading. Huh? Oh, I see. There's a lot of things going on this machine. Okay, yeah. So for folks who are doing it on their own machines, they can actually see some result, right? And it's a very nice result. If it comes up in 1 minute, it's good. Otherwise, I also have a slide. Okay. So where I have like copy pasted stuff, because at various places internet connection is a problem. Okay, since it didn't come up, I hope it will come up after we discuss this slide anyway. Okay, so here I tried something else. Now the only point is there a way for me to enlarge this thing? Ouch. There's no way to enlarge this stuff. So this was the original sentence. Where is the original sentence that we gave to it? This is the thing that we gave to it. Okay, I mean, let's not go to a real sentence because that's in large font. Okay. Okay. So this is what it does. So basically what it is going to do is to really figure out that there are 3 sentences in it first. Okay, so it does sentence segmentation. Okay. And then besides doing sentence segmentation, it also does tokenization. So it is going to figure out what are the words in it. Okay. So here I did not have any I am, I or I would kind of word, but if you put in that, it will also tokenize and figure out that there are multiple words of that kind. Okay. And then for each of those words, it also gives you a part of speech. So for example, here it has marked my name as a noun, okay, and NNP is a noun, a proper noun, right? And then is a verb, teaching is another verb, VBG is verb gerund, okay, and so on. So essentially, at is a preposition, IN is the code for preposition, Avasa is a noun, and so on. Okay? So this is the first thing it does. So part of speech tagging. Let's hope. This is just it has given up in fact. Okay. Yeah. Oh, no. Stop. Let's see. Yeah, we'll give it some time. If it comes up, great. Else I have slides anyway. So that's good. Okay. So besides the part of speech tagging, one other thing that it does, yeah, I know guys who have laptops are having fun, but for others it's a little bit of a problem. Just because I'm struggling with this guy here. Okay, so besides part of speech tagging, it also does named entity recognition. Okay, so what is meant by that? So essentially, it figured out that my name is a proper noun, but it also figured out that it is a person name. Okay? And then it figured out Avasa is a location, and then it also figured out that Hyderabad is a location. It also figured out 6:30 p.m. is a time. And yeah, 19th June. So that was an old example, so that's why we have 19th June. But anyway, that's a date. Okay? So it can figure out those things automatically. So imagine if you are given, say, you're working in a company and somebody asks you to really, take the entire wiki or all the collections of the company, and somebody tells you, get me all the names of the projects mentioned in these documents. So if you want to figure out all projects that have run in the company so far, this is a very nice application. So essentially, you can run such a tool to figure out project entities, okay, and then label them like that. So that's one. So then the other thing that this demo does is to really come up with this stuff called as co-reference resolution. Okay. So remember when I provided an example of co-reference resolution, what was the example? Carter told Mubarak that he shouldn't run again, right? So what does he refer to? Okay. The same thing is here. Essentially, when I have mentioned it basically figures out that it really means Avasa. Okay. So teaching at Avasa, and then Avasa is in Hyderabad. So basically that's the other thing it does, co-reference resolution. And then the last thing it also does is to figure out these basic dependencies. So now, which is a real lot interesting stuff. Okay? So here, these dependencies basically help you solve problems like subject, verb, object identification. Remember in schools, that is also another thing that you used to do. Okay? So it tries to figure out that teaching is the verb. Okay? And then N sub J dependency. So there are these dependencies are basically pairwise dependencies between words. So this N sub J dependency is basically going to tell you that this particular verb relates to this noun. So basically Gupta is the noun here. And then, of course, the compound dependency tells you that this word is not by itself. It basically is with the other word. Okay? And then there's another dependency which basically tells you that this is the object. So at Avasa. Okay? And so on. So essentially all these pairwise dependencies sort of tell you various aspects, say various syntactic aspects that one can discover from a sentence, from an English sentence. Okay, so that was the demo part. Now let's see. Okay, this thing also has come up. In fact, is there anything interesting I can show? Yeah, the interesting part that I can show here is as follows. So which was not there on the slides. Right, so the interesting part is here the u.s.a. So it did not really, so the nice part is it still figured out that there are 3 sentences, right? If the sentence splitting was done just based on the dot, it would have created many sentences, right? So, but it figured out that u.s.a is a part of a single sentence. Okay, that's that. And then what else? So basically, NER failed for some reason. Yeah, usually it does not fail. Mostly it is because of the internet connectivity or whatever. Others also failed because of internet connectivity problem. Anyway, okay. Yeah, there is nothing else nice to show here just because things failed reasonably. Anyway, so if you go back at home, you can just try Stanford Cone NLP demo and you will get that. And then, the description of all of these. So there are these tags. Now what are these tags? What do they stand for? You can really search for Penn tree bank part of speech tags and you will get their meaning. So basically PRP is a pronoun, VVP is some verb, so verb, past participle or something of that sort. I don't know exactly what, but it's a particular kind of a verb and so on. Okay? So just search for Penn tree bank. Penn is PNN. Penn tree bank. Yeah, I can search here, but I'm not sure if it will work. Yeah, Control T is itself not working. Oh, it's working. Okay, Penn tree bank. Yeah, let's give up. But basically. Now the problem is about for sentiment analysis. For sentiment analysis, there is no straight package. Well, there are tools. So there is a package called TM, so text mining package, which allows you to do all of those things that we talked today. Okay? Lemmatization, stemming, case folding, all of these can be done using text mining package. Sentiment analysis, you will have to build your own. Usually, there are some softwares for sentiment analysis, but there's nothing like a package in R to do that. Okay. So let us talk about the sentence. Yeah, go ahead. Yeah, that's a good question again. So now you are asking interesting questions. So basically, that's called as named entity recognition. Remember one of the tasks that we talked about in the beginning? So we talked about Einstein met the UN officials in something, right? So list-based approach or list lookup approach is one thing where you have a dictionary of all names and then maybe the name matches in the dictionary and that is why I put that as a person name. Right? But there are more approaches beyond that. So for example, if something is teaching, then that something must be a person. So by looking at the context words, I can try to figure out, oh, this is a person. Yeah, so maybe it has in dictionary my name, who knows. I mean, but anyway, yeah. So, but did you put that with capital, the first word? Okay, yeah. So sometimes it works, not always it works, but most of the times it does work. Okay? So maybe the name that you put in is not very common. So try putting in some common name. So in the sense, something that can exist in a dictionary. So, but anyway, so there are more approaches than beyond dictionary lookup. So many times it just takes words based on the context and tries to guess what is the thing. So what does it guess that thing as? So is there an entity that is marked at all? No entity is marked at all. So most of the times it works, sometimes it doesn't. Anyway, so now let's come to sentence segmentation. Sentence segmentation in general is a very simple task. Basically, so the task is you are given a paragraph, you want to figure out sentences. How would you do that? You have a paragraph, you want sentences out of it. What would you do? Full stops, right? You look for full stops. Well, you also look for exclamation marks and question marks, right? And exclamation marks and question marks are reasonably easy, right? They are unambiguous, but full stops are not always full stops, okay? So period is quite ambiguous. Sometimes it could be sentence boundary, and most of the times it is a sentence boundary, but sometimes it could be a part of an abbreviation like Dr., INC, and so on, okay? And sometimes it could also be a part of a number. Or it could be a part of that acronym, right? U dot S dot A dot. So not always do you want to really consider a full stop or a dot as a full stop, right? So therefore what you want to do is to build a binary classifier. How many of you know what is a classifier? Classifier? No classifier? Okay. Yeah, so then in that case what you do is to, a classifier is basically a machine learning model. So basically saying, you try to make some sort of rules into that model. So in the sense, what could be good rules to figure out if a particular dot is a full stop or not? Yeah, I mean the next word must be capital, must be starting with a capital letter. This particular word should not be starting with a capital letter. There should not be, space, yes, exactly. So if there is a number, then there will not be a space in general after the full stop. If there are new lines after the full stop, then it is like end of paragraph, which basically means it's also end of sentence and so on. So these are all various rules that you can encode in a binary classifier. But a classifier is nothing but a some sort of model based on these handwritten rules. There are all these rules: case of the word with or after the dot, length of the word with the dot. So if the word is like dr dot, right? So usually abbreviations are shorter, and so on. So you can all encode all of those rules and then build a nice sentence segmenter. Okay. Okay. So the next task, and I don't know what is the time. So based on the time, we will end at some point. So 3:48. Okay. So there's still some time. Okay. The next task is like phrase identification. So what is a phrase in general? Anyone can sort of define what is a phrase? Combination of words, but is every combination, which makes some meaning, exactly. So combination of words which makes meaning beyond those particular words by themselves, right? So for example, blood test is a phrase because blood and test have meaning, but when combined, it is a specific thing, right? So a concept is what you can call a phrase in some sense. So how would you find phrases? So basically, if I give you like a paragraph and I ask you, give me all phrases in this paragraph, how would you do that? Any ideas how would you find phrases in a paragraph? You must have a list of phrases. That's of course, if you have a list of phrases, you can do exact matches and then figure them out, right? So that's one way of doing it, but I mean, that's very difficult to build a list of phrases, right? Yeah, so we can basically start with one word and then say, oh, does the next word go with this word or not, right? So for example, one of the examples about blood test is that, after blood, whatever is the word, try to figure out, say based on, again, last 1 year of, say, Times of India corpus or collection of documents, try to figure out whenever blood was mentioned, how many times it was followed by test. If a large number of times blood and test occur together versus they occur individually, then it means that these two go together a lot of times, right? And in that case, you would put blood and test together, and then you go for the third word. Maybe the third word does not occur too many times with the blood test, and then therefore you ignore and then say, oh, my phrase ends there. Okay? So that's one way. Okay? And that's basically the third way, one of the ways that I have not mentioned here, but it is mostly about using something called as mutual information. So mutual information between two words. So the two words co-occur a lot together, they are called mutually co-occurring words. Okay? And there are other two approaches called as runs of words approach and sentence parsing approach. So what is the runs of words approach? The runs of words approach is very simple for phrasing. What do? You consider all runs of words between stop words. So English has some words which are called stop words. What are stop words? Anyone knows what are stop words? Stop words? No? So stop words are words which are sort of filler words. So like the, a, and, on, all those prepositions are all called stop words. Okay? So this particular approach is very simple. Consider all runs of words between stop words. So in the sense, just like for tokenization, you were using spaces as delimiters. Here, for phrasing, you would use these stop words as delimiters. Okay? So, for example, the previous slide, if I were to run a phrasing approach on top of it, this is what happens. So, is, to, as, makes, more, they are all stop words because they occur too many times in English, right? And anything that is separated by them is like a phrase. So, for example, indexing units is a good phrase, blood brother, blood test, bloodhound, adjacent words, index elements, they are all good phrases. Okay? Of course, you need to post-process this part, so in the sense after you get these phrases, you can remove those which are just length 1. So, like index is also marked as a phrase, but you can remove that, saying phrase should have at least 2 words. So this is a very simple and a very easy approach for phrasing. Okay? So and all it requires is a dictionary of these stop words. So and dictionary of stop words is very easy to get. I mean, take again last 1 year of Times of India corpus, right? And then figure out words that occur a lot of times. So like every article will contain a and the too many times, and therefore those are basically stop words. So if you apply stop words on some large corpuses, right, or on some large data sets, then this is what you get. So these are all interesting phrases if you look at, and in fact they contain a lot of locations which are 2-word locations. So remember that New York example which was screwed up because you were using space as a delimiter. Now if you have done nice phrasing, you would know that New York is a single thing; it goes together, and therefore you will not split it using a space. But keep it as a single indexing unit. Okay? So most of them make sense. There could be a few things which don't. So for example, example 1, table 1, they come up just because they're taken from US patents corpus. Right? But most of them actually make some reasonable sense. Okay? Now the other way to do phrasing is to really use a syntax or this kind of constituency parse tree. Okay? So remember on the very first slide when I was talking about various NLP tasks, I told you that you can also build a constituency parse tree or a syntax tree, right? English syntax tree. So for example, here the sentence is a dog bit the boy on the porch, right? So now for this sentence, of course, you can do first level parsing and then figure out, oh, they are these part of speech tags, article, noun, pronoun, and so on. And the second level, you can combine these to come up with phrases. Okay? So for example, the porch combines together to form a noun phrase. Okay? And then on the porch combine together to form a prepositional phrase, and so on. Okay? You can combine all of those, and that is how you can come up with this tree called as the constituency parse tree. Okay? So now, and of course there are softwares to do this. So essentially the same software that I showed you online, the Stanford Core NLP software, you can actually download it and you can run it on your sentences and also come up with trees of this kind. So the nice part is that once you have these trees, what you can do is to really look at these phrase nodes. Okay? So NP is a noun phrase, PP is a prepositional phrase, and then VP is a verb phrase, and so on. Okay? So you can just look at all the noun phrases, and then and then whatever are the words which correspond to that noun phrase can be called as a phrase. So for example, the porch is a phrase as per this particular parse tree. Now, of course, not all of them are reasonable phrases. Like the porch is not really something like a useful phrase, right? So therefore, what you could do is to really apply that mutual information thing on top of it. Does porch always come with the, or does the always come with porch only? No, right? I mean, the usually comes with many of them, and therefore clean up this one and say, oh, this doesn't look like a phrase. Okay? But all the candidate phrases you can get by really looking at these NP, PP, or VP nodes. Okay? That's another way of doing phrase detection. Okay, so yeah, we have looked at a variety of these tasks. So we started off with what is NLP, then we talked about what is sentence. I mean, how do you really take text and start processing it, right? So basically, find sentences from it, find phrases, find words from it, and then stem them or process them such that normalize them or lowercase them and so on. Okay? So since we have some more time, we will also look at word sense disambiguation. Okay? And this is actually going to be pretty interesting. So remember the example. So I want new batteries for my mouse, and the point is that you want to figure out which mouse. Okay? So how do you do that? So any ideas? How would you do that? So of course you have a dictionary, and what does a dictionary contain? A dictionary contains a set of all words, right? And for each word it contains meaning. So meaning such that it is written in simple English, right? Simpler English than the word, okay? And it has meaning of all the senses of that word. Right? So for example, consider this sentence: I am going to withdraw money from the bank. Okay? So now bank has at least two senses which is popular, right? One is the river bank, so everyone knows river bank, and the other is the finance institution, right? ICICI Bank. Okay? Huh? Yeah, these days people know only one bank, right? So yeah, I mean, in the sense that yeah, so this sentence I've been like talking for like 4 years, and nobody thought of it that way. I mean, that withdrawing money from a bank is such an important thing. But anyway, so in the recent situation, everybody knows only one bank. But anyway, the point is, coming back to the example, what we want to do is to really go back to the dictionary, look at the dictionary. It says bank has two meanings. One is the river bank, the other is the institution, financial institution bank. Okay. So, and we want to figure out what is the sense in which bank is used here. Essentially figure out which one is the right bank that applies here. Of course, the financial bank applies here, right? But we want to do it automatically. Okay? How do we do it automatically is the question, right? Yeah, the other words in a sentence, the context words, as you said, right? So money, what else? Yeah, withdraw and money, right? It could also draw water, but anyway, so withdraw is probably money related, and money is related to bank. The hope is that money and bank you will be able to make some relationship somewhere. So how would you make that relationship? Probably based on the description in the dictionary. So dictionary usually contains meaning for every sense of a particular word. It also contains sometimes example usages. So example sentences in which this particular sense can be used in. And some dictionaries have antonyms, synonyms. They also have something called as hypernyms and so on. Okay? So using those various kinds of words and comparing with the context, you can sort of say which particular sense is being used in this particular sentence. Okay? So yeah, let's skip this one. So we will talk about 3 approaches to do this stuff, right? And vaguely, which is based on what we just discussed. Okay? So for that, let's look at this example. So there is one example in which serves is used. This airline serves dinner in the evening flight. Okay? And then there is another example. So this airline serves the sector between Agra and Delhi. Okay? So both of the sentences use serves as the as the word. Okay? And in both cases, the word is a verb. In some cases, the particular word is a verb, some cases it is a noun, and so on. It is easy to disambiguate in that case. Right? But in both cases, it is a verb, right? But the senses are different, right? So all of us understand. Here it could be like serves dinner, or serves breakfast, meals, lunch, or whatever, right? Or food, and so on. But in this case, it serves the sector, or serves the region, or serves the area, and stuff of that sort would be the kind of things. So therefore, one way of doing this word sense disambiguation is to list down for every verb a set of possible objects for that verb. Okay? Say in the dictionary you also had set of all possible objects with which this verb goes. Okay? So the example in this case, this serves goes with any kind of foods, in the sense food, breakfast, meals, etc. Right? And this one, this serves goes with the sector or region and a few set of objects, right? So basically saying, if you can exhaustively enumerate the argument structure of the verb, in a sense, all the set of objects that this goes with, right? then you can use that to really do disambiguation easily, word sense disambiguation. Right? So when if you are now given a sentence like this flight serves a region between Mumbai and Delhi, you would say that, well, region is present in this particular sense of the verb serve, and therefore you would say that this serves is really this particular sense. Okay? So is that understood? So essentially, but the problem is for this one to work, you will have to come up with a dictionary which gives you a set of objects that go with this particular verb serves, okay, which is not very easy to do. It's basically a very time consuming thing. You'll have to list down a lot of things. So, but a better thing to do is to really look for context words. So let's in fact look at this example. On burning coal we get ash. Okay? And you want to figure out which particular sense of the verb of the word ash is being used. So you want to do word sense disambiguation for the word ash, right? So you go back to the dictionary and you figure out there are three senses in which the word ash could be used. Okay? In fact, ash is also the name of a tree. So particular type of tree, trees of the olive family with pinnate leaves, thin furrowed bark and grey branches are also called ash trees. Okay? So ash is also the solid residue which is left when you burn stuff. And then the third sense is the verb sense. So to convert something into ash is also called ash. Right? I mean, he ashed the tray or whatever, he ashed the papers and whatever. Right? So basically converting something to ash is also called ash. Yeah, absolutely. Ash can also be a name of an actress. That's pretty right? So in fact, there could be a fourth sense here. It's just that it doesn't exist in the dictionary. That's right? But yeah. It could also be the name of an actor, Aishwarya, right? But anyway, so the whole point is so whatever it is, right? And as we discussed, this has to do, this goes back to the other kind of problem when we are talking about Gandhi and so on. Okay? The same problem, when we are talking about common words, it's called as word sense disambiguation problem. But if we are talking about proper names, it's called as entity linking problem. Actually, the problem is the same. So you're right. I mean, in fact, usually people don't talk about common words and proper words together. I mean, so for example, usually in entity linking world, people will say Gandhi went to Bangalore and gave that speech. So now there the problem is to figure out which Gandhi. Is it Rahul Gandhi, is it Rajiv Gandhi, is it Sonia Gandhi, and so on. Okay? But here it's an interesting thing. I mean, if you really see this ash, it could be any of these three or fourth, an actress. Okay? And so on. Okay? So the point is that you have to figure out which of those senses is the right sense. Okay? There are three possibilities and you choose which one. So, and as we discussed, we look at the context. So in the context, what do we see? We see words like burning and coal. Okay? So now, if they are very clear, right? And if there's unique meaning to coal and burning, what we can do is to really figure out which of the sense has a nice overlap with the context. Okay? So basically, you find that this one says burned, right? And this one also is burning. So then, okay, it makes some sense, right? So basically, sense 2 is quite related, while sense 1 and sense 3 do not have anything like burning or anything like coal. Of course, we don't care about these stop words like on, be and get, because they are like filler words, they will match anywhere anyway, right? So we don't care about those words, but we care about important words and so on. So but then, I mean, what one can, so of course one can just consider this as a context and then match each of them, and then whichever has a good match is the one that wins. Okay? So in this case, sense 2 would win, because burn at least occurs here, and here there is burning. So if, again, you know, stemming is one thing that helps here. So burning is the same as burned, right? Because when you stem them, both of them become burned. So but what more can we do? So what we can do is to go back and look for senses of coal. So we go back to the dictionary, we see what all can coal mean. Okay? And then use it to really create something called as a context bag, in the sense that now our context is not as small as that, but our context is this entire thing plus the words in the same sentence. So which helps us to have a larger context. So now if we go back and sort of find a match with this context and this sense one, well, still there is not much match. I mean, if you will see, there is not much of the useful words which will match here. Okay? But if you go back, if you look for overlap between this sense 2 and this entire context, you see a lot of match. I mean, this solid which is here, combustible which is here, burn which is here, and so on. Again, if you look at the sense 3, it has hardly any match with the context, right? So basically, whatever matches the context is the one that wins, and in this case again, sense 2 is the one which will be used, right? Of course, if you have Aishwarya Rai here, then there would be words like Bollywood and stuff which do not match any of burning coal, and that's the reason why that will not match in this particular case. Yeah. Okay. So the last approach for word sense disambiguation is based on, or maybe the second law. So the next one is very simple. So I'll probably just call it second law. This is based on categories. So imagine a dictionary where you not just have words and their meanings, but also categories. So in the sense that bank has two meanings. One is the river bank, and the location from which you can withdraw money and so on. Right? And then with that, they also give a category. So this particular sense is used in the location sense. This particular word bank is used in the location sense, or this word is used in the finance sense, and so on. So imagine that all words are categorized into say 10 broad categories: finance, location, health, sports, and so on. Okay? So in that case, what you could do is to, so for example, now this is a sentence: the money in this bank fetches an interest of 8% per annum. Okay? So and you want to figure out what this bank means. Is it the location bank or is it the finance bank? Of course, it is the finance bank, but we want to figure out automatically. So what we would do is to really go back to dictionary. Dictionary says there are two senses: one the location sense and the finance sense. Okay? So therefore, we have two columns here, and then we look at all the words in the context: money, fetches, interest, any useful words around, right? And then go back to their dictionary representations. Right? Go back to the dictionary, figure out what all senses money is used in. Okay? So it turns out that money words one for finance. Money is never used in the location sense as such. Money might be used for other senses, but of these two, it is used in the finance sense. Similarly, other words are used, say annum is used in finance sense, interest in finance sense, and so on. So as you see, the context really votes more for the finance sense rather than for the location sense. And that is why, again, in this case, using this kind of categorical dictionary, you can really come up and say that, well, here bank is used in the finance sense. Yeah. Dictionary is easy to get. So essentially, all of us have dictionaries at home, right? So typical dictionaries also exist online. So you can basically just download a dictionary, say Webster-Merriam dictionary and so on. Connect it with the tool, exactly. Okay? So such dictionaries are available, but these kind of dictionaries where there is also this category mark is not very common. So but this is a good approach if you are using it for a limited domain. If you are using for a small domain, these words are only in that domain, say just in jobs domain or a very restricted domain, then you can actually build such a thing and use it. So last one is a very simple thing. So essentially, say if you have parallel corpora. So what is parallel corpora? So parallel corpora is a text which exists in two languages. Okay? So for example, parliament proceedings are available in various languages, various national languages, right? Of course, it is available in Hindi and English, but it is also available in various, I think 22 recognized Indian languages. Okay? So the same sentence is translated by someone in, so let's talk about just English and Hindi. So it's in English and also in Hindi. Okay? And say somewhere in the parliament somebody mentioned the money in this bank fetches an interest of 8% per annum. It will also be translated in Hindi. Okay? So now the nice part about word senses is that the same sense is never translated into the same word in another language. Okay? So for example, consider two senses of the word bank, right? In Hindi, for one you will use, probably in Hindi also it is called bank, right? For the other one you will use kinara, right? Nadi kinara. Okay? Right, for people, most of you hopefully understand Hindi, right? But anyway, in another language, you will basically translate it to a very different word. So if you have parallel corpus, so basically saying that with this sentence, if you also had its Hindi translation, it is very useful and it is very easy to then really figure out which sense is being used in the current context. Okay? So a word having multiple senses in one language will have distinct translations in another language based on the context in which it is used. So translations can therefore be used directly to figure out the right sense. Okay, so let me very quickly end with parsing. So we already talked about parsing, so it's not really a big deal now. Right? So parsing basically consists of two types of parsing. In the sense, you could create a parse tree of that form. So essentially, where a dog bit the boy on the porch, right? This is called as the constituency parse tree. So now you would ask, in which applications such parse trees are useful? Why would you build a parse tree? Any idea? How would you create some interesting application out of it? Any uses of parse trees? Right, but we are talking about a natural language right now, okay, so that's not really an application, huh? Why would you create a parse tree to transmit data? Traversing across that parse tree, but then what would you do based on that? Yeah, that's a nice one. So any other, we'll talk about that, but any other applications about a parse tree? Why would you want to build a parse tree? I'm not even asking you how would you build one. So how is a very difficult question to answer, but that's homework if you want to think about it. But what would you do if somebody tells you that, hey, give me any sentence, I'll give you a parse tree? What would you do with that? Can you use that to do anything useful? But part of speech you already have, you already have using part of speech taggers, right? You don't need to build an entire parse tree on top of it. Part of speech is just one level. Huh? It could help in sentiment analysis, this is one, right? So we also talked about phrasing, guys, a little while back, right? So it could also help you detect these phrases. What are the various phrases in this sentence? It could also help in sentiment analysis. And how? So the point is, usually a particular sentence can contain multiple sentiments. So for example, somebody would say the movie's plot was awesome, but the cast was not very nice, or another aspect was not very good, right? So the entire sentence does not have one sentiment, it has two sentiments in fact, right? And towards two different aspects. Now how do you figure out that there are two parts to the sentence? You can basically just do a parse tree, and then at some point you'll figure out there's a left part, there's a right part. Okay? And then if you do sentiment analysis, you can actually see that the left part has probably a positive sentiment, right part has a negative sentiment. And then you can say, oh, this sentence has two sentiments, and therefore it must contain two aspects, and therefore give different sentiments for each part. So that's where these things are useful. So essentially, say sentiment analysis is one example, but there are many other examples where parse trees could be really useful. So for example, if you are doing summarization and a real abstractive summarization, okay? So what is an abstractive summarization? You won't copy entire sentences, okay? But you will basically maybe copy parts of the sentences from here, part of the sentence from there, and so on, and then combine them nicely to form automatically generate sentences. Okay? So how would you do that? You do that by really figuring out, proper units. So basically, you won't really take r.bit, but you would take this as a unit. So because this is a proper verb phrase, and then maybe a verb phrase can be combined with a noun phrase. That's what you know from English language, and that's where parse tree can be useful. So if you are doing abstractive summarization, you need to build a parse tree. Okay, so there are various uses where these things are useful, and then the other one we already talked about, dependency analysis, right? So if you want to really figure out subject, verb, object kind of thing. So for example, in this case, put is the verb, and who put the thing? The boy put the thing. Therefore, the boy is the subject, and therefore it has that n subject dependency, noun subject dependency. Okay? And what did the boy put? The boy put the tortoise. So the tortoise is the dominant object. So the object in the particular sentence. Okay? So where could this stuff will be useful? So this could be useful where you want to, say, figure out facts from a news article. So a fact is nothing but a subject, verb, and object. So a fact is basically who did what, right? And also for things like semantic role labeling. So there is another thing called a semantic role labeling where you want to figure out who did what in that sense. Right? So it's very useful for fact extraction from a large corpus. Okay? Say if somebody gave you, you went to a new country and you are a sales guy there, or you want to sell something in that country, right? And you want to figure out the political scene there. Okay? So say you don't know anything about that country. What could you do? So if you have access to, say, last 1 year newspapers in that country, you can run this tool, automatically figure out facts. Okay? And then figure out, oh, X did that to Y, and so on. And that could be really useful to quickly understand a large set of documents, or summarize a large set of documents. So that's that. So this is just more detailed analysis of dependency structure. So since dependencies are all binary in nature, so they relate different words. So they exist between two words, and they just describe the relationship between the type of relationship between two words. Right? So essentially, it has a head and a head, or also called as a governor, and a dependent. So all kinds of, so these dependencies are also useful to figure out whether a sentence is written in active voice or passive voice. Okay? So active voice sentences have n subject dependency, passive voice sentences will have n subject past dependency. So based on that dependency, you can figure out how many sentences are written in active voice, how many in passive voice. Okay? So that's that. So this one we already discussed already. So that is all. So that is pretty much the end of the lecture. So what we discussed today, hopefully now if somebody will ask you, do you know NLP? You can actually say, yes, I know somewhat about NLP, right? So we talked about what is NLP and what sort of tasks fall under this big umbrella. Okay? So we talked specifically about the basic modules that are required to build any big NLP system. So tokenization, normalization, stemming, sentence segmentation, so given a paragraph, figuring out all sentences, phrase identification, voices, disambiguation, and a little bit of parsing. Yeah, NLP is a large topic, so large area. So essentially, right, I mean, there are many books on NLP. So essentially, the next things that we could straight away discuss after this could be like how to do sentiment analysis or how to really do named entity recognition. Or things like how to do summarization and so on. Okay? So, but for this 2-hour stuff, this is all. Where it is related to analytics, so if you basically want to, so analytics is in various areas. So as I discussed, right, I think I can go back to the first slide. So if you want to analyze and figure out how many, what percent of the customer base is liking your product, right? How do you do it? So basically get the tweets and then figure out sentiment analysis on top of them, right? So that's basically a straight example, right? But now I think this slide will start making more sense. Now just go over those applications that are written there, right? And all of them really use some sort of natural language processing. Okay? So for example, let's look at that. A weird application where probably no one is working here, but operator comments analysis, okay? So let's say you have basically all the discussions between the pilot and the co-pilot and the ground staff is all recorded, right? And they're all transcribed using speech recognition systems. Now if a plane goes bad or if anything wrong happens with the flight, right, you can always go back to the recording and then do some sentiment analysis, figure out what was going on that caused the accident, or is there anything human that caused the accident and so on. So all that analysis can be done based on these things. So if there are, based on these chat logs, you can do a lot of analysis in that sense, right, in various applications. Social media analytics we already talked about, sentiment of customer interactions, user profiling in e-commerce and retail. By looking at what kind of queries you are putting in, more things can be personalized for you if you can do natural language processing on top of it and figure out, oh, this guy generally buys more of clothes on my portal rather than more of food articles and so on. So there are various such applications. What are good tools to start with? Okay, so the first one, right, what if there are spelling mistakes, right? So search engines usually are very good at correcting spelling mistakes. Why? Because they have learned from previous users. Small data set and then you have some spelling mistakes in it. Sure. I mean, if there are spelling mistakes and so there are tools which do automatic spell correction. Okay? Because and you can install them on your machine, and they make use of simple things like 2 characters on the typewriter or on the keyboard are more frequently interchanged. So those are the typical spelling mistakes. So the ways in which people make spelling mistakes, right? And then there are also tools which sort of encode how people make spelling mistakes when they spell difficult words like Mississippi or pneumonia and so on. And then they have those mappings internally saved in the model. So you can download them and make use of them in your work. Right? Now to the second question, like what are tools that you should start with for this kind of thing? In R, TM package is good. So just try to use TM package. Read its. Everyone knows R more or less vaguely. So do you know Vignette command? Vignette. So just look up what is Vignette. V-I-G-N-E-T-T-E. Yeah. So it basically gives you a help file for TM package. And then there are many examples which are written in that help file. So those examples can help you sort of go over those things. I mean, very nice examples which discuss what all you can do with TM package. Okay, so that's one. The other one is the Stanford Core NLP software that I showed you, the online demo. You can download it as a software, and then you can run it on as many documents as you like. Okay, so the demo does not show everything. This software also does sentiment analysis. The software builds parse trees, which we did not talk which we did not see in the demo. Huh? Brad. I don't know about the Brad part, but this is called Stanford Core NLP. Okay? So this is called Stanford Core NLP software. Oh, when I say usually document, it means a text document. It could be a PDF also, but you'll usually convert it to text before doing any text analysis. I mean, usually text file, TXT file, and so on. Okay. Any other quick questions? Sorry, I was probably not more attentive to this part of the class, but I don't know. I mean, that has something to do with the layout. It's probably not really a classroom layout, but anyway. Go ahead. Sure. So, I mean, it depends on what application you are talking about. So, there are various reasons why people switch context and various applications. So, for example, when writing a news story, I might talk about something and then switch to another topic and then maybe talk about the first topic again and so on. Okay? So, there are things called topic models, which try to figure out that the first paragraph was more towards, if it is say a cricket match commentary, right? So some part of the commentary can be like a player-specific commentary, like Sachin, and then suddenly in between I start talking about the actual match, and I go back to Sachin, right? So there are topic models which help us try to do those things. They're not very accurate. I would take it. Basically, they're not very accurate, but they do at least some part of the job. Okay? So a similar thing can occur when somebody is querying. So if you have two tasks in your mind, you usually, say for example, you are booking a flight from Hyderabad to Bangalore, right? And between your wife tells you, hey, go book a cylinder for me, gas cylinder, right? What do? You basically you're searching for a flight from Hyderabad to Bangalore, but before you complete that search, you start searching for another thing, right? So those are called as interleaved sessions, where, usually a session is a homogeneous task, but, just because you have too many things in your mind to do at the same time, you interleave in that sense. And there is enough work, there's no published software, but there are research papers on how to really remove this interleaving. So how to figure out, oh, this was one task that I used to doing, this is another task. And then say that, oh, this particular thing that looks interleaved is actually these two sessions. Okay? So there is good work, but there's no software as such there. Okay? Okay? Yeah. Okay. Yeah, that's a good question, right? So sarcasm detection, we did not talk about at all. But, and there are no good softwares to do it so far. And it's really very difficult to figure out sarcasm. Okay? Sarcasm, is interesting. There are two ways of doing sarcasm detection. One is context insensitive way, okay? In which case the sentence itself contains a sarcasm. Okay? And the other is a context sensitive way. In a sense, say if you basically, if the lecture was really, really bad, right? And you go out and then one guy says to the other, the lecture was superb, right? And that's so sarcastic in a sense, and that has to do with context, because both of them attended the lecture and they felt what they felt, right? And then then they understand that it's sarcastic. The third person would think probably it was really superb, right? So that's the thing, right? So there are some approaches to it. It's still in research. There are some good papers. There is some. So people have tried to use the Friends TV serial dialogues and figure out sarcastic comments from it, and then try to be able to nicely classify and say, oh, this is sarcastic, this is not, and so on. There is no published software. There is no software which will help you figure out sarcastic sentences. Although sarcasm plays a really huge role when it comes to sentiment analysis. So, usually you do sentiment analysis based on the words contained in the sentence, right? But, this is a very nice sentence from one of the perfumes magazine, So the sentence is, if this is your darling fragrance, then you better wear it only exclusively at home and take the windows shut. Okay? This is such a sarcastic sentence and it contains no negative words that you can say that this is a negative sentiment sentence. Okay? So, so sarcasm is really important when you do various NLP tasks, but it's difficult to solve too. So there are no good approaches to do it so far. No commercial softwares to do it so far. There are some research papers around. Any other questions? Any other quick questions? Yeah. So we do not talk about the efficiency aspects, but practically you have to do it. So in the sense you have to really look at every word, look at frequency and so on. Yeah. Right, absolutely. So, so the answer is that yes, you still need to. I mean, I know there has to be stuff done efficiently, but you still need to really look at dictionaries, the full dictionaries, and maintain those counts and so on. It's just that you have to really build algorithms which are faster, which really do all of these things really quickly. Okay. There's no standard dictionary. There can't be, because I mean, of course, there's a Merriam-Webster's dictionary, which is the standard dictionary that people use for English, right? But there can't be a standard dictionary because new words keep coming in. Okay, and as far as NLP is concerned, you just don't care about those words which exist in a dictionary. Right? So on average, in English dictionary, in Merriam-Webster's dictionary, there are like 2 lakh words, right? But there are many more on Wikipedia. Like Sachin Tendulkar is also a word which will not exist in a dictionary, but is a useful word. You need to care about it also. So then you build your dictionary using all Wikipedia titles. So you go to Wikipedia, you crawl everything, you dump everything, and then whatever the titles, you use those also as dictionary words. So you have to keep growing your dictionaries like this. There is no standard dictionary that one can use. Okay. Let me not talk about Microsoft here. It's not, I don't represent Microsoft here. Oh, that's a good question. So it's nice that you asked. So that I can talk about because there's some learning there, right? So, chatbots, right? I put it in the last bucket because it's not easy to do it in a generic way. Okay. So, in the sense that if you ask a chatbot, "Hello, how are you doing?" right? Of course, one way to really reply back in a chatty fashion. So, chatbots are of 2 kinds. One which really just engage you in conversations, right? In India, we have a lot of people to talk around to, and therefore we don't need a bot to talk to. But in US, people are usually very lonely. Okay, so they feel the need to talk to a chatbot also. Okay? But anyway, so one kind of chatbots are which just engage in conversations. That's all. It has to do nothing, and it's just gossip chatbot, you can call it, right? The second one is informational chatbots, where you basically give out some useful information. So informational chatbots are usually domain specific, right? But these chatty chatbots are, or the gossiping ones are the more interesting ones, right? And Tay was Microsoft's efforts towards that domain. So let's build a chatbot such that, you know, if you ask it, "How are you doing?" it will reply back, "Oh, I'm doing good. How are you?" Right? How has the day been, or how has the weekend been, and so on. Okay? So now, of course, the obvious thing is, how do you build such a chatbot? So one way to do it is to really gather all the Twitter conversations, right? So if somebody asks you on Twitter, "How are you?" right? What do? You reply back on Twitter saying, "I am doing good. How are you?" Okay? So those replies can actually be used to reply back. I mean, if somebody else also asks you, "How are you?" you learn that, well, you can answer back saying, "I am doing good," right? But the problem is that on Twitter, a lot of people say nasty things also in replying back, right? So, and then if you learn those nasty things, then you know, the chatbot also learns nasty things. So then it says nasty things, right? So, and that's what happened when Microsoft launched the Tay bot. Okay? People started asking nasty questions. So basically, they started asking things like, you know, what do you think about blacks versus whites in the USA, right? And then now, I mean, the nearest match on Twitter, you know, whatever you can get from Twitter is whatever you can get. I mean, it could contain all kinds of nasty things. And that's what Microsoft's chatbot would also say. Of course, it's not as simple as that, but I'm just simplifying for the sake of this conversation. Right? So, which causes issues. Then as Microsoft, you cannot put out stuff, nasty stuff, right? And therefore, Microsoft had to take back that bot. And that's why I mentioned that it is one of those things which is still in research, and there's no commercial software to do it generically. I mean, AI and NLP are practically similar things. So here it is more of NLP, more of natural language processing rather than artificial intelligence in it.
You have a brief high level overview of where this thing is going. NLP can be used for a wide variety of things. It is not that it is perfect, needs a lot of refinement. Simple things like color, and color can be a problem. People are trying to do it, improve it. However, bulk of the work is happening in the English language. So if you guys want to do something in your local language or something or local dialect, there is scope for a startup company right there. Question is, who's going to pay for it? That is obviously the end question, right? Now, having said that, today I actually did something interesting. I thought, let me send you something called text blob. So if you can open this website, I think what's his name, what Sukanya must have put it up for you guys today. Now you have to understand something, that remember I was telling you that there must have been somebody who must have tried to analyze information and words and so on. So these guys have made ready-made libraries. NLTK is Natural Language Kit, which has been developed by Stanford University, and they keep appending it from time to time. So if your NLTK kit is not running, it's not because of you. Somebody must have appended it at Stanford after doing some research. So you need to keep that in mind. Text blob is something similar. It's a little bit faster than NLTK because it doesn't have all the features, but it has some good features in it. And of course, Pacey is the fastest. So all of these things are there. So when you go outside the class and you suddenly see on data on Medium or someplace this being used, you must be wondering what is all this? We didn't talk about it in class. It's nothing. It's just picking up the library functions, and it has got a huge corpus. What does the corpus mean? What is the corpus? It has a huge corpus of documents, a collection of documents at the back end, and at the collection of documents it has the rules. Is a word, D is a very common pronoun, like stuff like that. All of the things it has got, the rules are written at the back of it. So that is why the corpus is, it has got, for all of them have their own corpus. So all of them have their own corpus to start with. Now what I am doing in the beginning here is something simple. I am just going to kind of download some files here. So as you can clearly see, it's nothing much. I have not done here much. Just put in the usual files. Some things I downloaded when I ran into problems, because I was running it was not working. So I was googling and figuring out what is wrong with it. So some of the NLTK toolkits were downloaded from there. Having said that, the next thing that I did was, it is a Python library and offers a simple API. So I put some commentary for you guys to keep with you. It performs methods and performs basic NLP tasks. A good thing about it is that they are just like Python strings. So what are Python strings? What are Python strings? What is a Python string? You have a string, right? In Python you have a string. So if you have a string in Python, what does it look like? You just have this, no? Sorry, this is not working. What is Python string? So you have got, it is a book or a blog, right? So it's a Python string, str string. So that is what it is. If you do this, it can lead to a problem. You might have seen this. It's a book. If you do this, it can lead to problems. What problem will it lead to? This is saying it is getting closed here, but it is, the loop is not getting closed. So we have got that sorted out there. It has got, so I got a text blob here and I picked up the 11 characters. As I said, I'm starting from very basics. I know this must be very basic. You have done this 100 times, but I'm starting from very basics just to ensure that we kind of are on the same page. So you have got that, and you can see I've used, on the strings I have used an upper. Upper is basically a built-in command that will help you make it upper. And of course the next thing is to concatenate. So if some of you are running into any kind of problems, I have also told you where to download the corpus, because sometimes without downloading the corpus it may not work. So if you're running into a problem in the class right now, then that is because that installation is not happened. So if you run the code, you will know if you're running into a problem. Okay, so if you're running into a problem, then you need to go to Anaconda prompt and download the corpus. Then we get to the real work. The real work is tokenization. The tokenization is to divide the text or sentence into sequences. So create a text block object and pass a string with it. So you're creating a text block object, passing a string with it. Call functions of text block in order to do a specific task. So you're calling the function to do a specific task here. So this is my string. This is a text blob string. So you have to be very careful. This is not a regular Pythonic string. It's a text blob string. And have you heard of JSON format? Yes, just like you have a JSON format for certain things, especially if you are doing blockchain, you have to put things in JSON format. Here also you can see this is a text block, and that is there, and you can see I have tokenized it. So blob dot sentences, so it has taken the sentences wherever there was and it has made them separate tokens. So that is where very simple commands, blob dot sentences. You can further break it down into words. So I could do that. So I went to the next level and I further broke it down into words. So I just took the first sentence, that is why I have written 0 there. If you wanted to pick up the next sentence, you could have written 1 and you could have broken down into words. Very straightforward, simple, broken down into words. So tokenization of sentences, tokenization leading to this. Now comes the interesting part. The interesting part is we only want to take out the noun phrases. We are not interested in taking out anything else but only the noun phrases. So if you want to take out the noun phrase, you must first identify the noun phrase. You want to analyze the who in a sentence. Now I did this. I said Enlightened is a great platform to learn data science. Noun phrase print NP. First of all, can you please check and tell me that all the words are nouns? Are they all nouns? Are all of them nouns? Yes, no. Which of them are nouns, which of them are not nouns? Sorry? Great is not a noun, right? It should have been an adjective. This shows you, what I purposely bring this example is because this shows you that end of the day you are dealing with machines. End of the day you are dealing with machines. Somebody must not have at the back end been able to get to that level of granularity where we can clearly say that great is not this and it is this, right? So end of the day you are dealing with machines. That is why it is picking up some stuff which it should not have picked up here. Going forward, it's quite simple. After that, I picked a great platform. I went around and I did some tagging. So this is what the thing I want to talk about, parts of speech tagging. So in the part of speech tagging, what you have seen is it tells you what these things are. It tells you what Enlightened is a great platform. So I've done the tagging for all of them. So all the tags you will notice, they are all capital letters. All capital letters. So anybody can tell me what is VBZ mean? What does VBZ mean? So when you run this, you get something called VBZ. What does VBZ mean? So let's go back and check on the pen track. Where are we on the trend track? VBZ. What does VBZ? Verb third person singular present. Verb third person singular present. So if you don't know the meanings, you need to have this ready reckoner. Some of them are very easy, noun, singular or mess. Let's go through a few of them just to kind of familiarize how to read these things. So if you go back here, you have got JJ. What does JJ mean? I mean, it's a JJ. JJ means adjective. JJ means it is an adjective. Now go back and check if what he's saying is correct. Is great an adjective? Is great an adjective? I agree with you too. What does VBZ mean? Let me see. VBZ is version third person singular. That is means singular. R means plural, right? So you can see it is singular and plural. Platform is a noun. Learn is verb again. I think it's a simple verb. VB, verb or base form is noun. You can clearly see it. You can see signs. You can check the full list. I have left the full list here as well. Okay, then comes is the process of word formation added to the base word. So I've kind of made the base word. You can make words out of the base word. So blob dot sentences 1 dots word 1. What will this print? Can you tell me what it will print? Word dot sentences 1 dot words 1. What will that print? In the first sentence it will print the second word, or will it pick up the second sentence and print the second word? Think for a minute what it will do. So if you do this, blob dot sentences 1, it had been 0, it would have picked up the first sentence. 1 means it will pick up the second sentence. And when it picks up the second sentence, you can pick up the second word inside it. And then you can say, make it singular. So I first picked up the word, the answer was helps. And if I want to make it singular, I can say singularize it, answer becomes help. So from helps, we have gone to help. So you can see it's fairly easy to use. It's not something that requires a lot of brain power. I mean, I'm just starting you off. It's less than 1 hour in the class. So kind of showing you some of the basic things that you can use. In fact, you can use some of this for your projects. You know, a lot of challenges that you're facing with project is in terms of finding data. If you are doing ML kind of work, if you are doing convolution neural network kind of work or image recognition, everybody talks about object detection. In some form or the other, you are always talking about object detection. The problem is that many of those things are not easy to do. Either the mathematics behind it is very complicated for a 6-month time frame or 7-month time frame. But one area that you can explore is try to make sense of using machine learning, try to make sense of customer feedbacks, reviews, Twitter accounts. So once I had a bunch of students work in 2019 before the elections, I had a bunch of students analyze the Prime Minister's speeches. So they picked up the speeches of 2014 and 2019. And you can see the marked difference. In 2014 speech, he talks about corruption, price rise, a bunch secular country, all of those things. Those are key 4 or 5 words. And in 2019, he talks about what? There is silence in the class. In 2019, what does he talk about? Balakot, terrorism, Pakistan. That is what he talks about. So these guys went and picked up all his speeches and they just did what I am telling you. They stripped it into small chunks, took out the common words across documents and sent, this is what he's talking. These are the key words we have found in all his speeches, concurrent across all his speeches. Top 5 words I'd asked them to find out. So a very, very interesting thing, because you see sometimes numerical data can be misleading. And I'll give you an example right now in the class why it can be misleading. So all of you know, sorry, today it seems I am having a bad day. Every pen I pick up has no ink in it. So y equal to 5 plus 6x, right? Y equal to 5 plus, or let's make it yi equal to 5 6x. Yes. And I tell you that the r square value is 90%. Okay. Now looking at this equation, what do you remember? What do you think of? Something you've seen on this in this program? Unsupervised, supervised learning? Linear regression, right? To think about a linear regression. But at the end of the day, this is the mathematical model, right? Now the question is, what is the difference between mathematics and statistics? See, that's the fundamental point here. What is the difference between just doing maths and counting 2 plus 2 is 4, 4 plus 2 is 6, 6 plus 2 is 8. That's mathematics. Then what is the difference between mathematics and statistics? Statistics should be also called mathematics only. Sorry? Okay. Study from getting inference. What else? Correlation. What? Sorry, Sachin, bolo. Didn't hear you. Okay. So, you know, we are in this, you have been doing so much of this stuff. At some stage, mathematics and statistics starts to get blurred, right? I mean, sometimes you say I'm doing mathematics, sometimes you say I'm doing statistics. But trust me, there is a very, very significant difference between the two words. Mathematics, I gave you an example. 2 plus 2 plus 2, 6. Right? Statistics, you are talking about this. Then what is this? This is a math. If you look at this model standalone, this is a mathematical model. I agree with you. This is a mathematical model, because this mathematical model does what? It relates x to y, right? Then where is the statistical part coming out of it? Because if you remember you just told me in the class this is linear regression, yes or no? And linear regression, you and I both agree it coming from statistics. So where is the statistics part coming from here? Yes, we arrived at it based on a sample, but there's one more interesting thing. You see, all these numbers which you have written on the board here, 5 plus 6, are they set in stone or are they changeable? Why are they changeable? How can they be changeable? Because 2 plus 2 plus 2 in mathematics is 6, na? I cannot make 6 equal to 8, correct? 2 plus 2 plus 2 is 6 only. Then how can this change? Remember something that we always ask you to do? Calculate what? Confidence interval. So when you calculate the confidence interval, you say the confidence interval of this is, let us say, -3 to 8. And the confidence interval of this is, let us say, -1 to 9. This is what you say, which means that these numbers are only an estimate based on the population, but these numbers can vary between -1 and 9. It can vary between -3 and 8. So mathematically they are mathematical numbers, but this entire model is statistical because the numbers are not constant, the numbers are going to change because the sample will change. Otherwise, nowhere else in mathematics, if you go back to your school days, nowhere would in class 9th or 10th we write so many equations, x plus y equal to z, this and that. Did ever any faculty ask you to compute confidence interval in class 10th, 11th, 12th? No, because we were dealing with pure play mathematics. We were not dealing with statistics in the first place. Now you are dealing with statistics. That is why each and every number that you have has got a confidence. This is called point-wise estimate. And what is what you were saying today in the morning about estimate. This is estimate, but these estimates are all beholden to the confidence intervals. Now, why is that point important? The point is important is that when you are dealing with things like this, like language and all of that, we are talking about statistical models because we are also not sure that what we are saying, the system is picking up, is it going to be 100% like I'm saying is. It could be that in some other model, the word is considered to be a noun, whereas is always a verb, right? Is always a verb. So there's always going to be some degree of uncertainty when we are doing the tagging for these things. We are going to always, it's never going to be noun 100% guaranteed noun. We are saying it is 70% or 80% chance the word is a noun. So you might look at a bunch of words and say, तो बोला noun बोला था, ये तो verb है, what is happening here? So that is where the statistical element of this whole subject comes into place. We are still not sure about how to break things down and put it in place, specifically because each of these words have got many inks, running, playing, all of those things are there. So there is like displaying, this comes before playing, displaying. So replaying, playing. So all of those challenges are there, and that is why we are dealing with statistical model, not so much as mathematical models. There is a confidence interval behind each one of these things. Having said that, the next part obviously was to try and see how we can take the words and how we can pluralize the words. So just take the word platform and I wanted to just pluralize it into platforms. Tying back to what I was saying here, that if you guys are doing any kind of statistical model in your capstone project, then if you can do any analysis on text which can circumvent your which can bolster your findings. So whatever mathematics is saying, your equation is saying, the linear equation is saying that the sales is dependent upon, let us say, disposable income. Sales is dependent upon disposable income. If you can have any kind of English argument with all this NLP at the back of it, it only strengthens your argument in front of the client. The client feels that not only are the remarks, the qualitative remarks also saying that, the mathematical remarks are also saying that, right? That is the reason why we teach this course, because this part you already know. This part you already know. But the important part is to understand that it is not by itself enough to justify sometimes many actions, because sometimes numbers and what the comments are being coming are different. So for example, I'll give you your own example. One day there was this, I was reading the feedbacks. I always read the feedbacks. I was reading the feedback and somebody had written some comment. I could not understand the comment and I couldn't understand the rating. So I said, what happened? How did this go wrong? So I called up the program team. I said, I can't understand the rating and the comment. So either the comment is right or the rating is wrong. One of the two things has to happen. So this person, what the program team called up the student to find out. I don't know who the student is. And the student said, I actually wanted to say this, but when I was marking the person's ratings 1, 2, 3, 4, 5, I mistakenly marked it like this. Right? Mistakenly. So data at times can be wrong. Numerical data can be wrong, and when you look at NLP, it can tell you, hey, you know what, your numerical is not matching with your the written feedback that you have given to the faculty. Okay, you are saying, oh, he's a very good faculty, blah blah blah, and suddenly you see you giving him a rating of 1, right? If that is that is your understanding of 1, I think that's a very good one. Having said that, that's good. Having to then we move on to the next thing. Hey guys, it's 3:20. Is the speed okay or am I going too fast? Speed is okay. Generally the students in my class control the speed. I don't control the speed. The only reason why I'm going a little fast because all these things are a little bit simple, just adding one command. At any point in time you want me to slow down, please let me know. And any point of time you want to go out and have coffee or tea, just let me know. We don't have to wait till 4 o'clock to go and have coffee. Okay, don't worry, I will still get the content done. That's my job. Okay, So having said that, let's look at what is lemmatization meaning. So lemmatization, what happens is that he takes the original word called running, and it's a verb which we already know, and we say lemmatize it to a verb. So don't keep so that see, the other important things is, why are you saying lemmatize v? What does v mean? V here represents verb. Why should it be lemmatized to a verb? Because if you don't write v, it could also be lemmatized to something else. What? Because it could be lemmatized to maybe an Italian word, in the Greek italics word, which we also have, which is the birth of English language, where Shakespeare comes from. So that's where the issue is, that you have to sometimes tell them what you want to lemmatize. Then you have got n-grams. Now n-grams are actually quite interesting, because I will be using them heavily for classification today and tomorrow. It's also there in your internal and external project, or what do you call it, labs. It's also in that, and then it is also in your massive major project. Okay, so I would certainly suggest to you that so we talk about n-grams. So what n-grams is, very simple. Before you do that, let me try to explain to you the concept of n-gram on the board, because this will be a lot easier on the board than me trying to explain it to you here. So let's say this is a book, right? So you have got the first word, the second word, third word, fourth word. This would be called n-gram 1. What does n-gram 1 mean? Only one word at a time. Now you look at n-gram 2. So n-gram 2 would look like this. This is n-gram 2. So now the n-gram 2 is going to be, this is a book, right? I could have made it into 3 also, right? You could have done that also. So that is what here it is. I gave the command for 2, so it made it into 2. Enlightened is a great platform, like that. So that is where it was. And then you have got sentiment analysis. Now comes the fun part. Sorry? Classification problems. So what we can do in the classification problem, which we will see, is that we will convert these two words into numbers, and we will bind them together. So that will have a new vector, and we will say this vector. Okay. So now comes the interesting part. This is what I had been waiting for, and I wanted to get to sentiment analysis. Everybody wants to do sentiment analysis. In sentiment analysis, there are 2 parts. What are the 2 parts? Polarity and subjectivity. So what does polarity mean? Sentiment is basically the attitude or emotion of the writer. What is your attitude? Are you a positive writer or a negative writer? Do you think in a positive frame of mind, or think in a negative frame of mind? So that is what sentiment is. In addition to sentiment, you also have polarity and subjectivity. So within sentiment, polarity and subjectivity is there, and polarity varies between -1 and 1, where 1 means positive statement, negative one means negative statement. So naturally, if you are looking for somebody who has +1, you say these sentences or these phrases are positive. If negative, it means negative. Now this kind of stuff is what you can use in the capstone project, so as to speak. Yeah. Yeah, it is doing a background calculation for that. So it's a detailed calculation. It is taking some of the words which we already like, good, great, all of those words it is taking, and then it is making this thing at the back of it. Yeah, it's a positive thing. Subjectivity is where you are talking about like contextual. The contextual part, it doesn't do a very good job of it. It's picking it up, but it is not doing a very good job of it. So let me give you an example of subjectivity. So like judgment, where opinions refers to factual information. So I'm saying this is a good book. This is my opinion. Is it really a good book? It is subjectivity, no? I think statistical NLP is a boring class. Somebody might say NLP is a great class. It's subjectivity. right? So that subjectivity it tries to map. Polarity it is very good at doing. Subjectivity I'm not so comfortable with any of the three packages, because again the way it has been designed at the back end, the algorithm which is being used, it is not consistent across all three. All three meaning NLP. No, it is based on points. So it is bigrams and trigrams. It will take the measure of bigram, because individual words it has no meaning, right? You always want to look at bigrams. Is R is great. R great. R great will have more subjectivity. R means more people think that this book is great. Is great means only one person thinks that the book is great. That ways. Any other questions? No, it's okay. So anyway, so that is where we are. I tried to do that here, and I was seeing sentiment of 0.8, subjectivity of 0.75. So it says that it is fairly able to pick up the subjectivity and the polarity, and it says polarity is 0.8. What does polarity of 0.8, what would it mean to you? Positive. I'm already saying that Enlightened is a great platform to learn data science. It helps community blogs, hackathons, discussions, etc. We can see polarity is 0.8, which means that the statement is positive, mostly is a public opinion and not something that that is a factual information. No one has ever said that Enlightened is perfect or Enlightened is the only place in the world where you can go and learn data science. Having said that, FYI, the reason why I'm using the word Enlightened over and over again is because that's my firm. So that's what it is. So I must be wondering why have I chosen the word Enlightened. That's why. You can also do spell check function here, so you can check the spellings. You can look at spell check function. You can do word spell check. Platform ka spell check hai. And the next very important thing is about summary of text. Summary of text is actually quite interesting. Let's go and see. Oh, this one you mean spell check equal to 1, right? So it's picking up the 4 and saying it is right. 1 0. That is what it is. Okay, so we are kind of going through this in a nice way, in a neat manner, and then I have got some stuff here and here and here. Let us see what we want to do here. Let us go and look. Where did we go? Where did we go? Where did we go? Did we do the n-grams? We did the lemmatization. Okay, fine. Creating a short summary of text. You can see the summary of text is here. The text is about. You can create a short summary. So in the short summary, I have written a simple word tag in blog tags. The keywords is the text is about platforms, industries, platforms. Again, so you can see it has come back twice. Platforms has come back twice. Communities, forums. So it has come back twice the word platform. You can create short summaries. Do you know where this is helpful? Any idea where this is helpful? One place in your workplace where this is helpful. So one of the areas is that I used to find this kind of stuff, which I wish it was there when I was doing this. So I used to work in Hong Kong, and the problem is that I used to go to attend a lot of conferences on behalf of my office. So they used to give me a lot of research material and stuff like that, and most of the material would come either hard copy or they will issue a request. They will send soft copy of it. Now, who is going to sit and read 500 pages of research material? Because every week some conference is happening in some part of the world. Now I am not going to keep sitting and reading it, right? So one area which is helpful, it could have been helpful, is that instead of you writing so much text, you take the entire text from the Acrobat reader or Word document or wherever else, put it in there and say what are the keywords or key themes this is talking about. That will at least give you some sort of summary if that is an area of interest to you or not. Now if you already know you are interested, of course read the full thing from beginning to end. But if that is not something an area of interest, then you could have done that. But I didn't know Python at that time, and I didn't know NLTK or NLP, any of these things at that time. As I told you, I planned to be just doing normal regular work after my MBA. So now I feel that if I had known that, I would have saved a lot of time, because large document, by the time you finish reading the 10th passage, you forget what is in the first passage. And then I used to have a boss who was old school. So he would say, I want a summary of everything which has been written. So I used to keep every para I used to have to make summary on the side, because at the end I have to type it down and make it in 300 400 words, he will say, because he was a chairman. He said I have no time to read so much, but I want to know everything. So it used to be a pain. If this had been there, it is much more faster to do. right? One interesting addition on top of this that you can do is web scraping. What is web scraping? Web scraping. Websites, you can scrape the data, all the textual information from the website. FYI, just be careful, it has now become illegal. So if they find out you're doing web scraping on some of the websites, your IP can be blocked. It was not illegal 3-4 years ago. So when we used to do this class, we used to web and social media analytics. We used to go into Twitter, take out all the messages, and we used to analyze in the class in the real time, right? And scrape the whole thing and analyze in the class in the real time. But now it has become illegal, so you have to be a little bit careful of how to use that. But you should, so just when you're doing this kind of projects, just be careful about it. That's all I was trying to say. And then one of the interesting things here is that you can also check the language of a word. So you can pick up the language of, I picked up this words here, and I picked up this word, made it into a text blob, and what is it is Chinese, and I said, hey, let's convert this Chinese to English, and therefore I converted to English. And what is the English translation of the Chinese verb? This is cool, right? This is absolutely cool. Everything is going well. What happened? You want me to write even bigger than this?
No, sir, it's okay.
Now I think I'm fine. I think I'm fine now. You guys can see, right, at the very end. Yeah, that's fine. Perfect. Okay, now let's start doing some classification models here, which is going to be crazy, but it's okay. Let's do. So this was all the basic stuff I wanted to cover with you. Wanted to just go through singularize, pluralize, pick up words, do some basic sentiment analysis and stuff like that. But that's not what this class was about. This class last time I checked was statistical NLP. Still now I have not done any statistics in the class. So I'm beginning to wonder if I am teaching the wrong class. Having said that, I created some training data set. Now in this training data set, I didn't create it, I picked it up from somewhere. But some interesting thing about this training data set is that you have got these sentences, and next to the sentences I have used negative, positive, negative, positive. So these are assigned not by anybody but by the user. So I am the user, I have created this data set, so I have said Tom Holland is a terrible Spider-Man. Tom Holland is a terrible Spider-Man. It's a negative sentence. You agree with me? Then I have got a terrible Javert ruined Lee miserables for me. Again negative. The Dark Knight Rises is the greatest superhero movie ever. Positive. So I did this on my own, just took some sentences and I classified them as good or bad sentences. And then what I did was I did the same thing on the testing side. On the testing side also I did the same thing. I kind of did that there as well. Text provides an inbuilt classifier. And finally I came to do what is known as, took that and I went into text block classifiers and I created what is known as naive Bayes classifier. And I took a naive Bayes classifier. Have you by any chance heard of naive Bayes? Yes? You know what it is? Okay, so tell me what it is. Okay, you are very close, very close. I think almost right to the right point. Anybody else what is naive Bayes? Have you done it first? Or am I asking a question which I should not ask? See, tell me honestly, if something has not been covered, then let me know and I will cover it. But so naive Bayes, what is naive Bayes? Zero correlation between features. Okay, what else? Which is independence, which is what he was saying. Yeah, but what is naive Bayes? Why do we use naive Bayes? I think you were taught in supervised learning, right? Next week I am teaching supervised learning in AI/ML in Gurgaon. So naive Bayes. Any thoughts? Very good answer. Probabilistic model based on Bayes theorem. So how does it work? Like what is happening inside it? See, logistic regression, if I ask anybody, they will immediately say such a classification problem, 0 and 1. That's what people will say. Yes? The minute I will ask you about regression, simple linear regression, I showed you on the board, everybody would say, so the prediction problem, X you give, Y I will predict. So given A, what is the probability that B can occur? But then why are we calling it naive Bayes? You could just call it Bayes now. So what should I write on the other side? Right? So this is how Bayes theorem works. simple Bayes theorem. And to refresh your memory a little bit, you have got two sets A and B, and this is A intersection B, right? So what you are writing here is following: P A given B is equal to probability of A intersection B divided by PB, and then you are saying PB given A is equal to probability of A intersection B by PA, and then finally you are saying the following, that this implies that probability A intersection B is equal to probability of A given B divided by PB, no, not multiplied by PB, sorry, so it will be multiplied by PB, and you are saying that probability of A intersection B is equal to PB given A into probability of A. Yes, this is what you are saying, and then you are saying that these two things are equal, and because those two things are equal, what do we end up doing? Probability of A given B multiplied by probability of B is equal to probability of B given A multiplied by probability of A. Yes, and then that gives you probability of A given B, which is equal to probability of B given A multiplied by probability of A divided by probability of B. Yes, right? So this is what is known as simple Bayes theorems. And what's naive about it? What you were saying, what's naive about it? So think about it for a minute, what's naive about it? Okay, so let's see how this will work. How many of you have life insurance contracts? Life insurance for your life? All of you? Some of you? Life insurance? So as life insurance, when I'm sitting and doing your life insurance pricing policy, I use the following logic. I suppose you come to me and say that I want life insurance between the years 50 and 60. The person should be first alive till the age of 50. Then only if something happens will the person be given any life insurance. Correct? So there is the condition there. It's not as simple as probability between 50 and 60. Probability is that you are going to be paid conditional that you are at least at the starting of the contract alive, and the contract starts at what time? Age of 50. So it's no more a simple probability, it is a conditional probability. Just like we say it is conditioned to you getting very good marks in your +2, you are going to get admission into college. It is not just passing, but it is the precondition to that. So conditional probability is heavily used in sequential models, because everything is a condition. The sky is blue. The sky is blue is very easy for us to say, but for a system to detect, there has to be some probabilistic model which tells it that when you have this kind of sequence, the sky is, it should automatically point to blue. It is not talking about the sky has a rainbow in it. It's only talking about the color of the sky. So probably this is important. Bayes theorem is important. Now that you understand how this Bayes theorem works, just wanted to kind of draw it from first principles for you. What we are basically doing was the following. Would it be okay if I write the following? PA by B is directly proportional to PB given A into PA. Would it be okay? Yes, no? What have I dropped? I have dropped the denominator. Because I have dropped the denominator, my equality sign has become inequality sign. Got it? That is one of the important things here. Now what I will say is PA, instead of B, I put in multiple conditions. θ1, θ2, θ3, and I explain that to you in a minute. θ1, θ2, θ3, this will become what? θ1, θ2, θ3 given A into probability of A. So I have replaced B, instead of having one condition, how many conditions I have now got? 3 conditions. And what he was saying was that you can further replace it down by saying P θ1 into probability θ2 into probability of theta 3 given A multiplied by probability of A. How is this possible? Zero correlation and independence. So the conditions are independent. So because they are independent, you are able to do this. So that is why you are able to take, because they are independent, all these three terms are independent, but they are all conditioned on A, you are in a position to write it like this. And this is the mathematical model that we will be using. In fact, I have a full problem for you to do in Excel. So whenever I teach these kind of statistical models, I prefer to do one problem in Excel with words and sentences so that you understand what is happening. Our friend here can do it in 1 second. But we have to understand, just like the same problem, what is the mean and variance of 1, 2 and 3. Understand what is inherently happening. So I'm setting the stage before, because I know it's hitting 4 o'clock and I also know it is Saturday today, so we have to have coffee. So I'm setting the stage for that. So this is where you're talking about naive Bayes, and we will work out two problems in the class today in Excel before we do it in Python, so that you understand how that part of Bayes theorem applies to text. You, I'm sure, understand how it applies to numerical data, because it has been covered where in your which course? Supervised learning. Okay. So here what I will just finish this off and then take a break. Here what is happening is something simple. I have got a naive Bayes classifier. I am training it up. After training it, I am saying the following. Training it and finally asking it to do some simple things for me. I said, you know what? Classifier, show the top 3 informative features. So what are the top 3 informative features it is showing me? The top 3 informative features it is showing is that it contains is equal to true. What does this mean? Contains is equal to true. If a sentence contains is, contains means the sentence should contain is. If a sentence contains is, if is present in a sentence, in the next sentence, if A contains A, false means what? A should not be there in the sentence. Again, you can see terrible, it should not be there in the sentence. So what it is saying is that if that be the case, the positive to negative ratio is 2.9:1. So you can see that the positive sentiment, if this word is there, is there, the chances that your sentence is a positive sentence as compared to a negative one. If this word is not there, the chances that your sentence is a positive sentence is 1.8. If this word is not there, it is also going to show as 1.8. So that is what it is doing. And then I just made up a word right here in the while I was typing this down. Text blob, the weather is beautiful, classifier, and it tells you it is a positive sentence. And pretty much ended this classification problem there itself. However, it is not that simple. And I have also put the pros and cons, so you can see the pros and cons of some of the things which I do. NLTK and pattern therefore makes it simpler for beginners by providing an intuitive interface to NLTK. NLTK is a lot more complicated. Language translation detected, powered by Google Translate, not provided by Spacey. Lot slower compared to Spacey but faster than NLTK. Does not provide feature dependency, parsing, word to vector, etc. Word to vec you will learn when you are doing the next course. The next course is Sequential NLP, where you will start talking about how to use deep neural networks in order to do word to vec translation. So this was something, just an overview about using text blob, about how different types of text can be analyzed and we can start working on. When we come back after the break, we will then talk about something more intense and challenging about headline news analysis, some more statistical stuff. So this was just to get you started on the journey of NLP. Having said that, couple of things. There is a file which I have given you, and that file is known as news headline analysis. So just open that file. Okay, did you get this file? So there is a file on the top saying news headline analysis.jp. Yes? Okay. In the folder, or not in the folder, I think it's not in the folder. In the link provided by Sukanya, there is a massive CSV file which has got 2.7 million headlines. Yes, you would have been able to see that as well. Sukanya would have provided that link to you. We were struggling to upload it, so that's why I know that she has provided the link. It's there. Is it there? Yeah, it's there. So it's there. What I want you to do is first download that file or somewhere where you can access it, and second, I want you to read the file in. I want you to read the file in, because the reading of that file, the database to read it will take us half an hour. So if you set it up now, then by the time the break ends and we are all ready to come back and start, we can do something with it. Okay, so you want to go ahead and read the file in. It takes a huge file. Yesterday night I was testing the files before coming to class. It took me 2 hours. I was so frustrated because I couldn't do anything, and leaving the laptop would have meant it would shut down on its own. So I was like sitting there till it was 1%, half a percent, 1%. And before you do that, put it on hardware accelerator, GPU, because I learned that this is much faster to do it. It just condenses time. So go to runtime settings. Go to runtime settings. Go to runtime here, and in runtime you will see change runtime type, right? So set it equal to GPU. Hardware accelerator equal to GPU. Okay, so that's important. That just saves you a lot of time. So once you are done with that, let's do a quick class recap of what we learned, what we didn't learn, and what we are trying to learn. And then let's take a break, come back and start getting into some really heavy stuff. In fact, the news analysis is with you'll see this file. It has got BJP, Congress, Aam Aadmi Party, everybody is inside it. So it's a lot of fun. You will understand it's a lot of fun to analyze the headline. What did they say? When did they say? Why did they say? And if you guys are, if still time permits and you guys tell me you are still charged up to do statistics, then we will take this forward and solve 2 Excel problems on that. Okay, but it's completely up to you guys how you feel. Is it running now? The files are running. Hey guys, speed theek hai? Speed is okay. Speed is okay. Anytime you need me to control, let me know. Concepts chal raha hai. It will take time to absorb. It's not something that will come. A little bit of practice is needed. Unlike some of your heavy subjects like deep learning and all, it's not that heavy, because you are already using ready-made things like naive Bayes and all, which you already understand. It's more about applying it in Python. That is the challenge here. The challenge here is not so much in terms of, it's too much of heavyweight lifting in the brain. They are very, very simple concepts. Because you can't do complex concepts because we have not built it inside those libraries. So simple concepts, but the Python is the main challenge. Okay, so downloading. I'm just waiting for okay, then let's do a quick recap, because while it's downloading we can't do much really. So the quick recap of the class was, where did we start the class today? And I'm not doing the recap, you are doing it for me. What is the first question I asked in the class today? What is stats? Second question, what is a model? Then what did you learn in the class today? So 2 things you learned is stats and model. Then what did you learn? What are NLP types? What else did you learn today? Statistical and difference between statistical and mathematical. Yes. What else did you learn? How to compute the mean and variance of 1, 2 and 3. Right? Yes or no? Yes. So I mean, that I always check, because sometimes I feel I have already taught you and then I don't know if I taught you or not. The next thing, what else did you learn today in the class? You learned about NLP. You learned about 2 kinds of NLP, statistical NLP and sequential NLP. In sequential NLP, you go with recurrent neural networks and all of those things. Then you learned about sentiment analysis, parts of speech, tagging. You saw parts of speech be getting tagged, noun and adjective and so on. Sentiment analysis, I did it on the board for you. Then you learned within that about polarity and subjectivity. If the polarity is +1, people are positive. Polarity is -1, people are not positive. The subjectivity varies between 0 and 1. It is not about factuality, but it is about subjectivity. Then after that, you went from there to understanding how to make tokens. So you took sentences and chopped it into sentences, or also into words. Then from there, what else did you learn? You learned how to make it stem and lemization. You learned that. Then from lemization and stemming, you came up to learning about how to make it singular, how to make it plural. I showed you some basic stuff about spell check and stuff like that, how to make the spell checks work, etc. What else did you learn? You learned that there are 3 different types of library functions out there. The 3 functions are NLTK, Spacey and text block. So I was using text block today the whole day in the class. Also parts of NLTK were used. If you remember, if you see the library functions, you will see NLTK has been downloaded, certain parts of NLTK. After that, what did you learn? You learned a little bit about Bayes theorem, you learned a little bit about naive Bayes theorem. I have not really deep down into it. I will do that. That needs a deep down into it. So you just learned it at a superficial level, rejigging your memory. What else did you learn in the class? You learned a concept called bag of words, which you have not yet seen. You will see after the class. But bag of words is nothing but a bag which has only got words in it. The meaning and the sentence and the grammar is lost. Another important thing you learned was that these are machines, they are not perfect. So you saw one example where we were trying to pick up nouns, it also ended up picking up verbs, right? So we are machines, these are not perfect. The key important thing I told you in the class was that you can use some of this information to supplement your machine learning projects. You can say that, NLP is saying that customer data is saying that it is negative, customers don't want to buy, but NLP is also telling you what customers don't want to buy. They don't like to buy sandals, they don't like to buy shoes, they don't like to buy shirts. Those things you can use to do it. So
my name is Anuj Khajuria, and I'm working into analytics from last 8 years. So I have done my engineering from NIT Srinagar, and I have done my business analytics studies from ISB. So, okay, today's topic that we are going to talk about is sequential models. So RNN and LSTM are the sequential models actually that we are going to talk about. But before that, I have introduced myself, but I want your introduction as well. You are not many, so you can do it quickly. But with introduction, I want something from your side, one extra thing, that is like what is the inspiration behind doing this course? And like you already have covered 60 to 70% of the course. So I want to understand what you think about that inspiration right now. So you can take 2 minutes and write it down so that everybody has that information written and can present or can say within time. You don't have to take much time for that then. So we can start with after 2 minutes then. Okay. Okay. So we can start from here, right? From you. You can also tell about your the work experience, what you are doing currently, so that I get the feeling what the batch is actually doing right now. Yeah. You have to be a little louder because everybody wants to listen to you. Okay, but that's like you told like you want to do something in this field, but what it is actually, because there are so many things that you can do in this field. From where it started actually, where you come to know, okay, I want to do this. Yeah. Okay. Then one more thing that I know you guys want to switch also and earn more money also, and that's also one of the reason that you joined this course. So it's very obvious to me. If you want to tell that, it's also fine for me. It's not a problem. But other than that, I want to know more what you think about artificial intelligence and machine learning. So that's the reason I'm just asking this question, and accordingly, I can talk about things that we want to talk about today. So yeah, you are Amit, right? So I can remember these names actually because you are like just 7 people. So that's the reason I just okay. Okay, so again 11. I'll try. I'll train my model that way. It's very good reason actually because I talked with most of the guys actually who are in high position, and most of the times they are not able to understand what I'm saying actually. Then first I have to take them through the machine learning and artificial intelligence part, and after that I can explain them better. So it's always I think with people on higher side actually, a higher position side, that they want to learn, they want to like know what this deep learning, artificial intelligence, machine learning is, and then after that they can actually take the decisions that are good for their company. So Amit, Rohit, so you can talk about artificial intelligence and machine learning with your colleagues and that kind of stuff with your higher management. So that's also one of the important point, because if you know something, you can talk about that thing with your higher management as well. So it's just not about, yeah, of course it's important because you joined this course and you want to learn all these things, but if you don't know the concepts, you can't talk about all those concepts with your higher management. You will not be able to explain those things. Doing these practical things at your experience level after 10 years, it's your choice. If you want to do it, you can do it. If you don't want to do it, you don't have to. You can go to management and you can say, okay, I can lead some team. I have a knowledge of this, all these things. Yeah, that's a good point. Yeah. Once you have that kind of understanding and you know the flow, what things you want to learn, you can explore the sources. Like you can go to Google and see other documents and just study through it, and then how to implement things you can go through, but you should be aware what's the sequence of all those things, how from where to start and where you want to end actually. So that's important. Hemant, right? Devraj, Hemant. Yeah. One thing more that you talked about is rule-based systems. Yeah, so I guess everybody know what it is actually. So if-else conditions that we are using, this all is rule-based. So till now we were like, not till now, but it's just 10 years back, we were using that rule-based systems, if-else conditions. If we want to make, if we want our machines take some decisions, we just write if else conditions and then they take those decisions actually. But now the situation is different. We are just developing some kind of a mind or brain for those machines, and they are taking decision according to the data that's coming in actually. So that's what we are going to achieve. And deep learning, or the topics that we have to discuss today, it's like talks about all those things also, right? Yes, sir. Okay. So Abhijit, you, Dilip. Okay, I got the names. Amit, forget. Rohit, yeah. Devraj, Hemant, Abhishek, Siddharth, Abhijit, and Dilip. Right, great. So I trained my model that way. Good. So let's start with the topic, today's topic. So it's a natural language processing using RNN and LSTMs. So first of all, you already have gone through NLP, right? You already covered this topic, NLP topic. You have already covered text analytics. So anybody wants to tell me what's NLP, what's text analytics, and what all things you do to do text analytics? Or you want me to recap all those things for you? Huh? Okay, you want me to do that? Or you want to? Okay, sure. I'll, yeah. So first thing, we'll talk about text analytics, okay? And in text analytics, what all things you use, how you prepare the model, text analytics model, what all things are there actually. So I have a text. Now I want to do text analytics. What is the first thing that you want to do on that text? Exactly. So pre-processing, right? So in pre-processing, you told what you want to do? Stop words you want to, then duplicates you want to say, duplicates, it's okay, yeah, we can consider that also, but yeah, it's always there. Special characters, right? Text to, okay, yeah, that's one thing. You are missing two important concepts here. That's like, that's not a part of pre-processing. Yeah, it's a part of pre-processing, but I guess it's feature engineering, not pre-processing. Yeah. Yes, stemming and lemmatization. So stemming and lemmatization. So you know what these things are, stemming and lemmatization. So once you have done all this, you have converted it to like lowercase also, we can say. You have converted to lowercase. And if you want to remove numbers, you can remove. Some cases it makes sense to keep numbers also. So you always don't remove numbers. So after that, what we do, this is the first step, that pre-processing. Next thing. Tokenization. But I just want a name for like what that phase is actually. Feature extraction, yeah. Or feature engineering, you can say that also. Extraction. So bear with my words, actually I'm not good in remembering the words. So whatever I write, just what I'm saying, just focus on that, not what I'm writing here. So feature extraction, what things you do here? What kind of techniques you have for feature extraction for text? Yes, TF-IDF. Yeah, bag of words, somebody, yeah. And then count of words. And one more, if you remember something. Bag of n-grams. Bag of n-grams, yeah. N-grams. So what we achieve here, when we say feature extraction, what we are doing here actually. I'm just recapping. If you think it's like you already know all these things, then I can skip it also. So this is okay, right? Okay, good. So what feature extraction is actually, what we actually doing here? Yeah. So one thing here, if you want to train a model, can you give text as an input to that particular model itself, that algorithm? I don't want to do this feature extraction and nothing, just text. I can't do that, right? I can't. So we have like techniques, these feature extraction, TF-IDF, bag of words, count of words, then bag of n-grams. So you are aware of all these things, what all these are, and how we actually do things, how we convert it to numeric form using these techniques. You are aware of it, or I want to, it's fine, right? So if I have a text, okay, some text like my name is Anuj. Okay, this is a text, and then I want to convert it to a vector, okay, or in numeric form. How I can do this? It's important because this is all related, so it's very important to understand this first, and after that we can switch to this one. So that's the reason I just want to recap all these concepts first. Yeah, that's fine. We have done the pre-processing. The pre-processing is done. Now we want to apply feature extraction. Mm-hmm. 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 Okay. Okay. I have two statements, and these are two documents, D1 and D2. Okay. So there are two things, like Anuj is common in both the things. So dictionary will have only just one Anuj for you, right? So how the data will look like, I want to show that to you actually. So first thing, it will be sorted actually. So first thing starts with, I'm just writing Anuj will be there, the first feature, Anuj, and then it's breakfast. And I'm just, yeah, words, or you can say these are the features actually. These are the features. And then is, okay, whatever, we can just mention it, something like these are the features, and then had also somewhere. Okay, these are the features. Okay, and then now if we are using bag of words, then what should be the value? Because these are the column names, actually, you can say that way also. Then if we are using bag of words, then what should be the numeric values here for D1 and D2? 1, yeah, that's 0 for D1, 1, 1, 0. So this way, this is vector representation, and this is bag of words. And now you want to do a bag of n-grams. That's very similar. Instead of just one word, we'll have like n-grams. If it's bigrams, then we'll consider 2 words together. If it's trigrams, then we'll consider 3 words together, and similar. So bag of n-grams is there, then count of words, it's similar actually, it's same thing. And then TF-IDF. Anybody wants to explain that TF-IDF thing? How we calculate that? So, in that particular document, okay. And what about inverse document frequency? So don't remember the formula, just intuitively, if you see that if a word is occurring like what TF-IDF does actually, and why it's considered the better feature extraction approach than these techniques. So we'll talk about that, and we'll talk about intuitively, not the formula wise. Okay, so first thing, like a word is occurring like in my one document like 300 times. Okay, and that same word is occurring like I have total number of documents around 500. Okay, and that word is occurring like only one time, only in one document actually. So inverse document frequency will be 500 by 1. Inverse 1 by 500 is document frequency, and 500 by 1 is inverse document frequency, right? And if you multiply these two things, okay, this is like a number of 300 times, and in this particular document I have like around 1000 words actually. So it's like just 3 and 3 into 500, but this number can be like here and there, so don't go with the number, but it's just the concept is like now probability or the distribution, that TF-IDF number is going to be greater, but in case that number or that word is occurring in all the documents, almost 500, in that case your number will be 3 only. So it means your TF-IDF value is decreasing. So it has less importance. But the word that is occurring very rarely in all the documents has very high importance. So that's very intuitively that I explained it to you without any formula. So you understand that now. Yeah. So this is TF-IDF, and once you have this vector representation, you input this to your models. And what all models you have used for NLP or text analytics? KNN, okay, and Navier. Okay, so this is the thing that I want to cover, because this is very basic for text analytics and NLP. So that's it from the recap session. Now we'll come here for today's session. So what are going to be our agenda for today? Okay, so we'll talk about sequential data, and then we'll talk about traditional ML for sequential data. So that's where I want to talk about all these things actually. I want to use all these things here actually in traditional ML for sequential data. And then type of analysis possible on sequential data using recurrence, and then RNN, recurrent neural network. We'll talk about why we required these RNNs actually. So in between, I just want to add one more thing. Before RNN, I also want to recap deep learning basics, because they are very connected to each other. And if you are not able to get basics right, you will not be able to understand RNN. So I'll just explain it like briefly here. I explained NLP, same I'll explain before RNN. But first of all, we'll discuss all those sequential data and traditional ML methods. And after that, if time permits, today we'll do the practical if time permits. If not, then we'll do it tomorrow and day after tomorrow, okay, for both the sessions. But today, our main focus area will be these things actually. So what you mean by sequential data? Anybody wants to answer it? Sequential data. Time series is a sequence actually. Yeah, you can't alter the time actually. What happened. You can't alter the time. That's sequential data. So yeah, he's also right. You are also right. Anybody else? Okay. So yeah, it's the sequence is important. So if I talk about text, because the slide or the topic that we want to cover is natural language processing with RNN and LSTMs. Okay, so if I talk about text data, in text, this is important. If I jumble the words, then it doesn't make sense, right? It doesn't make sense. And if it's difficult for human brain to understand this jumbled text, then you can think about a machine, because brain is more complex than a machine actually. So if brain can't understand the jumbled words, how a machine can understand? And here in sequential models, or we'll talk about sequential data first, and then we'll talk about sequential models. Why I'm talking about the sequence thing here actually. So you understand what sequential data is, and time series, like he said, that if stock prices are like today is like something, some stock like 500, and day before today is like 400. This all are dependent to each other. You can't alter all these things. These sequence also matters, because if you not consider this and you try to predict tomorrow's data, then you will not be able to. You have to consider this. So if you want to prepare a sequential model, you have to consider the previous instance for that particular variable. Okay, so same with the text. Text, you can't, if I have written something in English, then the text should be in a sequence. If I want to prepare a sequential model, so what sequential model? I have to talk about it right now actually, because sequential model is like something I want to predict. You are using WhatsApp, and when you write some statement, the list of words comes according to your WhatsApp that these can be your next words. So we are predicting the next word. Yeah. So that's a sequence. You can't expect like after my name, after my Anuj will come. It can't be possible, because it's a sequence how we write English actually. So a machine has to understand how we write English. It can't be something like, okay, we can jumble it up and then machine will understand, machine will make a sense out of it. It's not possible. So that's sequential data, and that's sequential model also. Like if you want to predict something that is sequentially related or related to the past instance of that particular thing, then it's a sequential model. So you are predicting something based on your past data. Okay, so same thing we have explained here. So it can be one-dimensional discrete index, time instance is character position. It's important, character position here in case of NLP. So point can be scalar, vector, or symbol from any alphabet. The one more example that I want to give you, like if you talk about there is a student who wants to learn differentiation, but before that he should learn algebra. Without that, he can't learn differentiation. So that's a sequence, right? So he has to learn that algebra first, and after that only he can learn differentiation. So this is sequential data. Example of sequential data, speech. Okay, I want to translate English to German. So there is a sequence. My model has to understand first what I'm saying in English actually. And after that only he can translate, it can translate it to German. So the sequence matters. If I jumbled up the words, initial words that I'm typing in English, then my machine will not able to understand what all things I'm talking about. So speech is one of the use case for sequential models. Because this is also important. This is going to be one of the factor. There is going to be like a lot of other factors, but this is the previous day. Yeah, previous day closing is going to be one of the parameter for that prediction.
Maybe the voltage will be less or high, but
Yeah, because the today's or the next day's this price will be dependent on this, the last day price. So there is a relation between two.
can unstructured data be sequential? Can unstructured data,
Unstructured.
data can be sequential?
I talked about like video. Video. It's a sequential data. Your audios, your songs, these are like sequential data. You can't listen to one word, like the last 30 second first and then first 30 second last. You can't jumble that up. So music is there, then protein, DNA sequence, stock prices in other time series. Okay, so these are the examples of sequential data. So let's talk about language modeling. Okay, so is the task of predicting what words come next. So I give you the example, like you used to chat on WhatsApp and then you get that the next word, what it's going to be. So here similar thing, we will just try to see how it actually looks like, what goes behind it actually, how we prepare that kind of a model. Mm-hmm. Recommendation systems can be of different things actually, because here from language modeling you have to have a sequential data. For recommendation model, it's not the case. Okay, so the task is the students open there and there are 4 options: books, laptops, exams, and minds. Okay, so these can be, I mean, whenever you are typing this and you'll see these 4 options you'll get. Okay, whatever you want to. So how you decide which one you want to type, or how your machine will predict which one you want to type in. So for that, what we given a sequence of words, compute the probability distribution of the next word. How you do that? You know that how you compute the probability distribution, or using n-grams. You know that, right? You have the concept of n-grams clear, right? So if I'm talking about n-gram, or here we can see we can go for like 3 n-grams or 2. What you want to do? 2. So, but 2 will not make sense because there will not make a sense. Students opened there, that will make a sense. So we have to go for 4 grams actually. Yeah. Students is important thing, because without student you will not come to know which one should be there. actually. Yeah, students open there, then we have to calculate the probability for that particular. So how you do that? You have a vocabulary. Vocabulary, it's just a dictionary of all the words, all the unique words what you have, and then you will count the probability for that. Students open their books, probability for that. Given you have students open there. So I just want to, conditional probability? You know the conditional. Given event, yeah. So I have like the students open, I want to calculate this probability, open there. I want to go with books. Given the students open there. So I want to calculate this probability. So how I can do this? So here their books, and then given the students open there. So that's a statement. We have given this thing, right? We already know this thing, and we want to calculate the probability of this books one only. I don't want to calculate laptops exam minds right now, but yeah, books. So how you can do that? So first you need a corpus of text actually. Like you can get a Shakespeare corpus or some newspaper corpus, okay? Large amount of text data actually. And then you will try to find this actually, this n-grams, number of times this statement occur in that particular corpus, okay? So like let's say I got it 300 times, okay? And this thing how many times? I mean, it can be 1,000 or something like that. So that's a number of, so that's a kind of a probability distribution. It's just, I'm not using the formula, but you can see this is the probability that I'm going to get, okay? So this is how you calculate books. So similar way I have to calculate for laptops, exams, and minds. Whichever of these words have higher probability will be, yeah, will be there in that they fill in the blanks. Yeah, with students open there, and if books has the higher probability, then books will be there, okay? No. Corpus is something that you have to pick. Corpus is something like you want to train your model, okay?
So suppose today send that word corpus
Mm-hmm.
open their books is 300.
Mm-hmm.
Maybe after some people write the similar sentence, it might be 5,000.
Yeah, that's fine.
My question is the corpus giving option
So
to get the probability or it
yeah, I can give you example. You are typing something in WhatsApp. You are typing good morning daily basis actually. So you are adding good morning daily basis on your corpus actually. So it depends on like WhatsApp, what WhatsApp is doing. So it's for you only. It's calculating the corpus, what kind of words you are using. So if you type something in somebody's else mobile on WhatsApp, it can be different. The number of suggestions that you are getting or the actual word suggestions that you are getting, it can be different. Okay. Any problem here? You understood the concept? How we are going to get this language model? So this is NLP actually. This is NLP and traditional ML also. And similar way we have to develop something in neural network. It has some problems actually. Yeah. So probability is this. So you know the formula of, I haven't used the formula actually, but you know the formula, right? Conditional probability. It's like if I'm calculating for P of A given B, then it's like intersection of P, A and B, and then PB, probability of PB. That's the formula. And if you calculate it, it's something looks like similar kind of thing, okay? So what I'm doing here, the student open their books. I want to know the probability of this, okay? Given I already have these students open there. I already have this, right? So what I'm doing, first I'm calculating the number of times this whole, these, let's say we can remove this one also, actually, they doesn't make sense. For we can just have students open their books. So students open their books, we can count number of times this actually happening in a corpus. Corpus is the text that you are selecting. You want to get it from internet, from some newspaper site, or from Shakespeare's novels. It's on you, actually. So how many times this information or this text is happening together, that's an n-gram, actually, together in your corpus, okay? Once you have this, you can also count the number of times students open their happening together. You can also count that, right? So if you just, I have just taken example, 300 times happening this, and 1000 times it's happening this. This is the probability that you are getting. So that's how you calculate the probability. So which word among these four have higher probability will be assigned or will be filled here in this. Okay, all clear? Great. So here you can see the example. So you do these kind of things. You know all this, right? Here also. So they are using some language model, but not language model. Not language model. They are using language model, but not traditional ML models. Okay, language model can be in traditional ML methods and can be in deep learning. So deep learning, we are going to talk about RNN and LSTMs. So they are using those. So how I learn? I already explained it to you. Now there is a question: how to learn a language model? Learn a n-gram language model. So that's what we did here, right? We learned that n-gram first. N-gram is a chunk of n consecutive words. It can be unigrams, bigrams, trigrams, or 4 grams. What we have used here, 4 grams, right? Collect statistics about how frequent different n-grams are and use these to predict next word. The same thing we did here, right? Good. So here the mathematical part, or just explained in this mathematical equations, but nothing to worry, it's a similar thing. Here you can see, first we make a simplifying assumption that depends only on preceding n-1. So n-1 depends, it means like here I choose this, students open there. These are the words the next word depends on. Before this, I don't have any dependency actually on my predictor word. So here probability of n-gram we calculated, okay, how to calculate it, and then probability of n-1 gram. We did it similar way here, right? This is n-1, right? This is n-1 and this is n actually. And how do we get these n-gram and probabilities? By counting them in some large corpus of text. That's what I told you, right? So it's clear now. So here also, statistically, this is an approximation of it actually. If you see here, this is an approximation. We are using the probabilities, but we are approximating it to count because it's very similar. The probabilities or the numbers that you get from here, it's going to be very similar if it's a large text of corpus of text actually. No. They have default corpus first. After that, whenever you start typing in, you started using it, then whatever word you are using are also getting added to that corpus. Yeah, so that's the reason your WhatsApp use so much memory or that space. So everyone is clear about this concept, right?
Same formula.
Yeah, it's the same formula. Whatever I have mentioned here, it's written in mathematical equation. So if anybody has difficulty in understanding that, can remember this also, because nobody will going to ask write these equations. Nobody will going to. Okay, so I have taken xt, right? And what I'm saying, I have to, I have a dependency on n minus 1 words. Okay, and t plus 1 words, I have to predict for t plus 1 word. I have to predict t plus 1 word. So now I have to move n minus 2 back, right? So t plus 1 minus n minus 1 actually. Okay, t minus, no. So it's t minus n minus 1 plus 2 n minus 1 words. So it is just that mathematical equation. Okay, wait. What can be t plus 1 and 2 minus plus. So you can, the first thing, that first formula that you are saying, the first equation, px of t plus 1 and then xt extends to x1. So it's considering all the words that are there in that first thing, right? And then in second thing, what we are saying that we will not look for all the previous words. We'll just look for the words from, like, if we are starting from this position, okay, if we want to predict this one, we'll just look back these three numbers. So it should be x of 3. If I take this example and I want to write that thing, so how I'll write it? So it will be like p of x. I want to predict this is like which word? Fourth word. It's a fourth, right? And given what is it's going to be? It's yeah.
Saying that x is for t plus 1 depends. So t plus 1 minus n minus 1.
So this is going to be like x4 I want to predict, and I'm using x3, x2 and x1. So just a mathematical equation, algebra thing, simple. Okay, so that you want to have before going, before predicting it. Anything else? Next, yeah. That's the same thing, right? Suppose we are learning a foreground model, okay? Open, yeah.
So let's say our corpus had a collection which always was about a dialogue or about a novel, like two people talking. Where let's say the word appeared as like students open, where it was never there. Open your mind, open your books.
Yeah.
It's like a communication tool. And now I have a case where the sentence which I have in front of me, students open there. The context is more or less the same. But then will the model product here?
No. So you have to carefully select. Yeah, that's the problem we'll talk about actually. There are problems and we will talk about all those problems with the traditional ML actually. So that's the reason we move to neural network. Okay.
I understand in the example.
If
it's n-gram, then that could be model that time cannot predict. But if it's a unigram, students instead of you, if they are,
that's on you.
predict something.
Yeah, that's on you, but actually, who will decide that you want to use this unigram, bigram, or trigram?
When we are designing the model, do we need to specify that we have to use n-gram so that it will cross through unigram, bigram, trigram, then n-gram, or it will just go for the n-gram means it will definitely go beyond 3 or beyond 4.
You have to check the accuracy. That's how you can decide which unigram you have to use, which n-gram you have to use. You have to try with multiple things.
N-gram definitely cross over. So when you am specifying model to perform n-gram,
Mhm.
that means it will perform unigram, bigram, or directly.
No, whatever you are mentioning. If you want to just mention like 4-gram or trigram, because you have to calculate these all things you have to calculate before. That's the reason I took that recap of text analytics, because in that we have to prepare that vector first. So that is part of feature extraction. If you don't do that, then you will not be able to train.
My question is, when somebody writing n-gram,
Uh-huh.
will the model perform first unigram, bigram, then move to n-gram,
That's-
or it will just jump?
Yeah, that's what I'm saying. So first thing, when you are developing a model, okay, what all things you have to do in text analytics? First is pre-processing, then is feature extraction. In feature extraction, what you will do? If you are using n-grams, you have to specify which n-gram you want to use. Okay, it's going to be 4-gram or trigram or bigram or unigram. You have to do at that point of time when you are extracting the features. Yeah. So that's the reason the algorithm will not understand anything. You are just providing the numerical data to that particular.
In that case, that's why when you're saying students open your the sentence change to there.
Yeah. Exactly. Yeah. Sorry, this n-gram. You can keep it. No. See, there are problems, and we'll talk about all those problems, and that's one of the problem. But theoretically, you can keep it anything, whatever you want, theoretically. And then we will face some challenges with infrastructure, how we want to keep that kind of a data with us. So there are some things that we have to talk about actually, what are challenges are there in traditional ML, and we'll talk about. Okay, so you understood all these things. So here we have explained it in by giving some examples. You want me to go through this example, or that's the example that I have taken, it's good enough? Everyone? Fine? We can move ahead? Okay. So now we'll talk about problems with n-gram. Okay. So first one, the one he pointed out actually, that we don't have that occurrence in that our corpus actually, whatever corpus we have selected. Now I want to calculate students open their books. Let's say W is books. Okay, WJ that you can see here, it's books. Okay, so I want to calculate that probability, but this students open their books, it's not occurring in my corpus altogether. What you will do then in that case? So, random assignment for that particular text. Okay. But once your model is in like production and you encountered something that sort of, okay, so in production what your model will do then in that case? It will get failed and it will not able to show what's going to be the next word actually. So because in that case your first count will be 0. I mean, so your accuracy is it's not there now, because you are using it for some purpose and that purpose is not met actually. So it's failure of your model actually. So first thing, that count student open their books will be 0 because that text is not exist in your corpus. So in that case, how you can solve that problem? They have given something, the partial solution that you can see, add small lambda to count for every WJ. But this is one of the thing that you can do. Okay. Apart from this, there are other ways also. It's called Laplace smoothing. the one that here shown, it's called Laplace smoothing. And what we do here, we'll just add, like in count, if it's 0, we are just adding a lambda there, and in at the bottom, count students open there plus number of words in vocabulary. Okay, we are adding that. Okay, it solves that problem, but it will not predict correctly. It will solve that it's not 0 actually. Your probability is not 0, but it will not give you correct prediction. A random number, very. Yeah. Exactly. And the first thing when we got this problem, what they have done actually, they added 1 plus 1, not lambda, but plus 1. Plus 1 divided by this. I can give you formula here. So it's count plus 1 and then count of the past tense, that's plus v. So they have done this thing first. Actually, they have added plus 1, but
Instead of 0, low probability. So then what result occurs? So
you are still giving it one occurrence in your corpus.
count will show 0. So that means just 1.
1 divided by the count of,
Number of words plus very long probability.
yeah.
If I look at my general experience,
Mm-hmm.
same occurs when you're writing a student response. Right? So then it waits for some pointer there, like if I type A,
Mm-hmm.
and then basing that A, it
Yeah. So they want to decrease that probability furthermore. So they said, okay, instead of 1, go for lambda. Lambda is very small number. So that's called Laplace smoothing.
So it just create a dummy sense that it is predicting.
Exactly. That's it. That's it. Nothing else we are doing here. Uh-huh. It actually says that you have calculated the probability of the next word, whatever you are predicting, but actually that whole sentence doesn't exist in your corpus. But you are saying there is some probability that this can happen. Where does it take? So I'm saying like books, W is books, and it doesn't occur in whole corpus. Okay, so what I'm saying, I'm calculating probability of next word. It can be book. What is the probability that the next word can be books? Okay, given whatever the previous statement is, actually whole statement. So here, if that particular, not books, but actually probability of W is students open their books. So here, count students open their books, the count of it. So there is no count actually, 0 count. And then you are adding some small value to it. And then after that, just adding the other count, students open there, it exists in that corpus. And you have some value here. But what if that students open there also doesn't exist in your corpus? And that's the problem, because you are dividing it by 0. It's something that's not a probability. So that's the other problem. Okay. So how you do that? But this is some kind of an example. Okay. So this same example, but you are like making sure that students open there is like a statement, and after that there should exist something. But it can be that we are just end 3 words of a statement, and after that there exists nothing. But yeah, but you think that with traditional ML techniques you can do that kind of stuff? Probability is not 0, count is 0. Yeah, means if you want, yeah, probability is 0, but you are talking about the count, right? If it doesn't exist, that students open their books doesn't exist, then it's 0, count is 0.
Then I can go and see, I don't have to go for the entire string as such.
Mm-hmm.
Take a subset of it.
So how you prepare your traditional ML models for text analytics? You do pre-processing, you do feature extraction, and then after that, in feature extraction, what you are doing, you are preparing a numeric form of, you are converting text to numeric form, and then you are inputting that numeric to your model. But if you want to do this, how you'll do that? You have to take care while you are converting it to numeric form. Yeah, that's the reason traditional ML doesn't work for sequence data. Yeah, it's on you actually. This is just example, okay? So if you feel like if I choose bigrams and it will give me better result, then you can go for bigrams actually. But sometimes we will have two here, because if we are choosing like we want to go with 4 grams, like we want to know the fourth word, okay, then we have to have trigram also, because that's what will be like used for as like to predict the fourth word. So we want to have trigram and 4-gram also. But that's 2 vectors only. That's the only input that we can use. And that's during feature extraction only. There only you are manipulating all these things. Yeah, you can't give something like 2 inputs to your model. You can't. You have to do it in feature extraction, and after that, whatever you probability you are getting, you can give it to your model as an input. All clear? Okay, so we didn't talk about the second problem, right? Yeah. So what if students open there, it doesn't exist in your data? Then what? Then it's a bigger problem, right? It's infinity. Probability can't be infinity. So there, just condition and open there instead. This is called a backup. So instead of going with like students open there, we can use open there. Just open there, but here we have to make our like this feature extraction this way. How we can add that? How we can, or we have to write a logic. Okay, if we are getting the probability 0, then go for like 2 grams, but with like just last 2 words. So that kind of a logic you can also write there on top, first one also. But how many times? If you are dealing with 4 grams or 5 grams, then yeah, it's like you are using machine learning, but still you are using a rule-based thing there. So you are not doing something that is very useful. So that's 2 problems, and then there is one more. So what's that? Need to store count for all possible n-grams. So model size is, you know the complexity, right? Complexity of a model. Whatever model you have studied, or feature extraction technique, PCA, if you have principal component analysis, yeah? You already done that, right? So you know the complexity level for PCA, that kind of stuff, right? There. So similar way, it's also a feature extraction technique. So here, the complexity is exponential of n. N is number of words that you have in your vocab. So to store that kind of a thing, it took a lot of science. If your corpus is huge, and for like prediction, you need that large amount of corpus. So that's the 3 problems that you face in traditional ML. You can have, theoretically you can have, but if you want to implement it on like practical basis, it's not possible. It will take, to train your model, it will take like years. Yeah. So recall the language model task. What? A sequence of words, probability distribution of next word. That's what we have done till now, right? So how about a window-based neural model? So the window, we are already aware. Window is nothing but what's the sequence, what's the last 3-4 words, and if we say like 4 words we have to consider, then window is 4 words. Okay, so we want to have a window-based neural model. So how we can achieve that? So you are already studied neural networks, right? So you know the basics. Anybody can tell me that? Okay, we'll not talk about window-based neural model first, but we'll talk about neural networks. Okay, so here you can see the fixed window. The students open there, so that's a window here. So we are going to use similar concept in neural networks, but it's called fixed window, not n-grams or kind of stuff. So it's like we have time. You will take break on 11, right? 11:30, 11:30, yeah. We have time, no problem. So anybody can explain it to me, this thing? Have you seen this kind of thing in your neural network sessions? Here are 4 nodes actually. Here are 4 nodes. This is just one node. And then we are getting output. I'll not explain a lot of things here on this slide because it's just that to give you information about what neural network is actually and how we can use that. We have just have it here, but we'll talk about the neural network first, the basics. We want to recap all those basics because it will make it possible for you to understand it more clearly, RNNs and LSTMs. So we'll talk about all those things. So here the thing that I want to talk about, this. Again, you can see that one hot vectors, and then we have concatenated word, and then we have a hidden layer, and then we have a softmax. What we call softmax is, what's this actually? Of this layer, this softmax function that we have used, what it is actually called in generalize? Yeah, it's activation. And what is this? Hidden layer, and generalize name for it. Aggregation function, we use aggregation function, right? ReLU is there, yeah, ReLU is there. But most of the times, we'll talk about all the, I'll recap all those things for you actually, because it will give you heads up what we are going to cover in for an RNN and how we can relate all those things, okay? But what about softmax? I want to ask about softmax. Anybody aware of softmax function? Yeah, it gives you the distribution, probability distribution. Some of it is one actually. So binary classifying, right? So here the same problem statement, and we got probability distribution for books, the highest actually. It's the highest, and then after that laptops. Okay, so the output will be decided by us actually, which one I have to pick. In WhatsApp, you only see 3 to 4 words in your suggestion box, not more than that. So what all words will come there? All the words which have actually higher probability will come there in your suggestion box. Books will be there, laptops, and then 2-3 more words, whatever having a higher probability. So let's move ahead and we'll recap. So here you can see improvement over n-gram. Here no sparsity problem, that thing. We'll talk about how, but right now just what all problems or what all improvements we are having here with neural network. Will not have that count is equal to 0 problem here. Okay, we'll try to learn the language actually. The neural network try to learn the language itself, and then model size or the complexity will decrease actually. Okay, so you don't need that kind of infrastructure that you require for like your traditional ML methods. Remaining problem, fixed window, it's going to be still there. Okay, enlarging window enlarges W. So this is like these are what W and U. Anybody aware? What we call it? Weights. Yeah, it's weights. So it increases that. never be large enough, that already mentioned. We don't share weights across the window. So we'll talk about this last point with RNN, because that's the property of RNN actually. Uses different rows of W. We don't share weights across the window. So now we'll start with the recap. Okay, so you have deep learning, right? You already studied neural network, and these are the areas where you are actually people are using deep learning, internet and cloud, maze classification. So in CNN, what practical you have done? I mean, what you have done in image based, yeah. So you did this image classification as a problem statement or image? Okay, so you are aware of CNN, how it works. You are aware of pooling padding. You are aware of pooling padding, right? Okay, great. Language translation is there. In language translation, it's with CNN it's not possible. So with RNN it's possible. Okay. Then language processing, it's again with RNN. Sentiment analysis, again with RNN. Recommendation, RNN again. Cancer cell detection, diabetic grading, drug discovery, these most of the things we are using RNN actually. CNN is image classification majorly, where we have input as image, because you know the yeah, yes. But for sentiment analysis, you have a text, okay, and you want to understand, okay, if it's written in English, you want to understand for whom they have written or for whom they have shown that kind of a feeling, okay. To understand that, you need that kind of a sequential model or language model actually, which can understand your previous words, okay. So that's where like this RNN, recurrent neural network, comes in picture. So media and entertainment, video captioning, video search, real-time translation, this all happening through this deep learning stuff and using RNN. Actually, not RNN. RNN has forms, LSTMs, that's long short-term memory. So you remember Gajni? Yeah. So that's kind of a concept they are using. Okay. Then security and defense, face detection. Face detection, you have to use CNN, right? Autonomous machines, pedestrian detection, lane tracking, recognize traffic signals. So these all are like already in place using neural network, these all things. So I guess in India, you haven't seen these things, right? Yet. Face recognition is there, your phone, your laptops, yeah. Video captioning, it's not something that as a normal people we do, right? So, but it's there. It's there in film industry actually. So if you talk about film, oh yeah, it's there in Amazon Prime. Whenever you are watching something in Amazon Prime, you'll see the members that are present in that particular scene and their information. So they are using doing that video captioning, but for the members in that, for humans that are present in that particular. Gaps, lag. Okay, okay. I haven't. Okay. Okay. I haven't seen that yet. Then I'll check that then. So that's like the areas where we are using deep learning. Okay. Again, the use case is different. Use case is same. See. And here the thing that is added: time series, log analysis, risk detection. So risk detection is one of the areas that is like we are using the area where we're using deep learning. Why? Because it's not, you think it's a sequential data or there is a pattern in something, you're doing? Huh? Risk detection. If you are working for a banking or financial domain, and yeah, it's people. If I have a credit card, okay, I'll do particular kind of a transactions only, okay. And if I go like and do some or buy something different from my regular transaction and do like 2-3 lakhs transaction, it's not my nature. It's not in my nature. That's a sequence, right? Yeah. So that kind of a thing also possible. Yeah, they give you a call and confirm, okay, whether you have done this transaction or not. So this is very important actually, because right now you are asking, in India it's not possible actually, because whenever there is a fraud on your credit card, if you call them and say, okay, this is a fraud, long time ago, I guess 5 to 10 years back, they will say, okay, what we can do, yeah, we can't do anything for you then. But outside, whenever you report a fraud, they'll give you that money back. That's it, done. But in India, it's very difficult. So now they are using these techniques. But 10 years back, it was not there. It was not there. But right now, it's there. And they are also, because they don't want to be in loss actually. So if they have insurance, but still they are paying something for that insurance, right? Yeah, insurance is there, but still they want to save as much money as they can. So yeah, no, it's everywhere. Everybody wants to be in profit, and that too. If they have a technology, they want to use that technology. They don't want to do go for insurance and do things like that. If it's like 100% foolproof, then they will definitely go for that. Why they will go for insurance and all? That's the challenge, because it's very difficult to uh, give that kind of a justification to higher management. Okay, if they are not into artificial intelligence or machine learning, if they haven't taken the kind of a course they should take actually to understand all these things, it's difficult. It's very difficult to give them that kind of understanding, okay, what's happening there and how neural networks are working and all that kind of stuff. It's difficult, but in future it will happen for sure. If you are getting that kind of accuracy, there are tests that can happen after the result. You see the result and you can see the accuracy also. And if you are getting 100% accuracy, why nobody wants to move to it? It's just that they need to learn few things more as a higher management. But the input that you are giving, that in control, right? You are giving it to that neural network. But yeah, that's fine. But the input or the features that you have given to neural network, that's decided by you. You know what all features are contributing towards that particular thing, and there will be very rare case where there is a mismatch in what the conclusion is and what actual result is. So there you can see at all the parameters what you have a pass for that particular transaction. You'll get the things. It's not that it's impossible, but it's like a kind of a tricky thing to do that. It's in decision tree or in a forest, you easily get all those information. Going forward with this also, we'll get something. So what we are going to achieve using deep learning, we are trying to do what? We are trying to create a brain for a machine. And you think that right now we are in a position to mimic the human brain? Even neurologists, they are not into like, they are not able to understand this complex brain. Even they can't explain how brain function actually. So we are trying to learn a small chunk of information, okay, and then we're trying to see, okay, how we can do how we can use this information and prepare a brain for a machine actually. So human brain, you know all these things, right? You want me to cover anything here? The last one, capability to remember and connect things. That's the thing that's different with human brain. With machine, it's not possible to remember and connect things, right? Agree? So this is artificial neuron. We are trying to replicate human brain, but this is just one neuron. You know the brain, how it works, right? So there are neurons, and then how the information flows and how this all triggers, right? So this is a single neuron. So anybody can explain it to me? And it was like proposed in 1943. So you can think about like it was there in 1943 and now we are talking about it. Why? So first tell me that reason. Anybody aware about that? Yeah, that's the one of the biggest reason. Yeah, computation. And other thing, yeah, data. Data is one more thing that these two things actually, because of these two things, we were not able to achieve anything using this, and we were not able to explain. And nobody wants to actually listen to all those scholars, because previously PhD guys or masters who have done masters in like this artificial intelligence used to work in this field, but nowadays this is changing, and now people are working, and there is a reason for that also. What's that reason? Huh? Yeah, the tools are available. It's been like 60-70% of course. And have you written an algorithm by yourself, whole algorithm? Have you? No. That's the problem. You should write that. You should understand the maths behind that. But to understand maths, it takes a lot of time actually. And he was right that he wants to do the full time. There you can actually do all that kind of a thing to understand the math and then try to write that whole chunk of code by yourself, not using the Python package or some libraries. Okay, but that will give you much more sense than just directly using the package or library. These are aggregation function and these are activation function, right? So we'll quickly go because this is just a recap. So aggregation function, integration function, this responsible for aggregating input signals from other neurons, control boosting, inhibiting, or completely suppressing the given input. These things it can do actually. And then most common integration function is the multiplication, simple multiplication, vector multiplication. So this is like weights and your input, right? God. Activation function. So first one is step function, right? You know that step function. If you are f is just input. If f is greater than 0, then activation function will give as 1 in step function, and if it's less than 0, then it will give as 0. So this is a step. Ramp function, you can see if f is greater than 1, then it's 1. If f is between 0 and 1, including 0 and 1, then it's f. So it's a kind of ramp. And then if less than 0, then it's 0. So sigmoid function, I guess everybody knows about it. So how to train a perceptron? So anybody wants to explain that concept? How to train that perceptron? You already? Okay. Yes. Can you draw it here? Because I just want it in blocks only. I don't want any vectors or something. Nothing. It's just the process, how it all works. We say it's back propagation, but how that back propagation actually looks like, the flow of it. Anybody aware of it? How back propagation works? The flow of it. You want to just blocks. Yeah, just try it. If Yeah, you can just start from here. Okay, this is your neural network. Okay, and then how you do things. Here is the input. So you optimizing the weights, but depending on what? Learning rate is there, but what you are optimizing? Mhm. Yeah. So what that error is, that loss function, that's loss function. And we are actually minimizing that loss function. So optimizing, you have optimization as a subject in the curriculum or no? No? No. Okay. So every machine learning problem statement is a optimization problem. Optimization means we want to reduce error. We want to reduce error. Yeah. So that's what we want to achieve. And in unsupervised learning, it's not the case. Because in unsupervised learning, we are not predicting anything. We are just segmenting something or clustering something. And there, what's the loss function then? Loss function, I mean, just intuitively, I don't want any formulas or anything, but it's just what you want to increase there or decrease there to get. No, not number of features. In clustering or unsupervised learning, what you do actually? Yeah, exactly. It's distance. You can say distance, but difference between two clusters. You want to increase that. So it's not you want to minimize, but you want to maximize that distance actually between two clusters. So that's also a optimization problem. Okay. So optimization problem cannot be machine learning problem, but machine learning problem is a optimization. Yeah, always, always. Okay, thank you. So I want to explain it actually in more detail. So how actually neural network works, and when we say like back propagation, what it actually means and how we are doing. So you, when you gone through this back propagation, how you gone through it? You studied mathematical equations or intuitively only? But when somebody explained to you, how he explained through mathematical equation or intuitively? They told you, but so how you calculate the minima? Loss function, I want to minimize my loss function. How you can calculate differentiation? Yes, partial differentiation, exactly. So you know differentiation. You want to talk about it mathematically or not? Or intuitively, we will go intuitively also. We can go. We can go intuitively, and after that we can come to differentiation because it's so important, a little bit important. Gradient descent he talk about, it's very important to understand that also, right? Because that's how we are actually minimizing the loss function, and then we are achieving the path, or you can say the shape of the data, okay? So first we'll talk about, okay, these are my input neural networks. I'm talking in blocks actually. So loss function. So you can understand these things, right? These are inputs, x1, x2, x3. These are inputs. These are weights, okay? And at the start of when you submit your neural network, when you start training it, so at the start, what should be your weight? So how you can do that? It's always randomly, or you can initialize it to zeros also sometime. Yeah, right? Random, right? So, but there is a problem always. There is problem always actually. If you randomly allocate it, there are chances that because you are selecting learning rate also, you are selecting you are randomly selecting these, there is a chance that you skip your local minima if your learning rate is too high or your weights are too high. So in that case, you will not find that local minima that you want to find as a loss function. You find the minimum for that loss function, right? So that's your whole purpose. You find that minimum for that loss function. So that's the whole purpose of a neural network. whatever you studying here. That's the whole purpose. Scenarios can be different. It can be CNN, it can be RNN, LSTMS, GRUs, but the major, the thing that you want to achieve, it's to minimize that loss function and to get that minimum loss function. It depends. No, there also you can select random also. Yeah, random. There are different ways to optimize that also, because it's very important step, because if you have a data points, okay, and you want to predict the shape of it, or you want to model it and you want to predict it, you want to minimize this or the errors that you are getting, you want to minimize. From where you want to start, it's very important. If you want to start, you start from the midway only, then you don't have to travel much. Your training time is very less in that case. But if you are like starting with zero zeros, then it's going to be like take some time actually. It's always, you have to keep in mind, you have to try different combinations. So that's I guess the challenge with neural network. You have to try multiple things, and after that only you will be able to see, okay, which combination is giving me good accuracy actually, minimum loss function. Okay, so what I want to explain here, this is your neural network. It has like hidden layers, input layer, output layer, everything. Once I got the output, I have a loss function. Okay, loss function can be RMSE. You know that, right? Root mean square error. So you have predicted values also, and you have actual values also. You are just calculating this root mean square error, and it's in a function format actually. So let's not go into mathematical equation. First we'll explain intuitively, and then we'll go into mathematical equation. And once we have calculated it, okay, so we have to calculate using differentiation for sure. How to calculate minima? Differentiation and is equal to 0, and then you will get the point where it will give you minimum. That function will give you minimum value. Okay, loss function will be minimum. So according to that, whatever values you are getting, so I can explain it mathematically with simple example actually. X square 2x. Okay, this is my function. Okay, let's say this is a loss function. Okay, and when I do differentiation, it's 2x plus 2 is equal to 0. If I have to calculate minima, I have to do this, and then minus 2 divided 2, it's minus 1. So x has value minus 1. Now this loss function is a equation of like weights. Weights are there, then learning rate are there, and then inputs are there actually. Inputs and then outputs of hidden layers actually. So I will differentiate it on basis of my weights, because I want to change my weights. So whatever weights according to this you will get, you will back propagate it to here or to your hidden layers also. You have to give it to all the hidden layers proportionally. Whatever like error, if you got here you are getting 2 error, one is in this hidden layer and one is in this hidden layer, then proportionally you have to divide the weights also to the different hidden layers. Okay, and once the weights are initialized again, the process will repeat itself, and till the time the loss function is not changing actually, you have got the local minimum now. The loss function will not change now. It's a fix now. It will be there for. So that point of time, you can stop your algorithm, or your model will stop learning. That's it. It learned. So that's the basic, intuitively how the neural network works. But in traditional ML, is it possible to do all this? Yeah, exactly. We don't do all this kind of stuff, right? So this is, you are using simple command in Python to implement this like neural network. But behind that command, there is a loss function, there is a back propagation, there is hidden layers, everything is there. Yeah, if you want to check that code, you can check that code also. Go to GitHub for any particular library, whatever you are using. You can check that and try to understand what they are doing with the code actually. This is optimizing. You are optimizing this loss function. When you are doing differentiation, it's optimization. You are optimizing it to minimum. Yeah. Anybody have any doubts can come to me. We can talk about.
Yeah, in the interest of time, let other guys join. We'll start it. So here also, when we talk about, so far we talked about the feed forward networks, and one variation of the feed forward network we spent good amount of time. What is that? Till now is CNN. CNN is one, and which has very good application in case of computer vision, right? Now if you understand this recurrent network, again our standard practice of we need to understand what is this, even before what is this, why we need that, okay, in which situation we can use that, and what's special about that. Then we'll go into, so don't worry about this complex equations, you will easily get that. That's my duty, within 1 hour you can get that what it is, okay. Then we'll practice one example also, okay. So let's understand even before going to this deck itself, okay. So I use two terms, right? One is on a spatial related one where we can use the CNN type. Other one is something like temporal, okay. Let me start with the simple examples, okay, to establish when we require this. If I talk about, okay, we used to play these riddles, right? If I say 1, 2, 3, 4, then question mark, what will be natural answer after that? Okay, and we can be tricky also, right? 1, 3, 7 question mark. If it, okay, you need to identify the pattern in that, do some math, and it will not be visible what is that one, whether it is a multiplication or some division, there's some complex operation you are doing it, and some people enjoy that also, those riddles, okay. But if I give only 1 or 2, can you get that sequence patterns? Difficult. But if you have sufficient information, then depends on your IQ level, some may be cracking it within a minute, some may be cracking it 10 minutes, that is a different story, okay. So that means whatever, in case of images or in case of any of the decisions, we are not talking about the importance of the sequence. If I talk about one image, I am talking about classification of that, whether it's a dog, cat, or maybe whether it's abnormal, normal type of it. It doesn't have any dependency on the previous one. But you may say the same thing. Can you think of some situation just like I'm talking about number, there is a sequence, okay, or some kind of like a weather forecasting. Is there any temporal sequence in that to predict the weather? All the time series, okay, let me put that way. So before even doing this deep learning approach of the time series, what are the techniques you are familiar with? If I give you some time series data, okay, so what are the techniques you are familiar with? ERIMA, very good. You are talking something else? Exponential smoothing, yes, okay. Some regression methods, or ERIMA is a combination of auto regression and then moving average, okay. You notice some traditional techniques are already there, but we are talking about how do you solve these approaches, okay, with the deep learning. That's what the thing for us for the next 2 hours for us. So in this also, whenever there is some kind of a time series data, so does it need to be always numbers? I talked about sequence, you are able to predict it. Now I am talking about weather forecasting, you are agreeing that there is some numbers and all. But does it need to be always numbers? No, right? Okay, can you tell me any other example? Speech, very good. Speech, images also, if it's kind of a video frame or this one and all, there is a sequence importance is there. Okay, then music, speech, music is also, and nowadays even we can produce automatic music also, right? Now comes to the text, that's what we'll focus on. So text, what kind of example you can tell me? Chatbots is one good example, okay, but that is maybe I will take chatbot after some time. I'm talking about, let's start, because chatbot needs to require a lot of knowledge, okay. Even building a chatbot is also one good application now, okay. So I'll talk about where the maturity and all that maybe tomorrow I will talk. Today I may not get time on that, but in the text also, let's start with a simple example. Yes, very good example. Yes. So the word filling you are talking about. Yes. I will take the same example even in our class now to establish the need for the recurrent networks, and that too there are different types of recurrent network. Maybe some of you heard the name of this crazy. When I heard that first time, I was crazy. We are talking about long short term memory. What is long? What is short? Correct? So I can understand if some people who are hearing for the first time looks crazy, and that I told you, I recommended you to say that before even deep dive into the first focus on the words, you will get the clue on that. Okay, there is also a lot of clue. We will justify that what is there in that and all. Okay, but even before going that, first few minutes I will talk about general recurrent networks. Then we will establish what is the need for the little complex networks like this. And there is something called GRU and all, gated recurrent unit and all, but at least in the interest of time, we'll cover only one of them. That LSTM is good enough, much popular. And after that, your end game tomorrow should be what? I will throw you some real world applications. You should tell me it's not like only either or type. There are applications where I use combination of LSTM and CNN. Okay, so that's keeping that end goal. Let's learn, because CNN you have some comfortable understanding now. So the same level of understanding let's get from LSTM. Then tomorrow we will talk about real world applications, in which situations I need to get, what kind of applications will help me to understand that. Okay, that's our end goal. So if you start with this, so here, okay, recurrent might be looking like as complex as this. In our regular network, it looks like straightforward feed forward pass type of it, right? Okay, so but this one is not as simple as this. Okay, so it will be looking very crazy like this. Okay, connections backwards and all. We have a lot of applications. You already told, I need not go again on that. So let's understand a little bit on this further, where first let's focus on RNN. Then I'll go to the, I have this picture even again, I'll talk about that complex what you are talking about here. Okay, so this is more like, here you already have what, for anything, suppose if I take a hidden state here, let me take a different color. So what is input here and what is output here for this particular node? Input is coming from the previous layer and going, that's it, there is no recurrent connections. What we are talking here is, if I have a connection back to here, okay, so that means if you see in a time series manner, because anyway if you relate that to time series, you can easily understand it. Okay, so one way, say just putting that recurrent, just like if I can relate it to your recursion, how many people remember the program recursion? In one line we are doing it, but if I want to explain what is recursion, it's more like what? Maybe for loop of 10 times it is doing in that recursion. Okay, or maybe multiplication can be explained with a sequence of additions. The same simple methodology you can see here, where the recurrent means there are some time series. Okay, how much it is to be, how long it can be? That's the next question. Okay, so the recurrent networks, we require the recurrence, but how long? Okay, that's what we'll see with the examples. But the simple understanding is, we'll talk about this later. Okay, where this will fail, I will come to that. I'll establish my point in next maybe 10-15 minutes. Then we'll go to the complex thing like that. At this stage, we'll ignore that. So, let me take it, because I want to spend, I can take any example of a weather forecasting or stock or this one, but I want to intentionally take the text, because we will not get too much time if I miss the text here. So, sentiment analysis, you guys know. Okay, what do you mean by sentiment analysis? Whether it's a positive, negative and all. Okay, is there any real, is it like a academic project, or really there is any use case for the industry? Feedbacks, exactly. Okay, there are so many people who do the crawling of these websites from this one, that takes even decision in their long-term strategy also. Okay, so that, yeah, financial, or maybe let's impact on that. And even let's say the mobiles, or what needs to be the next mobile version, because they are launching every quarter or every year, every quarter nowadays, right? So they have, there may be some road maps in terms of what people are praising about, what people are cribbing about of a particular model, so that the next version should be solving that. Otherwise they can't increase the sales. Apple do that, but they have a what you say, reach to a level, then it will be difficult to cross that, right? The expectations wise also. So Apple is Apple. How many cribbing, say how many cribbing videos came, you have seen when new version comes, right? Okay, so because it was a good hit in the beginning, now what is happening, the expectations also, we want some that delta. Okay, the delta it is not able to. So that's the reason I'm seeing my view, because there may be, if it's a business class, people will be in. So but when the initial iPod comes, or maybe initial iPad comes, or maybe initial iPhone comes, that is tremendous. Okay, that's a different. But the same level of tremendous difference we can't expect at this stage. Now it's a game in terms of capturing the market and and they want to reduce. I think 2 days ago they were saying they want to reduce the prices again in India to capture the market and all. So they captured initially even because once they exhausted in US, what happened in US? If I remember still once in San Francisco when I'm traveling in a train, nobody looks for the next phases. And when I just had a glance at that, when I'm walking from one compartment, 98% of the people are taking the iPhones on, no other brand at all. Okay, but they will use, even if I see my clients who are coming from there, they still use iPhone 4, iPhone 5 also. Okay, so what happens? They need to throw that and then get the new one, right? So then robust is also there. So when they do a frequent release, it can't impact that market. Okay, it may impact other markets. Okay, that's a business related. Let's come back to our deep learning part. Okay, so the reason I am talking about is there is a good use case of this, and it's not a solved problem, but it's a very old problem. Okay, now just like you are talking about a Hindi English, the same thing. It is more prominent for us to see the Indian version for this. In the sense, English it may be a little bit solved, but when you talk about the same thing for Indian market, because why we need to worry about it? Because $1 billion of market, right? So that's why people are talking about Indian languages, whether it's a speech or text and all. Now I have these sentences. Can you see by just seeing it whether it's a positive or negative? I wish it had a longer battery life. Positive or negative, sentiment wise. Let's say positive is +1, negative is -1. You will put the sentence as what? -1. Like that you can see for other ones. Okay. So now if I am putting that into my RNN, okay, I can't put the entire sentence. Let me take the tokens as 5 tokens I have taken. Okay. So now what I am doing, 5 tokens at a time I am giving it here. So whatever the highlighted portion, can you see here? By 5 there is no fixed rule. I am talking about I can't give the entire paragraph on this one. I want to go in a step by step. Okay. So now the same things I am putting it into here into a self loop, and let's see how it works. How I am giving, like I want to show it to you I just want to take an example, and whatever the picture I have shown it to you in the beginning 2 slides ago, how it works. The same things here. If I take 5 takes here, right? I wish it had longer. That is the 5 words. That will be the first input. Second input will be what? I will be removed. Wish I had a longer battery. Then next will be what? Wish will be removed, and next one. Like that it can continue. Okay, it can continue for multiple paragraphs. So what I am giving here, this is the input, and for the moment if I ignore there is a recurrent connection, that means there is a previous state coming. If these are independent, let's say sentences of 5 words. Okay, let's see that first. Okay, if you see here, or let me see this one. If I take this as an independent one, there is no hidden state recurrent. First word is what? I wish it had longer. It looks like a positive or negative. I wish it had longer means it doesn't mean negative, -1, let's say. Second one, wish I had longer. That is also -1. What about the third one? So if I ignore the I wish and all, it had longer battery life is a +1. There is no doubt about it. Okay. But is it really the message that way we want to convey? No. So if I talk about that, the recurrent one, what is happening? There is some previous hidden knowledge also I am carrying it. It's not like an independent statement like this, which is like never any text analysis. So what will happen? I will expect some answer like this. Maybe -1 in the first 2 cases, there is not much difference. It's always negative. But this one, it doesn't look like a completely positive one because I know there is a history coming to that, which is -1. Maybe instead of 1, it may say something positive. Not like completely. But how do we arrive at 0.25? It's not, I just want to indicate a number which is less than 1. There's depends on computation, it may give you 0.1 or 0.25, depends on the network learning. So this is just to establish, because you are already familiar with the sequence of the numerical one, even in the text also, this kind of importance is there for the sequence. Direct image processing you can do with the CNN is a good option. But if I talk about a CT volume, I have 200 sequences. Okay, that way it makes sense. For individual image, it won't compete. The CNN is a good one to do it. But to combine that in a temporal sequence of images you can take. Good. Okay, you got the point here? So then I want to, this one I have some good interesting graphs for you where to make my point clear. Initially I don't have this kind of, I have only static ones. So now I have got in some other conference, because I haven't created all this. It has there in this one, I want to pull together so that I can convey my point. So you can see what is happening here. This for a simple RNN. There are not complex gates, nothing LSTM. I have similar diagram for each of the gate, each of the formula what I wrote here. I will convince you in next 1 hour. But here what is happening? Just tell me. This is just to describe how the RNN flow will be. Okay, I given more or less the references also most of the places. If you want to further refer, you can visit that. So what is happening here? This is like individually what? These individually the nodes, correct? And what are these? I talked about text and suddenly I jump to here. I am continuing the same example though. Now you need to think from, say what are the techniques you remember, we remember in the first class itself, at least I don't know the previous background what you have. Computer understand only the word vector, the vectors, okay. So there are, for matrices, for text you have different methods to convert it. You know some methods already? What are the methods you are familiar by this time? The account vectorizers, TF, IDF, word2vec also you heard of it? Okay, very good, very good. So I do have 1-2 slides. If you have some gap anybody, I will just cover that, but otherwise I am assuming at this stage you know some kind of a techniques to convert it. Once you convert that in the same sequence of a 3 words here, okay, maybe the vector size, I am just giving this as an input like this. What is happening here if you see, can you see the flow here? The simple graph, this is coming from the hidden state, this is coming from the one is xt, one is ht like this. Okay, this is for the LSTM formula, don't worry on that, but if you see on that, previously you have what is the input into weight plus bias. The same thing works here also, but only thing is the weights part of it, okay, is there, but input wise is not just only one input, but it has even the t-1 state also. That's why you see the combination of all that. So if you see the formula wise, it looks like familiar only, right? It's the same as activation function of input into weight plus bias. I haven't changed the fundamental rule of that. Only difference is you have, instead of the just a simple x, you even have a dependency of the hidden state. That's what I want to show in a beautiful graph here saying that. Can you see here? This is coming from a, let's say this is input and that is input. Both of them are going to an activation function and then that is going to the next one. That's what the sequence of operation is going on. Once you convince, then I will go for the next next point. But any doubts here, let me tell you, clarify at this stage. So what I am saying, if you see here also, right, I am giving input for each node. The sequence, just like you have I wish battery or next one I removed I and then next 5 like that, I given inputs for each of them. But what is happening in each of the input is the below diagram saying that maybe I can take this one. This is the hidden state coming from previous one. This particular one, yeah, is coming as an input. Both of them are joining and passing through an activation function. Okay, and then that is going to the next input. So when next thing happens, what? This will be hidden value coming from hidden ht-1 and again another xt will come. Both of them are going again in this kind of a formula. Yes, that is also there. Many people may not know, that's why I haven't started using those, but yeah, they have. LSTM has a complex thing than this. It's a simple recurrent network of the state. I haven't used any complex F, T, I and all. We'll tell you once this is the simple weather forecasting or simple sentiment analysis, it can do it. As long as if you have kind of a Twitter kind of a data. Why I am talking about Twitter kind of a data? Because we have only short sentences. But the moment I go for big paragraphs, you can see the complexity of it. Okay, that's what I will establish now, saying that the simple recurrent network may have the dependency. Okay, that's what giving it to the advanced recurrent network, different types. But for the basic ones, as long as the distance, just like you are telling an example of who are you, okay, next my name is, okay, maybe this one. After my name, based on the gender, it can auto-populate he or she. So that means the distance between the prediction and all, as long as it is less, then RNN is good enough. I don't require complex memory, remember, gate, this, that and all. Simple recurrent network will be good enough. But when I say the next one, are you clear till this point? Okay. So before I go to the next complex issues and RNN establish the point, let's understand different networks here. Can you see the picture here? Maybe little dense, but don't worry, I'll tell you what the different types are. How many types are there? 1, 2, 3, 4, 5. 1-to-1, this kind of a vanilla mode of version. What do you mean by that? Fixed size of input to a fixed size of output, some kind of image classification. Okay, here it is not even RNN, I will say. It is just simple one, right? Simple classification type. Sequence out, image captioning takes an image and outputs a sentence of words. Okay, this is talking about, second is a one-to-many. One image you are getting. So actually speaking, in the image sequence, even though I am talking about here, that may be a good point of little after the explanation of LSTM, but let me tell you because it's coming here. For image captioning problem, that's one of the challenge even that goes in many conferences. You can't play with only LSTM or only CNN. To do the image processing, you need to do the CNN. That's what you are familiar and agree with that. But after that, you will get a keywords, and after the keywords are finally, the captioning means what? If I throw some keywords, will you accept as a caption? It needs to be a proper, what do you say, sentence. Okay. So if I'm talking about this picture, what could be the caption? People sitting in a class, attending to a session or something like that is a meaningful sentence. To do that, CNN is not a good player there. CNN can identify you, yes, there are persons, okay, or 10 people. Those kind of objects it can detect and then classify. Those things it can do. After that, we need to use again a sequence of words as an LSTM. Identified, and for that you need to use again a LSTM. So it's a combination of LSTM, and this is what I was telling in the beginning. If I throw you some real world problem, something like this, you should be able to tell me. Okay, some points are coming now, but tomorrow we need to converge all that. Okay, if I tell you new problems, yes, these situations I will use LSTM, I will get these things, or this situation I will use CNN. We use some new problems also, but this is one clue for you, image captioning. Yes, so how many people understand the question? What you guys talking about? CNN, let me rephrase the question so that I will get answer from you itself. The CNN, is more like a true false type of a question. CNN can be used only for image classification, not for detection. Is it a true statement or false statement? CNN can be used for image classification, only for image classification, not for detection. False, correct? So the CNN wise, you can use the application wise, it can be a classification or object detection. Both of them, the approach wise and the network wise is not different. Only thing is the flattening and the last sigmoid and those things will be different. Okay. So in this particular example, to just convey the next point for you is, we are not interested in the classification type. In the picture when I take on captioning, I'm not interested in that. I'm interested in the objects what are there. From there I will, and I want to even flatten and use any sigmoid. If you can just visualize the network there, I will have some couple of convolution layers and pooling layers and all to extract the patterns and identify some object. Okay, these many faces are there, maybe these many female, male, whatever it is, to whatever extent we want to do that. Okay, maybe laptops or the chairs or there, this and all, right? So from there, these things will be fed into a LSTM kind of a network. Okay, then that will give a sequence in terms, because it's trained already on the sequences. When the combination of laptop, chair, this and all, it's kind of a classroom. Okay, otherwise if it's not trained on that, it needs to depend on some other wiki or some other APIs are also there, public API, Google API, Wiki API. I still remember some time ago, I want to use it, do some kind of a topic modeling. Okay, so I have some keywords coming from even the basic clustering. You are talking about some clustering thing, right? I'm not talking about complex deep learning, machine learning and all. I have some words, okay, some tickets and all the stuff. Then when I do a basic clustering, I got some, even in K-means also, if you can see there, the words you can identify. I don't know whether you really explored that. Top 5 words, you can take it from the, for each cluster. Just explore if you have not done it. You know how to do the K-means clustering? You might have done already, extracting the top 5 keywords. Now I want to combine those 5 words and give it more. I can't give a top keyword as a label for that. So we used to give that, let's say the cab, then travel, this, that and all. If I give it to a wiki API, it will give me this related to the travel or transport. That can be a better labeling. So why I'm talking about this? You know all this in multiple phases. So now you need to do this one. Don't expect to build a complete one network to solve your purpose. No one can solve a real world problem like that. So here it's a combination of like network, just like we're talking about CNN followed by LSTM. Even LSTM also within that place, if you want some kind of external APIs like this, you can use it. Okay, and finally you need to get your problem solved. That's the approach. Then sentiment analysis can be like this. Sentiment analysis where given a sentence is classified by accuracy. So here what I am giving so many, just like the example what we talked about here, I am giving multiple sentences. Finally I am expecting a single output, positive sentiment, negative sentiment. Okay, that is, so you can understand one to one, one to many, many to one, and now many to many. Machine translation, or now the translation also, I think I might have mentioned the code previously, from Sundar Pichai, when he mentioned 10 years of their research of ML of the machine translation is taken over within 6 months by the DL. Okay, so that's what the many to many. I am giving sequence of words, and sequence of words should come out. And synced sequence input output, that's what the video classification, where we wish to label each frame of the video. Sometimes the sequence matters more or less, but synced sequence also, asynchronous and synchronous, not much difference there, but depends on the application though. So in your real world, you can map to these applications. If you talk about, let's say, these are the 5 different combinations available. There are 5 different data types or 6 different data types for me. You have your domain expertise. You may not fill all the entries there, but you will get n number of applications from them. Are you with me in that? We'll talk about some more applications tomorrow. Okay. Now let me talk about, in the interest of time, all of you appreciate the requirement for RNN. Now let me talk about the limitation, which will boils down to the LSTM type of network. Okay. So where it do have the vanishing gradient problem, because when you talk about single network itself, it has a vanishing gradient. Even a recurrent network should be a natural problem. Okay. Then this BPTT is nothing but back propagation through time. So now it is the same approach what we was talking about, error propagating and all, but it will be little complex. That's why if you remember that time, yeah, not really. Now, if you recollect what we have told, even that there is some impact on that FP32, FP16 and all, but I'm not talking on that precision point here. So here when you say vanishing gradient, when the error, say what we are calculating the single word, if I am talking about, I have an error function, I am calculating the partial derivative of the error function with respect to the weights. Okay, so that I am trying to adjust the weights, how much it is deviated from the expected output. That's what I am doing. So what will happen is, when I will calculate only for end level, this is what my input is. Okay, I have a partial derivative and I got something like a 0.1 as an fraction which I need to change my input. That is here. After that, when I am multiplying, it's a chain rule. You remember? So 0.1, let's say another 0.1 here. 0.1 into 0.1. 0.01, 10 power minus 2. Like that, if I back propagate till the 10th layer in the beginning layer, it will become, let's say, 10 power minus 10. So it is not really adding any value change in the weights. That's what even if you fix a precision level of FP3216, that is the same, the vanishing gradient problem still will be there. Cut off in the sense, if it is not even within that, that's what they will already do it. That's what they are doing it. But only thing is, as a network, you see, it is taking many epochs, but it is not doing any change for me. So that's what, if you remember, one way of discarding it is with a fixed number of epochs. Put a constraint saying that, okay, 1000 epochs you run. But sometimes I already mentioned to you, if you remember, it's not like a small examples where it will run in a lab like this. One convergence for us taken a week on a GPU. I can't change one parameter and aram se go for a week and come back. By the time 1 year will be over without any improvement in the model. Okay, so we should be smart enough doing that, even though because I know it takes that much time to converge, I should be able to identify the pattern of it, how much change it is happening, so that I can cut it forcefully and then change this one. That's what we do typically. But there is no single one answer for that. Okay, on what basis I can say one technique what we used to follow is the change within the weights is not more than, or within the iterations is not more than, let's say, 10 power minus 5 or 10 power minus 4. I will put some threshold. Okay, then I will cut it out after 5-6 iterations. Yes. You can change that. That is a different dynamic way of changing the learning rate. That's one impact only. I'm not talking about only one. That is one case. Even in that case also, I'm talking about that's kind of an adaptive learning rate you are talking about there, right? That's okay. That's one way of changing it based on the identifying the pattern. One way, smart way of doing it. But I'm talking about one way saying that I don't want to continue 500 iterations if I know that my patterns are not in a way that it's converging within 100 iterations itself. I don't want to waste my 600 iterations, or main specifically epochs, let's say. Okay, I want to cut it out and tune my parameters and then run it. Early stopping is for different reasons. Here, even I am not even converging it. There, early stopping is for one of the reason for avoiding the overfitting. Okay, after that, okay, I don't want to again do it. It's not improving. That's also not completely different, but there's a little different purpose. Okay, fine. So then results that, okay, using BPTT is also nothing but back propagation through time. The same concept through time dimension is also there. Then find out a composition of many nonlinear transformations are there. Okay, so here this established the same point in terms of, okay, the same point as you are saying, the clouds are in the dash. Naturally you can say sky, it's not require much of them, but the understanding is it's little obvious as the gap grows. Okay, let's say I grew up in Karnataka, I am fluent in dash, or you grown up in Delhi, you are fluent in dash, means naturally the Hindi will come. But that may not be true. Some people are laughing. Okay, even I don't know Kannada. I'm saying I'm from Bangalore, but I don't know Kannada. Punjabi, yes. So on what basis I can say? Okay, so the one I am talking about is here I will say based on if I have only this much information, but you need to focus on the dots. Okay, so I may talking about your own biography or writing. You started somewhere here and then in between you told my parents are from maybe Tamil Nadu or maybe you are Punjabi or whatever it is. So you need to make, and finally after let's say 1-2 paragraphs or maybe after 100 sentences you are talking about I speak fluent. That means you need to bring the context from different sentences and then you can predict it. Something different. So what I'm bringing the point there is, here when the gap is small, you go for RNN, you don't require a complex LSTM. But when the gap is more, how much more? I'm telling in the beginning of the biography of Sachin Tendulkar, let me talk about he's from this end. At the end of the biography of the book, I'm talking about this. It may be as the gap is that much huge. But can I remember everything in that book and then do it my justice? It cannot be, correct? So that way this kind of long short-term memory kind of aspects are coming, where how to solve it? The simplest way is, this is one of the approach I am talking about. I need to have some control on my recurrence. Okay, that's achieved through some kind of a memory and gate. So by default, if someone asks you RNN has by default a memory, yes or no? No. Memory means where it is remembering.
Here we there's a 3 parts. Okay, so 1 at least remember the last 2 states.
H2, I am not remembering, I am not storing that value anywhere in the gate. It is using the previous one. You are taking the, but it's not remembering, right? Both are different. You are using both 2 inputs of that. You are using 2 inputs and computing. Once I go to the next one, I'm not remembering what it is, correct? So explicitly now I want to introduce some cell, okay? So that's where this complex thing is coming up. It looks crazy, but believe me, within 10 minutes you will buy in what is there in that, okay? So what is happening here is, it looks like some complex. Let me explain in a simple words first. What is happening there is, my purpose to come to here is I need to have some memory. We can think of, okay, I'll put some memory unit and then do the same operation, just a memory unit. But I need to have control on the memory unit, how much to remember, how much not to remember. That's where the long short-term memory, it should be long enough, but at the same time short enough. Why? Because of other computations, because I can't keep on putting all the junk there and then expect some good results. Okay, it should remember the long sequences, but even it should be short enough so that the memory will not be exhausted. So that's a complex problem to start with. So the simplest way to explain this is, you already know the basic what node each one, right? So let's say a node means what? Activation of input into weight plus bias, correct? Maybe if I put in the same notation, X, W, B. This is what our independent node is. So think that what you are seeing here in the yellow color, okay, how many of them you are seeing here? Maybe 10H you leave it as activation function, but other than that 3, right? 3 sigmoids. That means it is a 3 independent nodes you can think of. It's a wrapper of multiple nodes. LSTM actually, okay. There are other variants of it and LSTM also has some variations of it. Let's not talk on those. But at least to understand one framework which is little advanced than the RNN, let's focus on one version of LSTM where you are talking about there are, let's say even if you consider this tan-H is also, an activation is also a layer. We talked about that. It can be combined to a dense, but otherwise it can be independent. If you leave that, there are 3 gates. Can you see that? 1, 2 and 3. Okay. So then there is some kind of a pink color is nothing but what? Some kind of a simple point-wise concatenation or maybe multiplication. Something like this is kind of a multiplication, this is kind of a concatenation, or this is also concatenation. This is a simple operation. So, and this is nothing but 3 gates. We can't call it, we will confuse if we call that as again nodes and all, right? We call it as LSTM as a node. In that node also internally we have 3 small nodes, but the name for that is gates. Okay. So as the name indicate gate, that means it is having it can close the gate, it can open the gate, so that the relevant information can pass through. But the gate means what? Somebody, let's say there are 3 gates, the names also I will tell you. Forget, input, output. These are the gates. Gate means what? It is doing the gatekeeper job of -1, +1 type of it. But somebody needs to control these gates to get the final output. Okay, this is something like a conveyor belt in the top you are seeing. Okay, that is called a cell state. I may be introducing a lot of them, but don't get confused. Within 10-15 minutes it will be clear. okay. As of now, and I have a beautiful diagrams to make my point, okay, but at least now you just see the static image, okay. Then I will, or maybe because some places, some of you are little blank, I will first show the graphics, then I will explain the concept. But at least let me just tell you there are 3 gates, and somebody, let's say these are like gatekeepers. They will understand if you think the same example of it. I will take a simple example to convey my point as well. These are gates 1, 2 and 3. Whatever the sigma you can see here, these sigma are the gates. Even tan H also kind of a gate, but it is anyway one activation, not a yes. And sigmoid is also, these other places it is kind of a sigmoid, okay, activation, but it's kind of a gate, and there is a cell state, okay. So now, before even explaining this and all, let me show you the graphs, how it works. Let's see first one of them, one at a time, even though there are 2, let's first see one of them. Can you see here? A small graphics going. It's simple as that. This is the first time, okay, this is forget gate, this is input gate, this is output gate, just for the namesake. And we will understand each of them independently. What is happening here? There are 2, let me repeat, okay. Just like t minus 1 and xt, passing through a sigmoid function, okay, and then going to some pointwise operation. Is there anything crazy there? Nothing. Just like in RNN, you are passing the xt and ht minus 1 and through a sigmoid function, what it will do? Okay, if it's a soft sigmoid type of it, maybe 0 to 1, but otherwise 0 1, a hard sigmoid means maybe 0 1. Okay, 0 means forget everything, 1 means remember that. Even if it is taken 2 states, that's why it's called a forget gate or maybe remember gate you can talk about. What is happening there if you see that? I will convey my point in 3 ways. This is a graphic, then equation, then I will summarize with an example as well. Okay, it's a simple operation, just taking 2 inputs and then passing through a sigmoid function. Now let's see the input gate. It may look little complex, but let's see. Let it start. Okay, can you see here? The same which you passed through here, it is going through here also. Okay, and it is passing through 2 activation functions. One sigmoid, another one is tan H. Okay, so typically here we use not the ReLU because ReLU has the inherent problem of 0 to infinity. It's not controlled one. Okay, that's one reason I could say that. There may be other reasons, okay, but at least one of the reason, even though it is very good for the CNN hidden layers and all, here I don't see a common practice to use it that as a function. Okay. Sigmoid we have a valid reason because I want to do a gatekeeping operation, 0 or 1, that makes sense. If you want to make a decision of okay hard sigmoid, I don't want to remember. I want to remember or don't remember. If that is the case, hard sigmoid type of it. Okay, so tan H is a common one. Tan H, what are the values between -1 to 1? That means I am not doing a decision of 0 to 1, but I am giving a importance of that. Okay, so the same, maybe it is little dark here, but anyway, this is nothing but what is the previous cell state, what is the output from here. Okay, so you are just passing through these 2 activation functions and then you are concatenating here. That you are passing through, actually this is gatekeeper operation is what, nothing but it will decide what to pass through, but final actual say this should go to a final output. Can you see there are outputs, 2 outputs, one is a long term memory, other one is a working memory. Here even in the RNN also, how many outputs are there? Is it 1 or 2? RNN, let me go back, there are 2, not 2 of it, but why we need 2 now outputs? Because I'm increasing the complexity of that memory thing in that, right? Here there is no memory. I want to understand how much to remember so that when I say all this, I am from Delhi or so and so and all, I am fluent in. If I want to tell that, somewhere just like our human brain remembers that context, somewhere it needs to remember the context. Okay, that's why it is, one is a long-term memory. You can see one is long-term, short-term. That means that's the reason the name makes sense, even though it is a crazy combination though. One is for the long-term memory, other one is a working memory. That's what the short term constitutes. I can revisit also, but let's see the first one. Okay, before cell state, then output is what? The same. Okay, let me just close this. Yeah, it is starting from here, whatever comes here goes to a sigmoid function. Okay, and it is getting another output from here. Can you see here? That means whatever is updated from the previous forget gate and already gatekeeper job is what? To decide what to do it. But final thing, what is persistent in long-term memory is there in the cell state. That's what the conveyor belt is doing. It is taking the inputs from the gate and then doing the operation. that operation also will go directly like this from the input gate, and for the hidden state also whatever it comes, it goes from another activation function. So if you see here operation wise, this input is going for an activation function, but whatever the output so far from these two, how much to remember, how much to input, that is also coming from for me in a 10H. Finally, that is going as a working memory for me. So now I understand you have still questions, but let's take an example, then it will be more clear for us. So the example is like this. Okay, let me start here. This is like a conveyor belt, this much is there, okay. It's not like a, so we are using two terms. One is the gate, operation of the gate is what to allow, what not to allow. But somebody else to monitor all this, that job is done by the cell state. Okay, that's what the top one you can remember. So now if I take an example like this, let's say, okay, the forget gate is simple, right? Where the same formula I will revisit later, but what is happening, there is a hidden state and xt, and I am passing through a sigmoid, I want to remember or forget. That's what it is doing. Now the same, 0 means get rid of this, 1 means you remember this. Let me take an example where now I am talking about something. When we see a new subject, we want to forget the gender of the old subject. I am talking about two people. Okay, you ask a lot of questions. You are working in let's say the insurance industry. She is working in, let's say, the finance industry. Then maybe I am just talking on one sentence each. So I am doing the context switching so frequently. Okay, so the next one should be he or she, means if in my memory, if I am talking about something he, it will automatically talk about the he, his, her, I mean not her, he, his kind of thing will come. So when I see a new subject, we want to forget the gender of the old subject, correct? So how the things are happening there? In the input gate, for sigmoid anyway, it's kind of an input layer which will decide what to do, 0, 1 type, okay. Then in tan H layer, the vector of the new candidate CT could be added to the state. That tan H, I am not making a decision making, I am just taking a value of the importance of the value for this and then passing it to that to an action in the cell state. Here, in example of our language model, we would want to add the gender of the new subject to the cell state. In the forget gate thing, what happens? Let's say I am forgetting, previously I am talking about a person he, that needs to be forget from this, that will be 0, let's say. Now I need to add the new subject. That new subject may be again he or she, a person, he or she. Whose responsibility is that? That's the responsibility of the input gate. We would want to add the gender of the new subject to the cell state to replace the old one with the new one. Okay. Here we are doing, whenever there is a sigmoid, I am making a decision whether I want to ignore or continue. In this particular case, I want to switch. So naturally, the forget gate is ignoring it. Its output is 0, and input state it is adding it. There is a lady. Okay. So use the new subject as, and so that you can predict she for the next one. What the LSTM is cell state is doing till now, the job of forget gate and input gate is to say whether it is a 0 or this is a 1. Actual operation it is not doing, it is just getting the things and it is inputting what the new subject is. The actual operation of that is happening in the cell state. That's what it is happening. Now the last one in this one is the output gate. Now we need to decide what we need to output, and how many outputs are there here? 2 outputs, one for the long term memory, okay, one for the working memory. Long term memory and working memory, both they should have impact on the new subject or not, because I switched the subject. Okay, so the forget gate will take care of, okay, ignore the old one. Input gate will push in that, okay, there is a new object that will needs to go the cell state. That's why if you see the cell state 1, okay, if you see here, whatever the operation that will go here directly, and that will again come as a tan H1 to make an influence even in the here also, output gate. In simple words, in the, okay, even it looking like very complex, what I am doing is just a suffixes of forget, I for input, F for forget, O for output. For each gate, the same formula what you are familiar with. I just added, because for RNN it is very common to have input and even the hidden state. Only thing I added the notation wise is F here, I, O here. Okay. So in the forget gate, even you can say it, and opposite way of telling is, it is telling me how much to remember or whether you would forget, whichever is easy for you. In case of I, how much to input. I want to input only he or she as a one object or maybe little more than that. Then output will tell me, okay, with this one taking care what to remember, what to forget, how much to focus, what should be my focus, so that now the focus is clear. Okay, I am not again worrying on whether he or she, that is taken care. Now I am talking about the next sentence. Okay, he wants what, maybe based on the context. I want to predict that one. So cell state, anyway, we have something, and there are another important point is in RNN we have only one output. Here we have both long-term memory and working memory. That's what the justification for long short-term memory. It's more like long-term memory plus short-term memory. Both of them are coming into together, and LSTM is a combination of that words. Now you can see one more time the graphics. We talked about equations. Okay, we talked about one example of a changing an object. What is the importance of each gate? Now see each one of them, one after the other. How many gates we have in this one? In LSTM, if someone asks you how many gates you are familiar with, you can say the simplest version has, even they have something input modulation gate, some complex things or some variations of it there. Don't worry on that. At least the base version which you are familiar with the LSTM, at least 3 gates are there. So there is another variation of it, people call it as a GRU, gated recurring unit. Okay, I haven't included that, but just for as an add-on, why I need to get 3 gates, I will do the purpose with 2 gates. Okay, some optimal version of it and all they have done. That's what the gate. They also have the same concept of memory and all. Instead of 3 gates, they fused it into 2 gates. But that is a recent one. Now people started using it, but more prominent one, at least you should be familiar with, is the LSTM. If you are comfortable with this and if you want some performance improvement, if it is really happening, then think of that GRU as a takeaway. Even if you don't get, no problem at all. That's why I haven't added any slides on that. Okay, even I have otherwise comparison of all that, and that will be too much. Okay, so at least you should understand there are gates and there are cell states. So the cell state, and when somebody talks about it, it's like a conveyor belt. Okay, where it is taking from these gates, which is getting filtered. What needs to remember, what needs to forget, or what needs to be the new input. That's the job of the gates. Once the gates are there, somebody needs to take control of that. That's what the cell state is taking care of it. So if you summarize all that, in this particular case, just cell state, this is the new input and this is the hidden state going forward to a red is what? Sigmoid or tan H? Sigmoid. So that is remembering whether 0 or 1 type of it. Okay. After that, the same input is passing through the input gate. Okay. Here, sorry, input gate is here, right? You are passing both of them here. That means this will tell me the same input like this. Okay, where whether I need to forget or this one, and this will tell me what is the new object coming into picture. Okay, and both of them are combined here. That is passed directly as a cell state. Okay, next state, and because it has another impact even on the output. What to focus? Okay, what to focus means just the same thing. He or she will be taken care here as well. But after that, I need to convey something, right, as a prediction or this one, that will taken care in the working memory. Okay. So similarly, the what to focus is coming in here. So one sigmoid function, one tan H function. Okay, if you see here cell state, it is getting one operation here, another operation here, which is passed directly like this, and even one other operation here as a belt. So it is little complex, I do understand, but still if you remember the pictures at least, it will be able to convey the point. Okay, but nobody asks you internally, okay, write me the equations and all, but these equations are required for us at least to understand it's a logical sequence of whatever I learned so far. Even though if you first time if you see that, will it look complex or not? For anybody, even for us also, even when we learned, nobody taught us, even it's kind of a self-learning, plus when we applied, and now if I have time, I will show you crazy visualization of LSTM. Looks crazy because this recurrent itself is crazy, right? Okay. So because the visualization of GradCam itself is okay for you, you are able to appreciate because it's a simple 0, 7 and all, where it is concentrating and all. But now if you think of this one, how crazy it is, I will show you one. At least depends on time, how much you will run one example, and after that we'll go to the visualization part. There's open source from Harvard University. It's a good one. You can spend at least 5 minutes, I'll spend, rest of them you can explore it further. But you got the crux of that? Okay, if I recap those points, you need to understand, okay, I think slides wise I have that much. All the learning what we had in last 40 minutes or this one is just one model.add of LSTM will do that. Okay. But we need to understand, why we need to understand these gates, this, that and all is just to run example. That's why I was telling you, even the teenager also will be able to do, because you don't need to understand all this. For him, what there is a open source code and all, they make sense of that, okay, and they will run it. That's it. But why we need to understand this one is whether LSTM is going to do the good purpose or GRU, or maybe how much we need to use, what kind of, you are more think from a design perspective, okay. What kind of layers I need to concatenate, how many LSTM, is not just only one LSTM, maybe multiple LSTM layers do I need to patch in for my purpose. Those are the things we need to understand what is happening inside. No, that's a good question. So somebody asked me, in this one, you are not telling me how many sentences I need to remember, or what is the content. Am I interested in his complexion? Am I interested in his speaking ability? I am not talking on all that. But how we learn what to forget, what to zero? You already accepted, okay, sigma will 0, 1. But how it will do? During the training phase, what will happen? I trained with without training, I'm not just jumping into the real world and then doing it. The responsibility of the training is, this is the entire document. Your biography or my biography, that doesn't matter for us. I am giving an input and it is, I am learning on top of the data. Okay, so that even when you talk about word prediction or this one, I trained on something there. Okay, sun rises in dash. Okay, even we trained our kids to tell that one. Somebody told it. Similarly, the training should be there on the common sense and all this one, because it's the only thing missing for us in the AI. We are telling about AI 2.0 or 3.0 we are in. What is lacking is that common sense. Once that is there, like in movies, we need to fight with them or we need to work with them. Other robots or software robots or real robots type. Okay, but it takes long time to go there. But what is happening there is it is the response. I can't hard fix saying that you do this, you do that and all. But you have control to give the data that way. Based on that, it identifies whether I need to remember the last few words or this what to remember not. That's smart enough there. You are not hard coding anything on that. That's why it is smart. Okay. When you peel it out, it is not as intuitive as CNN. We need to spend some more time. Okay. So, but I thought, okay, 2 hours is the one which we typically spend, because otherwise I need to cut on other topics. Okay. But if you are really interested in LSTM, I have much more, another 1-2 hour material on that to cover. But at least you should be get at least the base one. Okay, that's why tomorrow I not park it too much, last 1 hour. So I will leave it to you. So you want me to tell whether you are interested more on this image or text or this LSTM, or no, I am interested even in the GRU, I can talk on that. Yes, I have one example there. Okay, but example will be, after talking all this complexity, it will be one line and then running it. Okay, because that's what it is happening. Say in CNN, at least you have some addition of layers and all. Here I am talking about only last 1 hour, I am talking about only one layer, only model dot add, the same thing. Model dot add and tell, you have control of telling whatever there is a hard sigmoid or normal and all, you have control on that. And it will do the purpose. Okay, but once you take a big complex operation, okay, then you have control in terms of design, whether I need to put LSTM at what layer. Okay, whether I am talking about a small beginning or middle or maybe multiple layer, that will be good exercise to do that. We'll run one example because I talked enough. I need some break for you guys also. Okay, so we'll run example, then we'll come back to that. But are you clear on at least, say, the 3 points you should be clear. Our fundamental thing of why we are using that, you should be clear. Why we are using RNN should be clear, and at the same time, why we need to use the LSTM kind of thing, where it is complex. And that too, time-wise also, computation also will be more for this. But do I need to, does LSTM always surpass the RNN? Always, is it a de facto standard? Need not be. Because if I talk about the gap between the prediction based on your purpose is small, I don't require this complex LSTM stuff. I can reduce the factor of, a fraction of operations when it is a normal, RNN. I have these many operations to do that in the LSTM. But in case of RNN, maybe here it will go with instead of xi comma, maybe xt comma ht minus 1. That's it. So how much of order of magnitude the computations will be different? At least as good as RNN. Yes. It's more like, okay, even with the small, there is a saying, right? Even with the small, don't use a small stick even for, some saying was there. It's like a big stick, okay, if you want to. Yeah, someplace it is like there you can't do it anyway. Here you can use it, but only thing is depends. Say, that's why these are like, we are trying to give you the building blocks for you. But because I am working on that, I am trying to append with the why question also. Otherwise, just to learn what is LSTM, nobody require as a person to teach you. Okay, there's a good amount of videos, good amount of information is already there. So that's why we try to make it interactive and then make it coupled with example, so that your thing is it will register in your mind. You know when to use what. That's the should be a key takeaway. That's why I always don't miss on the why part. Only what part will not suffice, and I don't require to be a mentor or a teacher for you guys. Okay. So the main part concentrate on why part, and even if you have some gap in what part, you just read some material and all, you can easily, I have enough references there. Okay. Otherwise, the other AML batch, for each of them, they are talking about 16 hours, CNN 16 hours, RNN 16 hours. With some more examples, we will get something like that. Okay. But I'm ready to share the information, whatever you have. One is references. Other ones, what are the material I have, also have little more than this. You just shoot out email, I can share it to you guys, no problem on that. It's nothing like a proprietary material and all. So I don't claim everything on that. So maybe my style may be unique for me, that's it. Otherwise, it is, every material is there in that, and mostly I won't take credit for that. Typically, I will give the references. Okay, so that you can, even the beautiful graphs what I took, I haven't used for maybe 2-3 batches before. One of my friend only used it in one conference, then I took the reference from him and then I started using it. Okay, so I keep learning from there and I keep sharing that information. That's what we should be a continuous learner. Okay, now switch to the example. Okay, so all of you, can you open your laptops? So what we are talking about here, I have 2 examples. Okay, to run from the text point of view. Let's see if we can run. Maybe let's talk about the step 2 in the deep DL experiments. So all of you, for your information, the same example, I haven't shared any new examples for you. Okay, the same information what I shared to you. This is what I shared to you guys, right? Maybe a month ago, this is what the information we shared to you. Okay, this is already run. The step 1 also we run first example, still the second example that will take maybe hardly 5-10 minutes. We'll see when we can run that. Let's focus on the step 2. In step 2 also I have 2 examples. One for CNN, which we already run it. That's for the CFAR10 data set, right? Remember? Then the second one, I will give you a brief introduction for that. It's a real use case. The CNN example, don't try to run again because it will take a lot of time to load and all, because your computational complexity will be more in that. So we have 40 minutes. Okay. So all of you are with me till this point? Okay. I'll talk about something on the NLP, even if you have some gaps and all, it's my responsibility tomorrow to fill that gaps. Okay. But here also I'm assuming some basics as you will be knowing, and then we'll start from there. Okay. All of you are with me in this your example? So what you need to do here in your version, something like a merge is there. Can you see here in this one? Merge, MERG, merge is there in your case. That won't work if you, in the latest version, because that is deprecated. Okay, just remove the merge. We don't want that merge now. Okay, there's only one change you need to do, and that's it. Let me tell the context. And this has a dependency of one file. Can you see that file? Somewhere, can you see this one? Textdata.csv. Do you have that file with you? I think I already shared that. So all of you have run your Keras, TensorFlow. You should not get any of those errors now. I'll be surprised now because we already run 2 examples. This is the 3rd example kind of stuff. So all those things should be taken care. If you have some issue, we can talk offline in terms of those installations or anything like that. So can you see this data? The data is little dummy. I mean, little dummy in the sense it's a created data, but the application is a real world application. Can you relate to what this by seeing the structure of the data, what it is? Where from we get these kind of things? Some kind of issues or ticket. That is the bread and butter for our Indian IT industry. So you can apply to any company or any client, doesn't matter for us. It's an internal or external, correct? That's why I took this example. And so many people extended this also in your previous batches because it's very common and then to do this one, right? So let me give the context there. So how do we get this one? Maybe your Jira or ServiceNow, SNO, whatever or your proprietary one, you can just download on a particular category. These many incidents or issues are there. Okay. So what is our interest is I'm giving a small example portion here, but this is inspired from a real world project where we are talking about maybe some 6-7 years old example, this one, or maybe 5 years old example, this one. But that time it is very new, but now it's democratized already. So our aim is, if I am working with one of you, your client, let's say you are my client, and I want to identify the tickets, what I can automate from you. Right now I deployed 5 people to solve your issues. Okay. Now your question is, what kind of innovation you can bring it to me? I don't want 5 people, or my SLAs are violating. Okay. So what is the natural option for us? Okay, 5 people are not getting, maybe I need to add 2-3 more people. But is that the trend? That was the trend couple of years ago. Now what is the trend? Are you getting the problem what I am saying? I am coming to you as a client, or your client is saying you, or your boss is saying to you, I want to improve my SLA. That can be one situation. Or I want to reduce my costs. Do whatever the technology is not, I can't linearly add the people and get the thing solved. That's what the real situation we are in. So what are the options for us? Apart from adding the new people, we need to use the technology wise. So one approach in that one is, we want to deep dive, slice and dice using this ML type of things on. But you can question me, you already have what is the type of category, subcategory, subcategory also it is there most of the cases. It's not like I won't expect the organizations to be dumb. Before I do some text processing and all, already the category means what? Maybe here I am talking about software. Software, then open source, Java, .NET. Even in Java, whether it is a Java runtime or this one, I can go till that level, right? Already that kind of categorization is there, and those many tickets are coming. You can tell anywhere how many tickets I am getting for open source related requests, how many tickets I am getting for Java related requests, how many tickets I am getting for a particular application. Is it a real rocket science there? That is already available. But still, why do I require a text processing here? Just follow me little more, because I won't talk this kind of example when I'm talking to a students type, because they don't get the picture of the industry. But you are all having good experience, right? So when I'm talking about, the problem is, I want to identify the good automation cases so that I can offload to something to the robot or software robot. Okay, so that the people can focus on other important tasks. Okay, I can throw you some example if you are still not convinced. There are, at least I was involved in thousands of scripts, okay, where we are able to move hundreds of people out of their day-to-day activities. They were used for some other purpose. Okay, it's not just only 1-2 cases. That starts from simple password reset to granting access in Oracle system, or changing the permissions in HR system or SAP system across. Okay, it's a wide application, this one, and only thing I can't give the names of the client. That's the only thing. Okay, but it across the domains. Now, in your organizational side, because it's a little old application, I'm thinking already some automation might have already done. I'm not questioning on that, but still there is a potential to do that. So, how do you identify the cases without much manual effort, so that your technology of deep learning and machine learning can play the role? That's what the problem we are talking about. Is it relevant when we are talking? So, but what I'm talking there is the category and subcategory. I can say that, okay, Java category of the subcategory, they have some 500 tickets because there are a lot of volume is there. Okay, automate that one. Can it work that way? Are you getting what I'm saying? Before you classify something on this side of these labels, I already have categories in this one. It's not like a dump start for the organization. They are rich organizations, IT savvy organizations from last couple of years. But I can't use that directly for my automation journey. The simple reason I can give you is, some may be generated from auto-generated from a server, some tickets. Some may be a root cause may be different. Root cause may be what? Some physical disconnection happened from in a server. Because of that root cause, how many tickets might have come there? Somebody says that I am not able to access the DB. Somebody will say my app is not accessible. This is down, that is down. That may be boiled down to n number of different categories. One for database, one for web server, one for app server. But the root cause is what? Physical power issue. Or let's say Oracle DB crash, not the physical related, something crashed. Or memory, some bad jobs are getting maybe failed. The memory overconsumption happened. Okay, so all this journey started for multi years. What I am talking about, all real examples, at least where I am involved in personally also, where we started with the statically identifying based on the statistics. These are the cases. Some of the cases even we done a proactive thing also. In the sense, first you identify where the problem is. If you can automate it, okay, let the problem happen, and then I will correct it automatically. I don't require a human intervention. The other thing is, if there are something like a bad job failure and all this one, why should I wait some bad job to get failed? Already business discontinuity happened. Can I do a predictive action with all this anomaly detection and all my machine learning, deep learning, and do a corrective action then and there itself? So memory is overshooting. Okay. So, and I could predict it that it is going to fail, the bad job is going to fail if I don't add memory there. Okay. So log that event and then add that, and they should be accountable for all that. I can, okay, just like I identified and then add the memory and then who is accountable for that? Okay. Everything is documented again, logged. But there also you can question me saying that if you're, you may not accept directly my statement. Already there are so many server alerts. Are you talking some rocket science here? Already server, there are so many apps on the servers, whether it is HP or Dell and all those guys. If the memory is overflowing of 90%, do we require a DL to do that? 20 years before itself, they can claim that what you are talking about. I have some alerts to do that. Then what is the value we are bringing here? Am I making sense when I talk about? I am giving you the hint and I am giving you the challenge also. I buy in some point. In the interest of time, I am not taking too many things from you, but because we need to complete it. But the main point here is, if you remember any time on the server's operations in this one, it is kind of a big, kind of a cricket match type of it. In the big wall, you will have thousands of servers, and this is people will be crazy looking at those and where the issues are there, color coding and all that. If you ever seen any operation center, okay. So there, a typical poor guy will get thousands of alerts. What he need, if I can reduce the 1000 to let's say 100, I am making his life better, so that he will attend those. Say 90% of making memory is not a big deal. I already have the alert for that. But like that, I am getting hundreds of alerts. How do I know that which server I need to concentrate on? If I follow the patterns there, on a weekend, there is a job happening on a regular job patterns are happening, where that 90% is a real alert for me, for a server 1. For server 2, it is a regular pattern, you ignore it. So that I will concentrate on the server 1 instead of the other servers. I'm just not adding so much of value just by, so what do you say, the new thing, but I'm trying to do it in a dynamical fashion. Not just only one parameter, taking parameters from multiple things, and I can identify using this machine learning and deep learning the patterns. Make sense? So this is a very big application where, why I'm talking about all that for 5-10 minutes is you can relate it wherever you are connected with. Okay, it's not like you need to do the entire gamut of that applications in that. Okay, they have predictive applications, they have even you need to identify your organization where it stands for. Then you can define next step. You already done this one. Okay, my aim is I will take the challenge of this this one automatically, just we are saying monitoring one. I will reduce by 10%. Even that will save a lot of time for the manual effort. Okay, you can take step by step. Now that's the background for this. And now even where we start in that is, you already have labels here. Can you see this? These labels are actually a step. Initially we started with a clustering kind of a problem, because I don't know how many clusters to do the automation. Okay, and that too not based on the category. I am taking the summary and the resolution and those kind of things and then grouped it. Okay, and there is some manual effort there. Initially we started with clustering and cluster evaluation and all that. Finally we done some manual effort also. Finally we arrived at some labels. Now what I am talking about here is, how do I use this, okay, to do my further classification kind of thing. So simple classification with the text data. So let's see that example. Then I can take a few more questions. Okay, all of you open that. So I will go line by line there. Okay, some of them are very easy. Okay, let me see anything which is not acceptable import in this particular case for you. Just see, have a glance at that. Anything new there? There are some things new. You should tell me what is new there. These are all just system logging and all that stuff. Not much difficult, I hope. Yeah. Here, you know both sequential and modal. Okay, two approaches. Okay, we'll use one of them here. Here, you know activation, dense, dropout. Okay, flatten. These are all there in the convolution. We don't require all of them, at least for this particular example. That's okay. Merge, you just remove it. That is deprecated. It's not required. LSTM is maybe a new one. Correct? So these are utilities, optimizers, pandas, then cross validation. These are all the existing ones, right? From your machine learning, you are doing this. Now tell me the next function, what it is doing. Is this a function? Yes or no? This is the function name, load data from file. Okay, maybe I am using that in the text underscore data.csv, I'm using it. But what I'm interested in that? I'm interested in the summary, and output column is labels, that is that index 1, 2, 3, 4, and maximum features of 300 I'm taking. Okay. So now something new may be coming. So in the sense, I'm just loading the data using the pandas. Okay. So I'm taking the summary into that, and this is the one you should tell me if you are familiar with this, what I'm doing there. So it can be count vectorizer or what to vec or TF-ID vector. What is the output from here when you see? TF-IDF is converting that into, we call it as a word embeddings. Okay. Even if you have some questions tomorrow while I am talking about NLP, I will just recap. If you are familiar with this, I am happy. Then I will pose more questions in the real world, what to use, when to use what. That should be our takeaway for that. Okay. I don't want to repeat what you already know. We'll just start from there where your understanding is. But at this stage, okay, you are converting it into that word embeddings. I have the vectors now. That's what okay, here it is actually vectorizing, and actual thing is happening, the conversion is happening here, fit transform, correct? Then I'm just converting it into an array. Okay, labels are already there. I'm just encoding that because that's 1, 2, 3, 4. I'm just encoding that there. That's it. Okay, as a string type I'm talking. Initially, what is that name? 1, 2, 3, 4 is there, right? Label index. I'm just making it into a string. That's it. Can you see that training parameters? A bunch of parameters. So this is what we have seen. We already, this is how many examples we have run by this time? I think 2 we already run. So initially, I don't have this kind of a pattern of defining all that. If you see the first example, I just want to make sure within 5 lines of code can I build a deep learning. Now we crossed that stage. Now as a standard practice, we need to see it's always good to define the parameters at one stage so that it will be easy for us because the Python is very popular and but it's very crazy when it comes to the debugging. If you don't do the comments, at the same time, if you use you can define parameters anywhere. I bet you if you do that your own project, what you have done here, if you refer after 6 months, you don't know when why you added it all that. Okay, so make sure you have a habit of at least what does that mean, and follow the standards. That means keep all the variables at one place. These are simple things as a good practice for you guys. Okay. Even we have nightmares when somebody is debugging Python, somebody else's code will be a nightmare. I'm telling you. Okay. Typically in the GitHubs, we do have some good practices they follow and the documentation. That's why. Otherwise, if it is just namesake, if somebody uploaded, we can't. Even to change one line, it takes a day. Okay. So those are the mostly I'm not talking on this one because if you are not familiar with any of them, you should tell me. What is the maximum features, by the way? You remember in the TF-IDF there is a document and then terms. Okay, those are terms. NA50, yeah. Okay, so all that dimensions and all. Okay. Now here, if you can see, this should be very familiar for you. What I'm doing here? Just I'm calling that function load data. I'm doing a test train split. Okay, how much is the data? Just 50-50, but typically it's a 70-30 or 80-20 is the standard practice. Okay, that's it. I'm not doing anything new here, and I'm printing that whether it is coming or not. Can you run and see whether you are able to run that? Just remove the merge and you should be able to work. I'm also running not in my machine because I took 5 minutes before the class at around 9 o'clock to run this one, and only error I got is only the merge because I'm also hoping the same version you are using. If you get any other errors, tell me. Sorry, we're able to run till this point. Just you loaded that and into that, and now you are building a model. We'll run one example. Add graph and all there with the merge and all we don't require. That is an optional one for you because we are concentrating on LSTM because I want to show you even CNN also we can use for this data. But whether it is really good for us or not, I'm not talking on that front. Okay, this is not the best what you say in the architecture or for the network, but we can use even CNN or LSTM for this, even for the text data. That's what I just want to show it to you. Okay, so in the interest of time, that I will leave it as exercise. That graph. Can you see here? Can you see this line here? Can you see this line? I'll come to that line, but there is only one LSTM you added. But typically, even a graph means I created a subgraph using a CNN in the border portion of it. Okay, but there also some merges used only that one. So we need to do. You can just comment out. I will tell you if you want to run that also. But at least now, everybody should before we break for lunch, you ignore the graph. Anyway, it's commented out. I think even in your code, right? Correct. So at least let's understand the simple structure of this with one LSTM and how it is performing. then we can take another approach of that as a graph as well. Let's see from here. You are able to run till this point, all of you? Okay. Now I am just printing the dimension of the input and output. Okay. This is where the network will be. Okay. Maybe 1 month before you have seen, I doubt whether you have relooked it into after that, but let's see how much you can make sense in that. There are 3 actions happening there. What is this first one? And what is the other way of, instead of sequential way, there is another way also. Using direct model, but what is the advantage and disadvantage? Or maybe, what is the structural difference? If I use sequential, I can go on add and all. I don't require to mention anything after at the end of it. In case of model, there will be more flexibility, but I need to make sure I can't hang any layer hanging like that. Okay, I need to attach it to something. This will be automatic here. If you don't have any specific advantage to make it into model and all, you can by default use sequential. That will make your life simple. And this is also another example to show, even if you have some subgraph, you can create it separately and then add it here also. That is also another possibility I am talking about, but that's okay. You leave it at this stage. Have I used embedding previously? I think I used it in the CNN. Have I used it? Embedding. Even if, so typically the embedding will be one of the initial layers. The reason is, you are converting it into some kind of a transformations you want to do it. Okay, those, we won't typically do that kind of embedding in the middle of the layers. In the beginning of the layers, if you want to do some kind of a tweaking in terms, because here I am talking about taking the max features, embedding dimensions, I am talking about taking that input, right? So that's what you will take it as an embedded layer. But otherwise you can think of a input form, maybe transformed input layer you can talk about. Okay, once I read that layer, okay, then can you see it? Dropout, dense, a couple of dense start layer, and I have one LSTM layer here. And what are the parameters for that? I have the output dimension. Output dimension should be equal to the previous dimension, right? That one plus I have 2 activations. One is, you should tell me, activation and inner activation. Why I require 2? If you remember the picture, yeah, that's not actually sigmoid. Okay, the standard practice is actually tan H. Yes, yes. Maybe I might have run some modifications to do that, and I might have shared that code to you guys. Because typically when I have time, it's not just only reading out the code. We need to change some parameter and see the impact. So that's one of them. Now you can trace back. That means you just put that tan H and then let's run that. Okay. So any questions so far in this one? These are the regular layers which you are already familiar with. Okay. Only thing is I am just telling about in all case what is the activation. Even if you don't say activation, in this case, can it work or not? Yes or no? If I don't specify activation layer, can it work or not? Yes, it is required, but you don't require compulsorily to mention it. It will take based on implementation, maybe Relu or something else, it will take it as a based on implementation. But if somebody asks you if you need to compulsory mention, it's required compulsory, but whether I need not mention it because it will take from default. Okay. Similarly, even the k-means, what is the compulsory parameter needs to pass there? In the k-means clustering, you are talking about that. What is the compulsory parameter you need to pass? But just try in one of the scikit implementations, you don't require to mention even that also. Only taking some default, but doesn't mean that you don't require that. You need to require that k. That's where the people will spend a couple of days to identify the optimal k. Okay, it is required, but only thing is to, if you are not mentioning it, it is taken care at the default. Otherwise, it will throw out an error. Okay. Now you done your structure. Till this now only structure is there. What this compile is doing? Actual model of telling you, if you are talking about right now, I created the skeleton till now. These are my layers. This is my property of this. Now I need to stitch together and say this is the forward pass, this is my loss function, this is my optimization. That I am doing in that compile. Okay. So I am telling you use the ADA delta. I am interested in the accuracy. I am using this categorical cross entropy. Why I am using categorical cross entropy? Multi-class. Okay, cross entropy classification, and that too I am using categorical because I convert, even though it is numbers, I converted it into categorical. That's why it is categorical. That's why you should convince each and every line why I am using it. If you are not convinced, it's my duty to convince you. Okay. Clear so far? Let's run that. That won't take much time. The reason is I'm just compiling it. I still not done any fit and all. Have I done there in that line? Okay, so you just see LSTM. Now that thing is happening in this one. Okay, in this 4-5 line, maybe it looks like a 10 lines. If you ignore the print and all, it's hardly 4-5 lines. Okay, so what is happening there? The fit is similar to your machine learning also. Only thing extra here is the structure and compile. Once you do it, similar to your fit and fit transform type. Okay, so I am passing X train, Y train. I am passing the batch size as well. Okay, and I am just printing the number of epochs and evaluating on the X test. We have done X test. Split we have done, right? 50-50%. Can you run this? You may not get the best performance. That's okay. It may take some time, not too much time. I got only 44%, but I expected because it's not too much of data. Data is also small example for you guys. What's time now? 1:05. Okay, still we have time. Good. Okay. The next example is optional, but I'll just spend some time. But before that, this is like compulsory one. Till now, what we have run, we run a text example and we used even LSTM and then we are able to run it. Okay. The other people who run, just comment out these 3 lines, then you should be able to run these also. I'll explain that anyway. But that is optional. But all of you should be familiar with the 3 examples till now. You can ask me any questions till now. First example, we took it what? PIMA Indians data set, simple data set. Second, we run it with the Cypher 10 CNN example. This one is with an LSTM text data. And I have one more example with the routers that I can even run today or even tomorrow also. That's not. With this example, when you run, it's easy for you to run that one. Merge part is one line, right? So because it's deprecated, you just comment out this one. There is if else condition, just put some default one, then you should be able to run that. Output it will have because it's not the best one, right? So, but you will be able to run it at least. But my intention, I will tell you why I'm doing this one is, there are 2 purposes. One is, you can replace that LSTM with some kind of a group of net layers of a CNN type. I am creating a subgraph with some couple of CNN and CNN means that convolution and pooling layers. I can create as a subgraph and attach to the main graph. That kind of practice I haven't done previously. In a monolithic one, we are building it. But I want to show it to you. If you have these kind of, now I can make the other, so I can make LSTM layer as an optional. I can comment it out and then push this one there. The performance will be different, will be there. But I want to show that one. Because in the examples, my concentration within the hours what we have, I can't help you to build the, what you say, the optimal network. I can take only one example in that case. I want to show different flavors. Then we can see what is the best network within that. That's why the performance wise, I won't expect, at least PIMA dataset you will get some 90, 95 and all because it's a small one. But this one data itself is not very complex, right? I used to work with tens of MBs of files. Actually, the same file what I've given you 24 KB, the files itself, the maximum features will be 1,000, 5,000 kind of stuff. It took a significant amount of time. Only thing is, I can't use that data. It's not my data. I'm not working with that company also, but still I respect the IP of that. But whatever I can share it with you is whatever I can abstract it out so that you can use it in your regular work. That much I'm doing. So if you want to run this example, the same thing. You will just see some convolution layers in a loop. We are doing it. Only thing is just put some out layer as well, and then you can run it and then use it as well. Not much difference in the performance for me because it's a small data. Not much difference because the data is looking like only hardware, software. There is not too many words, right? But you can apply. Just think where you can start at a different. I talked about a big journey there. You may start with basic thing or maybe it is advanced stage or a prediction or a predictive level. You see where you are and you can use this kind of extend this example to your purpose. So because only we have some 10-15 minutes, so I don't want to start with the new topic, but we can use, because we don't come back to again the basics. Okay, just so far what we covered. If you have any questions and all, let's discuss that. Utilize the time. Then tomorrow I will start with small NLP stuff. We can run one example to be more comfortable. Okay. Then I will talk about the transfer learning. Okay, that is also primarily very important. Now we haven't used any example of transfer learning, but we are talking about building from scratch. But when to decide from, do I need to really start from scratch or can I start from the transfer learning? Transfer learning also, okay, I will get the model, but how to tweak that? So those are the things we'll talk about. Then we'll spend an hour on the autoencoder, because it's more or less we spend more 70 to 80% of time on the supervised, but we need to give some importance even to the unsupervised. I'll spend an hour, okay, and we have an example also on that. Then the last 1 hour we will talk on some advanced topics if you can grasp it, or more on the practical project stuff. I can customize that, that's not a big deal, okay. This, I haven't shared this one.
Oh, okay. It was from.
This is not my material. I was thinking where from these things are
I
coming.
got it from here.
Pre-reads, is it? Okay.
No, pre-reads.
Okay, okay.
What are these image formats or features? I mean,
When to use what, this features type of it, is it?
yeah, there are features for the vision they are talking about.
Features for vision,
I have
yes.
heard this keyword shift. It's a kind of representation of images, but
True.
I don't understand it.
When to use what? Even I just need to check, and I have some knowledge, but I don't want to give off-baked information.
Okay.
Let me look. So your question is when to use what, this shift or
Yeah,
gist
yeah.
and
What
stuff,
are
right?
these things? I mean, I don't understand details of it.
Got it. Just let me note down. I'll just tell that point. What are those? Shift and what else?
Shift and shift.
So now at least by the time we finish this particular session, you should be clear on what is CNN and the basics of that, and what is the, how do you visualize the CNN. And now the last 5 minutes I will use that LSTM visualization I was talking, right? We can do that. But before that you should be, that is optional for me. I haven't promised that, but because we have some 5-10 minutes, we can use that. You will enjoy that. But before that you should be clear on that. So RNN, LSTM also, it looks complex, but it just think from the, if I ask you somebody, this is my version of it. If somebody asks me what is LSTM, why I need to use it. LSTM is a kind of part, is a variant of RNN. RNN don't have memory. When I require this, as the name indicates, long short-term memory, when I require to get the gap within that, whatever the word embeddings is huge, if I know that, then RNN cannot solve the purpose. So I require some kind of a GRU or LSTM. In LSTM, I will have 3 gates, the base version: forget, input, and output. Each gate is nothing but not a complex one. Each gate itself is a small neuron node within itself. Forget will tell me with a sigmoid function what to remember, what to forget. Input will tell me what to, the same information, what is the hidden state from input state, plus what new information I need to embed or give importance to that. And then output will tell me what to focus on that. And cell state will help me to do the connections like a conveyor belt. That's it. There are 3 gates. Each gate is kind of independent node. Just like each node has a function of this, nothing different. Okay. And we typically use tan H and sigmoid for that function. Okay. That's it for the LSTM. And what are the use cases? You can talk about speech, music, or word text like this. Okay. Or weather forecasting, any of them. So when someone asks, okay, I already know the ERIMA and all, why do I require to use the LSTM? That's also a fair question. Then, and we talked about, I haven't made it much complex. Even we are talking about ensemble of LSTMs are also there. Okay, even we proved one when we filed a patent, because we filed, we can talk maybe, hopefully, not the context, complete context, where one particular situation of it, ERIMA also we tried, because that's the basic one. I need to prove that why I require an ensemble of an LSTM to identify some sequence. The problem is statement is same. Okay, but I talked about multi-step sequence. Okay, without going into too many details, we tried ERIMA. ERIMA is able to identify some sequences, but not all. Whereas this one is able to prove it. So that is one example. Okay. So once you are convinced, then let's make it more interactive for 5 more minutes. True. True. Agreed. Okay. So all of you, just you can type in your respective machines, or you can just follow me with this. LSTM Viz. Okay, this from the Harvard guys. I'll show you one example. After that, we can even you can enjoy it based on your time, and only limitation I will say is not the computer or anything, our time. Whenever we have. Where in this one, that I mean, again, time and effort and stuff, right? So But I do, especially when I interact with some of the IIT professors, right? So their guys are also doing some good job. So for example, IIT Hyderabad professor was talking on GradCamp++. That's also becoming popular. Okay.
I have heard that a lot of research is going on.
Good research is happening. Because they have they started, now the racing is, they started AI or data science BTech course also. MTech is already there, and they are claiming, okay, we are the first ones. Now the 1 year courses, 6 months courses are over. They are talking on even in US I think CMU started, and even in India also BTech in artificial intelligence, BTech in data science they are talking on. Normal. But if you ask me what is the difference, you remember the IT era was there, CS and IT both are, I don't know the Delhi, even in Delhi also. I think in IITs also I remember, my BTech is in computer science and MTech is in IT. Okay, but if you ask me what is the difference, 2 subjects I used to tell the differences. Okay.
Even I was an IT graduate, and the difference was I was taught some of the communication system
subjects, that's okay. But it's more like because we want to encache the what is there, and that too it can survive for a couple of, we haven't seen any BTech in blockchain or IoT at this stage because it changed, but AI they are projecting for next 5-10 years it will be there. So naturally say what they will be learning, something on mathematics they need to do much more foundation. Instead of the courses on the electrical engineering and all, they'll put more on math. All of you are able to open this? There are so many examples, but in the interest of time, I can pick one of them and I'll tell you how to use that. This is this much crazy when I start with that. So what is the background? Let me give it to you. What I picked up, just can you see this? All of you are till this point here with me? There are so many examples like this. Okay, these are all different examples using the LSTM. Okay. We can pick one of them, okay? How many have examples there? 1, 2, more than 15 I think, right? 12, 15 are there, okay? Let's pick one of the example, maybe the hidden state. I want to show you the complex one, hidden how it looks like, okay? If I pick on that, what is happening here on the, let's understand, if when you see some kind of a graph, what is our first thing? What is x-axis, what is y-axis? Can you see what is x-axis? There is a video also. In this one you can see it, okay? I can play it also, but anyway, I will voice over because I know what's there in that, okay? I will tell one example, then you will enjoy, spend some more time, okay? And see the video also, just 5-10 minutes video, okay? I will give the gist of that, okay? The x-axis is nothing but the dimension of, the words, can you see that? That's what the time dimension is, because it's the words, but typically these words are coming in xt minus 1, xt plus 1 like that. This is the times. What is this one? Hidden state, okay? How the influence of that hidden state is there. Now it is looking like a crazy thing, right? I can't get anything from there, correct? But let's select something, maybe this is the example they talk about. Let's say Little Prince. Select anything, okay? Something I picked up, some random things. Can you see there is a line? So it is showing actually how when I pick up these things, okay, these two as what are nothing but these two. These are nothing but two words. That will be word embedding will be there for that. Okay. So what is the influence of that in the previous one? Okay. Is there any connection with this one? That means it is at least going stable, right? It's not like completely. Sometimes what will happen? There will not be anything in this. It will be zero. When something is zero means that bar is zero means what? There is nothing to remember from this, not adding any value for this. But here it is not like that, right? Maybe there is something negative impact, but at least can you see some above threshold also? That means they have more impact on this particular word, because ultimately we are trying to learn some sequence or pattern from there. Somewhere there will be impact in the hidden state, somewhere it is not. But to little more understanding on that, maybe you can see matching of that. It will be little more crazier now. Oh, sorry. When you do the matching of that, can you see here? Some words, okay, there is a match count here. Maybe parts of speech also you can add. Name entity also you can add. Let me see. Name. So, but these I am thinking that you understand what is parts of speech, what is NER. But even if you have some gaps, it's my duty to tomorrow I'll fill it up. But the basics you know that on the this what I'm talking about. What is NER? Recognition. What is the other one? Parts of speech. Noun, verb and all, right? We'll just do a quick recap tomorrow. But here what it's trying to tell is whether it is a person or I don't know what is the GP, proper noun, na? GP, I didn't remember, that's okay. The proper nouns are coming here, different color codes you can see here, or even if you click only one of them, that will also show you what is the impact of that in particular what we selected it, what is the little prints we selected, right? So it's not like out of the box that word is coming, there is some context already coming up in terms of that, the importance of that, these many states are there. Okay, so if it is little crazy to understand even that, there is one more simple example also of a structure of the numbers and all. But what is the key takeaway here when it looks so crazy like this? But let's see what is the key takeaway for us. Okay, now see the. Previously little prints means what? At least it has some relation, it's not too crazy, right? At least some state. But the means it is very common one. Okay, we haven't done any processing. So typically by the time we reach here, we remove all the stop words and all, so that we want to identify only the interesting patterns. But let's say for that matter, if we haven't done that, now these many times the is actually playing the important role in the hidden state. No, the representation wise, because they fonts wise, because they added, okay, this is based on parts of speech or based on name entity, they have given different fonts also. Okay, you can see the precise also. You can see all the so many places it is there, right? That's why it is a little crazy combination like that. Match count with respect to the particular sentence, we have seen that count, right? You remember, if I have a sentence of I was, what is the sentence? I wish I would have a long thing. If I have different sentences, how many times it is matching with that? The which is selected, how many times it is matching with the existing sentences? So this is also, if you can buy in, please take it. It's also optional. Why I'm saying optional, this kind of, at least you should understand what is LSTM and all. If it is adding some value for you, please spend some time. Okay. The key takeaway is there's a lot of hidden states happening in that. The importance what I'm talking now is, unless you do the proper language processing, it will waste a lot of like this. Typically the need not be there in that, actually speaking. If I do some kind of a pre-processing already, I will concentrate only on the main important ones. Okay, that also adds to the complexity. That's why you can see the lines here, the states are changing because there is what to remember. Okay, it may think that I need to remember this, the state. After that it will say, okay, no, this is not much important, let go down, and maybe there is another relevance, let me remember that. That context switching is happening so frequently. And this is coupled with all this name entity and parts of speech and all that stuff. Okay. So if you're interested in and you're spending time on that one, you can spend some time on that. Okay. I also started showing only for a couple of batches when they can really take it. Yes, please. Yes, source code also available if you want to change it. Yes, that is also open sourced. This is also somebody else's project in that maybe a PhD level or maybe some lab, they open sourced it. Okay, I don't think it's very old, but at least I started initially. I don't think for you guys, I haven't shown this. No, I haven't shown. You are with the 8 hours batch or 16 hours? 8 hours is no way. Even 16 hours itself we are not covering able to fully. So in 8 hours I can't think on that. Okay. But at least 16 hours is a good enough to get a good understanding. Okay. But I strongly recommend I have even that won't complete the entire story but I have a good references at the end of that. Okay. We can discuss that tomorrow. Okay. So good to go till now. Okay. Thank you.
See, nowadays most of the modern vectorization algorithms, the package is available, right? Internally it's doing the cleaning job also. It made the job very simple. If you see, before these advanced vectorization and tokenization concept was evolved, initially people are doing manually. You know which packages they had used before manually? NLTK toolkit. Have you heard about this? Natural language toolkit. Even still also, if you want to make your own customized processing, cleaning and all, still people are preferring that. If you don't want to use a generic processing, I want to do very customized. I want to build vocabulary only for the sizes of 4 length or only with the size of 5 character length. Like that you can build your own by using NLTK toolkit. You have to do a lot of pre-processing and cleaning with your data. You can do some filtering and all those things. But apart from that, today this word to vec embeddings, all this tokenization, TF-ID vectorization, it will do the basic necessary cleaning, whatever is required, clearing off the stop words, comma punctuations, these things and all, but the basic things it will do. Beyond that, if you want to do anything on specially, you have to depend on NLTK packages, you have to do it. But regarding this Reuters data, already that all the cleaning and stuff was done. Only thing is what you have to specify the vocabulary size, at what vocabulary size you want to build your model. So it's not necessary that you need all the vocabulary, no, top words you are going to take. So all the words will be arranged on the in terms of the frequency of occurrence, the most predominantly used. The least words we not necessary to encode it. Very rarely any document will have the count there. So it's not necessary to build your very big model by using all the vocabulary. So we have to filter out the top words, which are the predominantly used words that is appearing in almost in all the documents. So that is why what I say that maximum words, what is the maximum words you are utilizing to the model. So here we say 1000 words. When you say 1000, no, it will take the top 1000 words to build the model. That means for every article is represented by 1000 columns, right? Unique 1000 columns. There are certain article will be not necessary that every article will have the entries for all 1000 columns, right? Hardly, like out of 1000 maybe there are certain article will be filling only 86 columns, certain article will fill 146 columns, certain article will have 200 columns. So very rarely, that almost practically impossible that any article will have all the counts for all 1000 columns. That scenario will happen very rarely. Almost like in a movie, for example, the movie example, right? I told you like GST and politics won't come. So it won't happen, right? So what kind of database do you suggest for it? So what kind of data structure do you suggest for this? Two-dimensional list, right? 2D list. So that's what your data is loaded as here as a 2D list. When you load this data, that means every row, the length of every row is unique. You can check it first. First you load the data and check. Okay, this is the first record. What kind of encoding? By looking at the value, what do you infer? Count. It is a count based encoding. And if you want to check the length, 87. That means out of 1000 only 87 columns will be filled, the remaining will be 0. Got it? So that is the maximum vocabulary, the size you want to build for your data set. So similarly you can check the second record. Second record, what is the length of second record? 56, it's variable length. Okay, so you should understand what data structure is, your data is loaded. So while loading itself, we have the data as xtrain, ytrain, xtest, ytest. This fashion we have the data, and also the number of classes. Number of classes is collected here. We have 46 classes. That is also printed here. So total number of training samples we have 8,982 records we used for the training and 2246 for the testing. Total number of classes is 46. After that, we are passing to binary encoding. We are doing binary encoding with tokenization. Still, if you want, you can also use with the count data itself as a TF-ID also. So here we are passing this xtrain and x2 tokenizer. So the tokenizer is defined with the maximum number of words for 1000 words. And you run this portion and you check X-train now. It will be binary encoded now. So I run this portion. Look at your data size. Your data size is 8982 records, and each record has 1000 columns. Now this time your frequency count is replaced by binary values, either the value is present or not, 1 and zeros. So how do you make sure that? So already we have displayed this, right? X-train of 1. The same thing I'm going to display here after binary encoding. Like this. This is 1000 points. So 1000 points you can see hardly, because only 86 locations are filled. All remainings are 0. So wherever it says 1 is that word is present in that. Okay. Once you have prepared your data set, rest of the job is as usual. You are familiar with that, the same story. We are defining the model. This model is done without whether do you think CNN layer will make sense for this data? Will it make sense? Sorry? Already even numerical also we have applied yesterday, right? CNN. But it is a binary encoded. That is also you have to think. Already it is very sparse. Already this matrix is very sparse. Not necessary. Ones and zeros only we have records. So for sparse matrix we don't apply CNN. So this is very sparse. So directly I go with this layer, dense layer. I start with the dense layer. My first hidden layer with 512 neurons, and you specify your input shape. Your input shape is what? Number of max words, that is 1000 comma. This is a way, one way to specify here is directly here you can specify activation ReLU. Another way to do that is, you can do like this, both are equivalent. Separate line you specify model.add activation of ReLU, or here itself usually what we do here comma activation is ReLU, right? That is one style, this is another style, you do it like this. So this is the activation function defined for the first hidden layer, ReLU. So here I introduce dropout layer. Here we introduce dropout layer because we have lots of zeros, sparsity is more. So I do some random dropping of neurons, 0.5, 50% dropout here. And again here, what is this layer? Output layer. Output layer is designed with number of classes, 46 neurons. Already your output classes is one hot encoding is done. Your your labels or all your labels are represented with 46 binary vectors. It's a one hot encoding is done. So we compile the model, we fit the model. This is the procedure you know already: compile, fit, and evaluate. Yes. It won't fit. Error, dimensionality error you will get. The dimension itself is wrong, right? No, after dropout we have dense layer, the output layer. This is the output layer. Dropout layer we are introducing. There are different levels of locations you can use the dropout. Where are the layers you can use dropout? Suppose you are using convolution layer. There also, after convolution layer also you can put a dropout. Even after max pool layer also you can introduce a dropout. But here we are not use convolution and max pool. After the first hidden layer I introduce a dropout. Suppose in hidden layers how many neurons you have? 512 neurons. and 512 neurons are there, and the input size also you see 1000, the 1000 neurons is connecting to 512. How many computing elements are there? That is what your network topology shows, right? When you display the architecture of any DL model, how many computing elements are there? Out of those many computing elements, you are randomly drop some 50% of the neurons, computing nodes. You are not considering, that means those nodes, the weight values you are not updating, you are leaving it as it is. Randomly it will take. For example, see, 50% of the weights is not updating, 50% of the weights is not learning for that pattern. What will happen inside? Let us think. What will happen? Sorry? No. Okay, understand my question. Instead of making all the nodes to learn the weights, you are going to back propagate the error and all the weights is going to update, right? You are saying that 50% of the randomly selected some nodes, you please don't update for this pattern. That means what you are communicating to the model. Sorry, please. Of course, this is a process for generalization, but literally what's happening inside to them? That's what? Only for those neurons weights are not updating. It communicates what aspect of learning there. The remaining neurons you are overloading. Am I? My remaining neurons I am overloading. Even in case if 50% of the neuron sleeps, you should rescue this. You should take care of this role. That's what is generalization. That's the concept of generalization, right? Not every neuron is learning every patterns. So you are incorporating the generalization in this faction. So you shutting off these many neurons, you please don't update, let others take care of the process. So we overload the remaining neurons to take care of, to understand this pattern. So that is what we communicate to the model as a generalization is incorporated. Yeah, half of it, 50%. If you think, see, that's what you should not do over generalization. Sometimes it will underfit. Suppose you say 50%, at the end of the day, if you get 40% accuracy, means immediately what it should strike? You should come directly here. Might be I did a lot of dropout. No, you just try reduce it. Instead of 50%, you put 20%, 0.2. So these are the things. Seeing the output again, you come back and where you should adjust and fine tune is what? By practice it will come, by experience and practice. Data will be transmitted. Only those neurons weights won't be updated. That means updated in the sense it's not learning that pattern, right? Those weights are not, those neurons are not learning that pattern. Only the other neurons is taking extra load to learn that pattern. That's what redundancy you are reducing there. The size, you are limiting the size because they have sparsity. After all, if it is sparse, then only I can confidently apply a dropout there. If my data is not sparse, it's too risky to apply sparsity there. If it is not sparse, basically your convolution, the result of convolution layer, you have a lot of sparsity, right? You have lots of zeros. So that's why there also you have scope to apply some dropout. So rest of the things is known to you because it's a multi-class problem, so it's a categorical cross entropy. Then we are fitting the model with batch size. What is the batch size here? And also this is the automated validation split we pass. This is one style we have seen yesterday, right? 10% of the record I use it for the validation process. Batch size is 32, number of epochs 5 epochs. It is done for 5 epochs. After 5 epochs we got 88.67%. and since you have 46 records, your confusion matrix is 46 cross 46. How to interpret this? In your first record, that is the first category, out of this is your test data, right? This is your Y test. In your test record, each category, how many times it is appearing. Yesterday we did value counts, right? Using value counts that you can find it out. Using value counts, what is the count of test record under each category? For example, this category we have 10 counts. So out of 10 news, 9 news are correctly recognized to this category, 1 is a misclassification. There is a 1 wrong classification. Maybe see, this is not visible, unless otherwise you represent all 46 by 46, then only you come to know it. Because is there any misclassifications, or only it is only 10 records? How do you display? Okay, this is the first row. This is first row of CM, confusion matrix. So you can see there is one more misclassification here in this column. Okay, that means the total record in the first category is here also 9, 10, 11, 12. Out of 12 record in this first category, 9 is correctly classified, and these are the misclassifications. Similarly, you can check for every row, you can check your confusion matrix, and also you can see the classification report also. You can see the first category, how many records? 12 records, right? The first category is 0, we have 12 records. Out of 12, only 9 is correct classification. So it returns your recall and precision score for every records. Almost the same thing only you are going to do with your movie data assignment. Your movie data assignment, the same thing you are going to do, only difference is what? Instead of 46 classes, you will be doing only 2 classes. That's the difference. This is multi-class problem. In your movie data assignment, you are doing with only you have first 2 rows will come, 0 and 1. Only 2 types of sentiment, positive and negative. Total number of records, not correct records. Total number of records in your test record, test data. Out of 12, no, 0 is the one category of news. 0 labeled as one category of news. Sorry? 12, yeah, 12. 12. Out of 12, only 9 are correctly recognized, right? And a few are splitted, no? Some other category. Which one? Yeah, it's into 100. Everything you multiply with 100. Percentage, all are represented in percentage. This is count. This is count. And overall average is given in the bottom for all the category. Yeah. Sorry? Yeah, correct. Correct. Validation split. Yesterday we used, right? 10% of the record is used for the validation. You see the evaluation during the epoch. Epoch, you see how many records are used. It is taking only training 8083 samples and validate on 899 samples. This 899 sample is what your test record. Out of this 899 records, if you total all these things, it will come to 899 records. If you sum all this, no, this is sum of all these things will boils down to 899 records. No, again I have to teach yesterday's topic. Don't compare with the ML methodology and DL methodology are different. In ML we have model.fit separate, model.predict is different. But here same function you do the training as well as testing. Don't think is what the training itself 2 in 1. Its training process also carried out with this much percentage of the test records. Both are done in same line. Whereas your machine learning separately you do model.fit and then model.predict, you are doing it separately. That's what this is a different style of evaluation. No, we can also use that sample. If you don't pass it, it will take that X test. That's what if you see the see, one is manual, another is automate. Anyhow, I didn't do it purposefully. I didn't use train test function. If you notice, I didn't use train test function. By default, Keras data, when you read the Keras data set, built-in data set, this is the way you have to collect it. You have to collect it with 4 variables: X train, X test, Y train, Y test. I didn't manually apply train test split. Yeah. That's what, this is the percentage is not in my control, right? Whatever the built-in data set, how they split is not in my control. Suppose if I want to evaluate for 60-40 or 70-30, otherwise I have to depend on the built-in data set. This is how they have splitted the data. If you want to go with your own percentage, means this is the only way you have to do, pass your validation split. Otherwise you have to depend upon one standard. This is how they prepared, let us say 50,000 data for the training and 10,000 data for the testing. That is how they build the built-in data. When you load built-in data, your data will be splitted like 50-10. But if you want to test it with your own percentage, where is the scope? You should have scope, right? I should not depend only on the built-in data, how it is splitted, 50,000, 10,000. If I want to make it 20,000, if I want to test it, you should have an option. That option is what? Validation split, the score you are passing it. No, same thing I printed twice. Same thing is printed twice. See, 2 times printed. Score only printed.
So we have to give model.evaluate X train, Y train to see the accuracy for training data, right? That's what we have to do. Okay. Instead of X test, Y test, we should give X train, Y train.
See, basically test score and accuracy both are same. After all, I am printing the same variable, right? Score. Actually, strictly should be score of 0, score of 1. Score of 0 will store the loss, and score of 1 will have the accuracy. But here it is printed, both are same variable is printed. That's why. What are the values score will store? Score will store 2 values. One is loss. Okay, one is the loss function, that is a loss value, validation loss. Another is the accuracy. So you can put score of 0 and score of 1 and you can see.
When we are loading the data, the first step, so there we are mentioning test split equal to 0.2, right? So it means in the train only the remaining 80% data will come. So my question is, because this 20% is anyway we are not using it, so why do we give 0.2? We can give 0.1 or less than that, and then in the validation step we can use the more records for training, right?
Is it fine?
No, I'm asking, is that the right way of thinking? Is it in the correct direction? You said that is the way we load the data into train and test. So why do we give that split there? Why not we take the entire data and then in the validation step we all anyway we are giving the split as 0.2?
Yeah. There is no way connection between that percentage and this percentage. This percentage is independent of that one. This is 10% of your training sample is utilized for the validation here. It is taking the 10% of your training samples for the validation. Sorry. Now 10% for the testing, 90% for the training. See, otherwise, if you have this confusion, better you give like this. You have to specify like this. If you want to use while you are loading the data itself, you specify the percentage, right? 20% or 30%. That data, that percentage itself, if you want to use it for the validation here also, better you specify validation underscore data equal to X test, Y test. Yes. It will use the same percentage. Yeah, here this one we have to remove it. This one we have to remove it. This one should be removed. That's why in Prima we have did two things now. One is with manual validation. This is our manual procedure, and if you don't want to use that value, this is auto verification. For auto verification, we have to specify like this validation split. That means we are not using that or loading the data whatever the percentage you collected now, that one I am not utilizing it. That is the meaning. I am specifying the percentage here. If you want to utilize that, you have to say your validation data within tuple you have to pass X test, Y test. Two procedures are whichever is you want, you can do either. No, there is a separate function is there for TF-ID vectorizer. So you have to use that. The function itself different, not simple tokenizer. The function itself we have to use a different function called TF-ID vectorizer. That you have to import and you have to use that function, TF-ID vectorizer. So let us close this. So nothing new we are doing it here in this data, right? Except your preparation is different, right? Preparing the data as a binary encoded data. Shall we proceed further? I think no, there's no point in spending more time on this. Okay, first you tell me the few applications or problem or domain area where we have the scope of sequence prediction. Maybe one thing you can tell from this diagram. What you can tell? What do you infer from this? I didn't ask you the algorithm, how RNN is going to work and all. I'm just asking the application. First we'll start from the applications. First understand the application, then we'll come to the algorithm, the feedback network, how it's up. All the story we'll discuss. So this block is representing, the moment you look at this block, what kind of application is striking you? Stock value prediction. Based on the last 5 values, tomorrow's, what will be the stock value tomorrow? I can do the prediction, right? Weather forecasting, weather. Based on the last 5 days amount of millimeter of rain, how much it has rained, I can predict tomorrow's rain. So this is, first model is many to one model, right? This is time series, not similar, time series. This is time series. Sequence. Instead of time series, we are calling it sequence. Sequence and time series both are same, sequence. Why I call the common name sequence? Tell me the reason why it is not particularly specifying time series. Other input means, sorry? No, you're not understanding my question. For example, you understood my question? Why it is not named as time series? That's what he asked. Why it is not named as time series? Of course, logically it is time, something like a time series. We can solve time series problem also, one of the problem we can solve. But not only the time series problem is not solved by your RNN or LSTM. No, day to day life we have a lot of application. Why you mobile phone, your text next word it predicts, right? Is it based on time based? It's not based on time based. Your next word, your mobile phone, your text editor is predicting, right? That problem also it is your model is solving that problem also. Do you call that as a time series forecasting? There is no time stamping here, but just only if I present a sequence of letters. It's a sequence. I train the model to remember the sequence. So whatever the combinations you want to make the model to remember, what are the, after Jack what should come, after Jill what should come. You have all the permutation and combinations. If you have the combinations of these word sequences and you train the model, your model is going to say after this word you are supposed to have this word. That is what in the text when you type the next word based on your past inputs. So all the detailed analysis we see how it predicts and all. We didn't go to the algorithm for time being. At least you identify the problem, which are the potential problem which is going to come under RNN, recurrent neural network. Whereas LSTM is a slightly tweaked version of RNN. We don't use directly RNN, with a slightly tweaked version of RNN in the sense we are going to increase a little bit capability, more capability on RNN. That is popularly called as LSTM, long short term memory. The meaning is long short term memory. Why it is called as long short term memory and all, you will shortly you will understand once you understood the logic behind the architecture. Okay, so there are two problems we addressed here. One is numbers, that is say 15, 26, 46, and output is 32. This is one kind of problem. If you have numerical values, your model is going to predict the next numerical value. Jack and Jill. Do we solve this kind of problem? Shall we solve this kind of problem? Right, that is another model, right? We can also build a model to predict the next word after Jill. If you have trained Jill and went is one combination. Okay, any other problem or any other areas you can suggest? Sequence prediction. What is your assignment? What is your assignment? You want to predict your movie review as positive or negative, is a sentimental analysis. Shall we apply that problem here? Will that fit into here? Is it possible? What you are going to do? This is the sequence you present to the model, and you are making the model to remember this is one label. This is a sequence you are presenting to the model, and you are making the model to remember this is another one. What is the difference between this and this? Tell me. Using, see, we are talking about sequence prediction. Here it is predicting the next word. Here it is predicting your sequence belongs to which class. That's the difference. It's going to predict my next word of my sequence. This is one kind of problem. Here your model is going to your sequence belongs to which category. So it is called sequence classification problem. This is sequence prediction problem. You can also use sequence classification model. You can build a LSTM model, that is RNN model, even for movie review data also. Sentimental analysis also you can apply. What is the difference by using this model and using that model? What is the difference? Primarily, just superficially you tell. Technically I am not asking because I am not introduced the architecture. As a superficially, as a bird's eye view, as a abstract, what is the fundamental difference do you think? You develop a deep learning model, you vectorize the things and all, you apply to the ANN architecture, you make the model to remember 1 and make the model to remember 0 or n number of classes. Here also you can train for n number of, don't think it's only for binary, you can do it for n number of classes. Even the news group data also you can apply this model, but it uses a different logic. That's what I'm asking, what logic it takes. In deep learning model, what you have solved just before, each word is represented numerically or some whether it's a continuous real value or binary value, whatever it is. Simply it remembers that as the independent features, that's all. They are remembering this as the independent features, but it does not explore the context across the feature. Is there any context across the feature? Do you agree? Independently this is 5, independently this is 4. You present as a neuron, make the model to map, just like any other, no? Like a prima indians. What is the difference? In prima indians we have feature, instead of that we have numbers, nothing new. The same numbers I am making the model to learn this. If these are the numbers, you remember as 0. If these are the number, you remember as 1. I didn't explore this relationship, the context. Before this, what word was? Before that, what word was? And if your model is going to explore that sequential context into the picture, do you think shall we able to predict what class it belongs to? That is a capability your RNN or LSTM model is going to bring. Okay. Any other area or application do you think of? That is algorithm. I'll come to the algorithm. How it will work? It will take feedback. I didn't come to the algorithm. Please hold on. I'll come to algorithm. Moment if I show the algorithm, it immediately lose the interest. I'm damn sure. See, if you are interested, feedback, you want to see feedback, see. This one will scare you, or you see, I can directly show this is RNN, this is what the feedback network goes on like this. What do you understand? First context, I'm bringing the context where you could apply this. How the feedback's happening and all, we'll come to this. I'll come to this. Please wait, hold on. Any other context? Tell me any other context where we use it. Product recommendation. Suppose you are purchasing in Amazon, okay, last year, this month you purchased this product and this product. They can predict what could be the next product you are supposed to purchase. You have a sequence, right? So last year you have purchased camera, and the next product you have purchased a laptop, then mobile, then your, for example, trolley. There are some chances to predict from the past pattern. It's reasonably, not 100%, but reasonably you can use of this LSTM model to predict what could be the next product you are supposed to purchase. Chances. Yeah, if we have that data and patterns available, yeah, we can predict the volume of traffic also. Sorry? Oh, this is also another way of doing it. Better and all, off the hand I cannot tell. I have to cook and see the taste. Before cooking I cannot tell. Suppose if any recipe if I say, shall we prepare the same recipe in microwave oven also? I can say, yeah, it's possible. Will it taste better? I have to prepare and see how it tastes, then only I can say. Understood, right? That means, see, there are plenty of options are there. Same problem with different approaches, right? Now you are slowly uncovering, right? Almost everything is possible with any model, but depends upon how do you use that data for that model. Previously you told movie sentiment analysis, you thought only with CNN or deep learning model only it will be solvable. Now the moment I gave the context, now you agree that even sentimental analysis for the movie review data, even you can use LSTM model. That understanding should come first. What to do for what kind of problem. If that understanding comes, how to do is a matter of a day. How to do anyone can do, because the provided technology and tools, algorithm, libraries are there. It's a matter of a day. All these example we discussed, right? Okay. What kind of problem this will fit into? For example, chat box. What kind of problem chat box will fit into? You pass some query, that is also sequence of data, right? Sequence of words. What are the courses do you offer? Suppose you are opening the Great Lakes website and immediately chat box pop-ups. Suppose you are typing it. What kind of problem? Do you connect this problem here to this context or not? If we connect, how it will be different from these examples? How it is different from these examples? Think carefully, you analyze all these examples carefully and tell me. No, that is the way of implementation. Everything, this also I can make it interactive. So go to some website, some review, if you type it, Interactively you can type the review, right? Yesterday I saw the movie, this movie was so and so and so, and click it, it will say the answer, right? No, that's the way of programming. This also I can make as a continuous process. Okay, give the next movie review, I'll give the scoring and rating. That is a way of implementation strategy. I'm asking about the logically how it is different. Yes. No, fundamental difference I'm asking. Don't think more too complex. Very fundamental question. In what way this kind of problem different from here? It's not multi-class. It's not multi-class. Again, you are making mistake. This is many-to-many mapping. Input also sequence of words, output also not single word, it's a sequence of words. You got the point? Input also sequence of words, output is not if it is a classification model like this, your output is going to say, okay, this is this record or this is this record, sentiment. Another one is what? If this is a sequence of word, it is going to predict one next immediate word. Again, many to one. If this is a sequence of words, output also it's a sequence of words. It's many to many sequence mapping. You got the difference? Okay, this comes under many to many mapping. Your voice translation also comes into that, your speech translation. So you have a lot of options to choose it. How do you design the model? It's one-to-one mapping or one-to-many mapping or many-to-one mapping. You have plenty of options are available. You have to find out your application fit into what kind of model it is. Suppose you say something and you are immediately say, suppose you speak in English and your response is going to say in your local language. That is also many to many, right? So only instead of text it will convert into voice and it's playing back. That's again it's a very popular product Google is developing, right? Suppose you land up at China, it will translate. Machine translation, this is an example of machine translation, chat box as well as machine translation. Whatever the question you speak in English, this translator will be always you are wearing, that will understand as the input many sequence of words as input. It's going to throw the output also sequence of words in Chinese words. So this application is machine translation application. Machine translations, one language to another language conversion or chat box, English to English, whatever the language to whatever the language. How do you map and model? Basically everything at the end of the day it boils down to the numbers. Whether it's these texts, how do you map into numbers, and these numbers how do you map to the output? How do you map the input and output? Any other example or application do you think of? Okay, this is what the sequence classification problem. The sequence classification problem. Suppose you have the sequence of these numbers are nothing but encoded. Your sequence of words is numerically encoded. Let us say movie review or hotel review, whatever it is, some numerically encoded, and if I pass the sequence of words, my model is going to say it is a good or bad. So this is a sequence classification model, something like this. Again here there is no limit of number of classes. Don't think only binary, you can use multi-class also. So not only sentimental analysis, you can think of other technology, other domain also. For example, DNA sequence classifications. If given a DNA sequence of ACGT values, predict whether the sequence for coding or non-coding. So you have plenty of applications and choices are there under this category. This is what the application I talking about, this many-to-many mapping. Machine translation. Rather than predicting a single next value in the sequence, okay, a new sequence is predicted that may or may not have the same length. That is a very important point to catch here. Not necessarily to be the same length. When you are asking the question in the chat box, not necessarily your chat box will answer with the same equal number of length. So these are the challenges in which you cannot use conventional neural network. In conventional neural network, you have follow the fixed number of inputs and fixed number of output, right? but it's going to dynamically change. Sometimes your input will have 10 sequence, sometimes it will have 5 sequence. So these are some of the practical challenges. That is why it has emerged as a separate area called recurrent neural network is going to solve this problem more effectively. That's what, this is the challenges, that's what I am talking about. The conventional model, these are limitations of multi-layer perceptrons. Even a classical neural network model, if you want to apply, the important point here is what the dimensionality of the inputs and output is known and fixed. So because of these reasons, we don't use a classical multi-layer perceptron model here, but we can use a deep learning model. Deep learning model is possible. Sorry? Yeah, deep learning means, don't say deep learning means CNN. CNN is a part of deep learning. It depends upon whether you use it or not. Classical neural network, I am talking about the classical neural network. This is a limitation of classical neural network. But DL you can solve. Because you are going to solve your, I think the movie review data set, you have two options with you. That is an assignment task for you, right? I don't know all of you are going to solve in same approach or not, but I could recommend you, if you have a split in batches, at least one batch you try in deep learning model, another batch you could try in LSTM model. That could be a good strategy to compare. Otherwise, everyone you approach in single problem, no, you don't have an opportunity to see the result of the other approaches. But this is just my personal thought. You please check with program office. And finally, don't blame Mahesh sir only, he told like this, like that. Whatever the instructions you get from program office, please follow that. This is my personal opinion. I came to your favorite topic. Okay, this is what you are looking for, right, from the beginning. What in the normal neural network, I am talking about a classical neural network or feed forward neural network. Backpropagation, multi-layer perceptron backpropagation neural network is a feed forward or feedback network? Feed forward. Our deep learning model is a feed forward or feedback network? It is a feed forward network. Your classical neural network is a feed forward, that is MLP classifier, which is available in sklearn. I think you have not used this. Have you used this? Just as a one-liner, you can just easily try. Suppose you say model equivalent to, imagine if you want to apply this for the Prima Indians data, model equivalent to MLP classifier, hidden underscore layers, only this is the argument you have to pass. When I say 8,8, that's all. What it means that 8,8 means use two hidden layers, hidden layer 1, hidden layer 2, each should have 8 neurons. 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. We know what is the input for Prima or this today's data, what data we have seen. Housing values 13. You can also try, okay, but that is a regression problem. Okay, Prima data 8 neurons, right? 8. Okay, otherwise you'll get confused between this 8. Okay, let me take something like 10, 6. What it means, your input layer will be 8 neurons, 3, 4, 5, 6, 7, 8, and hidden layer 1 should have 10 neurons, and hidden layer 2 should have 3, 4, 5, 6 neurons. This is an architecture, and output will be 1. So how do you do? Model.fit. Model.fit, X train, Y train. Okay, then Y predict equivalent to model.predict X test. Compare your Y predict with Y test, job done. Same neural network model is available in scikit-learn library in the name of, in the phase of machine learning. There we don't call it as a deep learning. It's a classical neural network model. It's a shallow. Even also you can increase the model. You can make this model as a deeper. There is no restriction here. Instead you say like for example 10, 15, 20, 40, 80, still it will work, but you are overloading it. But to certain extent only it will work. One point of time it will hang because it does not have the architecture to handle it. Multi-layer perceptron. Not shallow, that's what I say, no, if you give like this is not shallow, it's a deeper. Still you can apply, but does not has a parallel sophisticated architecture, something like a TensorFlow and Keras. That is also neural network. I can call it as a smaller network. Smaller network. Smaller neural network. Which one? See, we use the deep learning only if you do it in either Theano or TensorFlow. That's it. Otherwise, don't use the word deep learning. If anything which is implemented in TensorFlow parallel architecture with Keras package, that model alone it's called as a deep learning. So all other model we simply say neural network model. That's all. Simply neural network model. You can make in different name like small neural network, shorter neural network, or shallow neural network. Whatever the name you want to give, you can give. So deep learning we are focusing on. We have a sophisticated platform. Computational power. Your TensorFlow is giving the computational power to do this. Otherwise, with MLP classifier, you cannot think of applying the routers data or that MNIST data set, 50,000 sample, 40,000 sample. You cannot think of. With this model, you cannot think of even beyond 5,000 records itself. It will hang 5,000 or 10,000 records. The system will hang. That is why we have a sophisticated architecture to handle large data sets. So it is a framework for the better framework for the neural network model. That's it. But in both machine learning, your classical neural network and deep learning have the same strategy of updating the weights. There is no difference. It's a back propagation. Only the error is propagated back to update the weights. Understood? We call it as a stochastic gradient descent. But of course, in deep learning model, there is slight improvement in terms of adaptive moment concept also incorporated. So that is still increasing the efficiency of the performance. Convergence. It will have very good convergence. But the classical model has sometimes it will take a lot of time to converge. You have to run it for 1 hour. It won't converge. Converge in the sense what? Your loss will be at 0.4 or 0.5. It will never come below. So you get only 40%, 50% accuracy. Because it follows SGD. Whereas here it follows adaptive moment. So your weight updation is same as your errors propagating back. Okay. Yeah, you can give. I didn't pass the other parameters, it will take the default parameters. The default epoch is 200. It will take the, otherwise you can specify epochs equivalent to, you can give. Everything is available. So the default learning rate also available. You can, if you want to give your own learning rate, you can specify LR equivalent to so and so. Let us say if you want to give 0.15, you can specify learning rate. Epochs, if you want to specify the epochs you can specify. Everything is possible. What we do it in RNN, additionally, we present input, this input will be passing on to this weight, okay, and you have the output. This output is nothing but a summation of x into w, right? In the output you get x into w. Of course, activation function is acted here. You have f of net as the output, final output. Additionally, what we do, this output is taken to the input in recurrent neural network. That means what? When you are presenting your second record, this is what your sample 1. Sample 1 you have presented, and your model has shown some output. Okay, for the sample 1, let us say 0.5. when you are presenting sample 2, along with your sample 2 is one input, along with that your previous output also come as another input to your neuron. That's the difference. Just simply the output. I didn't calculate any error and all. It's not the error. Simply the output. Suppose x is 5. And your weight is 0.5. And my bias is, let us say, 0.1. What is the output of neural network? 5 into 0.5 plus 0.1. Okay, this is 2.6, and this 2.6 will be 1 plus e power minus 2.6 sigmoidal, and you get some value between 0 to 1. You got that output. That is the output of the neuron. Directly you take that output and feed as the input to the each individual neuron. If it is a one neuron, let us talk about one single neuron. Same process will be applicable to, suppose you can have a stacked multiple neurons also. We are talking about one single neuron. What is the process that happens in one single neuron? Which one? I didn't calculate delta O here. Unless otherwise you calculate error, then only delta O will come into the picture. Simply the output. Output again your feedback to the input. Immediate previous only we are giving. Okay. So instead of looking the model something like this, it will be, we can flatten this like a conventional feed forward. Look at this, whatever I told here in this, it is represented here. See, what your x is traveling. Imagine I have only one hidden neuron. Let us talk about one neuron. Your x is traveling with the weight W. W is the weight which connects x to h, right? Input to the hidden. So I call it as W x h. And this is the weight connecting hidden to output y, WHY, which is connecting hidden to output. So it is called as WHY. So my input is traveling to this neuron and I have the output, this output. This output is fed back as input to this neuron again. So now I am going to unfold this. If I unfold this and I represent this, if the same output is fed back as an input, next question is what? What is the weight value for this? Tell me. If this output is taken and fed back to this neuron, any input has to travel via weight, right? What is the weight for this feedback? Sorry? My output is, let us say this output is something like 0.45. Okay. I agreed. 0.45 is going to multiply with which weight I am asking? Huh? Same weight. Wherever you have supplied one input, okay, you have supplied one input and you got output. That output is fed back and it has to cross to the same weight. Till the time I update the weight. So far I have not updated the weight. It is going to pass on to the same weight, right? Shall we interpret in the same sense, in that sense? Is that clear for you? Output has to fed back to the input means again it has to pass to the same weight. Still my weight is not updated. No. Yeah, that's what we are going to, if you can easily understand from this diagram. When I unfold this, okay, this is what your current time instant sample. X suffix t means this is my current sample at this time instant. Let us assume that this is sample number 2. Correct? This is a sample number 2. That means you have already presented sample 1. When you have presented sample 1, your xt is traveling here. What is the additional input coming to this neuron? The output of the previous time instant t minus 1. That means when whatever the sample you presented at t minus 1 instant, that means sample 1. My sample 1 output, this is my sample 1 output, right? Sample 1 output is coming as another additional input to the neuron. Look at the weights, WXH, WXH. It's going to travel via the same weights, right? It's going to have the same weights. So your previous instant output is coming as the input to the additional input to the model. It's a summing. And this model output is going, this output is going as what? Input to the next layer, that is next time instant input. In all this instant, if you notice, my weight is remains same. My weight remains same. Okay, for the first sample, there was no feedback. Okay, I start with the x of t. So how do you write the equation for x of t? X of t, how shall I write? 4 into 0.5. Let us assume there is no bias. For simplicity, I am not having any bias. So you have 2, right? Yeah, this is the weight, right? No, I didn't include that. I didn't include it. So this is the output. So f of this value, let us assume this output is 0.35. Okay, this is the output. No, this current time instant is multiplied with this weight, right? No, I didn't. No, first I am getting the output, one feed forward. The neuron x at current time instant is going to 0.5. First I need to get the output, right? That output I should take it for the next sample. Let us assume for the first sample there is no feedback. Because there is no, this is the first sample I am presenting, so there is no feedback. So then when x of t plus 1 goes as input, this time same 0.35 will come via the same weight. It's going to come via the same weight. So 0.35 into 0.5 plus this next sample is 3 into 0.5. So both will add, okay, both will add, and you have some value. That value will be passed on to the activation function, and you have the output. Okay, again this output will be taken for the next sample and it will be going like this. Is that clear? It is a, sorry? That's what we are going to see. This is one single neuron. You can have any number of neurons. No, this is not my input. Suppose you have input n number of inputs. Input layer. Suppose your input layer. That's what I am talking about. So this is what this. If it is a normal neuron, what do you do? If it is a normal, this is what my hidden layer one. This input is coming here with the weight, and you get this output. This will be propagating here via. Additionally, what I have, I feed back. Every network you feed back. Everything you feed back. Next layer also, this neuron also feedback. Every neuron you feedback. Same neuron, don't confuse with the layers here. Every neuron has this activity. Every neuron will have this activity. The output will be fed back to the same neuron. The previous input, whatever the previous input your neuron has produced, for that output it produced, it is taking that also into consideration. That means it is going to act as your previous input as additional information, as a memory. Correct? It's acting as a memory unit. So we call this as a memory unit. Every neuron, it's not only working on with the current sample, it also taking into picture the cumulative sum of the past sample also as a immediate past memory. There we are propagating, the error is propagating back, no? So finally you see, no, whatever for this particular sample, you have one output, right? Finally, that output you compare with the target. That difference is what? Error. That error you will be propagating back. which is some unknown number, I didn't calculate. So this is a simple RNN. This is an architecture of simple RNN, but there is a drawback of this. Suppose if you are increasing the layers, the same error back propagation rule also applicable here. Only additional feature, every neuron has its own feedback component, additional this plus of this memory unit is coming into picture. So that means your immediate past only you are giving feedback, right? So that is why we call it as a short-term memory. But why we got the word long, again I will come back later. Short-term memory, what is meant by short-term memory? Because your every neuron is not only taking the present sample, also the immediate past. So it's a short memory. Shall I write it? It's a short memory. Your RNN will be working very well for a small sequences. It can do a prediction very well, do the prediction for the small sequence. If it is a large sequence, no, if you are going to give a large sequence, your RNN will fail. Why? Because what will happen? We have a concept something like a vanishing gradient. Concept of vanishing gradient. What is that? I am telling you. Suppose when you calculate the delta error value here, right? The delta error value you calculate, and the error value is something like this 0.05. And how do you propagate back? This delta error has to be propagated via the weight values, right? So at every layer, this delta value already is in fractions. When you keep on multiplying, as you see, the delta value here and delta value here, let us say delta hidden 2, this is a delta hidden 1, let us assume. Which delta will be smaller, which will be greater? Tell me numbers, 1 or 2. Which is smaller? 1 will be smaller. Do you agree this? Okay. As I propagate back too much, okay, that means I am approaching towards my input layer. What will happen? This will be contributing very less for the weight adjustment. Am I right? So your delta value will give very good weight adjustment for the layer which is close to the output layer, but it will give you very poor weight adjustment for the layer which is attached to the input side. That is what we call it as a vanishing gradient. Vanishing gradient. Why we call it as a vanishing gradient? Because your delta is what? The gradient factor. It's almost slow, small value, again small value, at one point of time it will vanish. That means that depends upon number of hidden layers. Generally we use the stacked LSTM model, not one single layer. We will be using stacked. That is why we use DL models, right? DL model we don't use it for single layers. We will be using it for the multiple layers. When we expand the depth of the model, this is a problem, and your RNN has a short memory, and imagine a long sequence is going to come. See, sometimes when we watch some crime thriller and all, okay, according to the incidents, who is the suspect, we keep thinking, right? Okay, this will be the person. You will have some person in the mind. As the story progresses, some other incident will happen, and your suspect, you will disappear. You will forget that person because the context has changed. Now you keep this is the person who will be the suspect. Okay, as the movie progresses, as the sequences progresses, I tend to forget the very initial scenes or events, and I tend to remember the recent. What is the recent context? That only I am trying to update. That's what happened in our biological RNN or biological model. So the context is very important. What the RNN will be suffer from? RNN is suffering from for the long sequence context. It is not retaining the context of long sequence, and how that is overcome by LSTM model. In LSTM model, simply we don't give this feedback simply. We have some scaling factor and filtering factor for the feedback in the form of a gating structures. That means there are certain weights. Okay, there are certain neurons in which the weighting has to be given more. That is something like a compensation for the vanishing gradient. because anyhow the vanishing gradient is not going to give you enough update on those weights. What these scaling factors are going to do, these scaling factors are going to give some boost if it feels that neuron is giving some influence on the context. If it is the important means, if it want to retain that memory means, it will give high scaling factor. If does not wants to retain means, it will give the less scaling factor. That is depicted by this next diagram. This is what? This is an extension of RNN model. This is just a little modification of RNN model. We don't simply give the feedback with some scaling. So how we are going to give the feedback with scaling, that's what we are going to see. Here we have three important gates. Three gates you are going to see: input gate, forget gate and output gate. Input, forget and output gates. By looking at the flow, can you see these three cross? 1, 2, 3. These are the three gates. The first one is what? These are some of the peepholes I have given into the models. Some extra peepholes. Don't simply feedback. I'm going to give some portion I want more, some portion I want less. Imagine this is something like a block of it's a pipeline which is getting some waters. Okay. So you have some control mechanisms. So here I want more flow, here I want less flow, here I want more flow, something like this. These are going to act as a filters. So what we call this as, this tapping unit as forget gate. This is the input gate and this is the output gate. Three gates we are defining here. And see what are the inputs coming to the forget gate. Look at the flow and tell me what are the inputs that comes. Your current input, right? Your current input and your xt of -1, output of xt of -1 means your past output. Your past output is coming, your present input, and this is what your sigmoidal activation function. You get a summing point, right? You get a summing point. This is a sigmoidal activation function. You apply sigmoidal activation function, and this is going to this gate, and based on the output of sigmoidal activation function, that means because your sigmoidal activation function will fluctuate between 0 to 1. Okay, suppose if the output is close to 1, okay, that means whatever the information it receives from this layer output, that means your previous output, the same output is coming here also as a scaling factor. Not only here, I'm tapping it here also to this unit also. Your previous unit output also coming here, that is going to be multiplied with what? This output of this sigmoidal activation function. That means based on the output of this, it is going to decide, this is a weighting factor, right? This is a weighting factor for previous output. Whether I should give more importance to the previous output or least important. If the sigmoidal output has high value means it will give more weighting factor, right? That means it will remember this more. If it has to forget this output value will be smaller in number. So that is why this gate is called as a forget gate. This has to decide how much it has to remember and how much it has to forget, depends upon this output. This is forget gate. And next comes, this is the input gate. What are the things comes to your input gate? Your current input, also your current your previous output also coming in this flow. So your current input is mapped onto your hyperbolic tangent squashing function. That means your current input is scaled to +2 -1. It will be mapped onto +2 -1, and that will be multiplied with, again, whatever the sigmoidal activation function you pass, no, summation of xi and this input, this product, no. These two you have summed and you apply activation function. Again you have an activation function here. This output along with this, your input is passed on to this directly activation function without multiplying with this. These two are product multiplied here at this tap function. It will be added in this output of this, it will be added. What is the significance of this? Your forget gate is giving some information about your past record. how much importance has to be given for the past sample. Along with that, what is the importance of my current information? How much my current information is important? That contribution is given by this unit. That contribution is giving. Along with that, one more output, one more gate, we take it directly. This product is coming to sigmoidal activation function. It is going to here. This output I am taking, passing on to this activation function. But this is a strategy they have designed it. For this strategy, they split up, instead of taking one simple output as giving as a feedback, they have kept 3 tapping units, and they have mathematically formulated. It's a kind of an algorithm, right? People have done with a lot of experimentation, whether they need a scaling factor here or hyperbolic function here or hyperbolic function is here. They have done some experimentations, some R&D. Based on out of that R&D only, we have this model. This is an architecture. This is a standard architecture. We are employing this architecture for our applications. Why it is here and why it is not here and all, it is a design. We have to ask the people who developed this. We are going to use this. We are going to be end user of it. But at least we should understand the context of why these 3 gates, the contribution of these 3 gates. This gate is going to give the influence of your past immediate sample, contribution of the past sample and the current information, and cumulatively, this third unit is nothing but the cumulatively your forget gate and your input information is leaving this memory cell. So here in LSTM model, at every neuron, we don't use the term neuron. Instead of using the term neuron, we'll be using the term called memory cell. But literally the same only. Why it is a memory cell? Because it has some tapping units here to decide, to control the inputs at several stages. This is what we discussed in LSTM gates. So one is forget gate, decides what information to discard from the cell. It's a memory, right? It has to decide whether to discard, I have to remember it. And your input gate decides which values from the input to update the memory state. And your output gate is a accumulation of both, decides what to output based on the input and memory cell. Each and every gate, yeah. Weights will altered only during your error back propagation, during the training process. We just discussing the forward flow only we are discussing. This is how the information is flowing forward. When the input is coming, what are the computations is carried out? There's no weight updations you are not talking about. Here there is no weight updates. Look at that model. Actually, this is not, this is not error back propagation. Don't think this, of course weights are scaled here, of course weights are scaled, not because of error back propagation algorithm. That will happen as per your error back propagation algorithm. But at least you have to get one feed forward flow, right? For one feed forward flow, what are the computations that happens? For your current input, when you present, what is the contribution of your past input, and what is your memory cell is throwing the output. And I will be taking this output to the next x of t plus 1 data. So you are presenting your data, and this is what the flow that happens into the memory cell. Now, same thing that happens to all the neurons, right? This is what is magnified. This is magnified and given. Same thing, same memory cell you have, every neuron will have the same logic. Every neuron will have this. This is just one neuron, one memory cell. This is one memory cell. These two things you have to assume virtually, which is not available here. You have to assume virtually because your past record you cannot see. What is the output? Your past output. Only thing is what your past through this feedback only you can realize. Similarly, your next memory cell, unless otherwise you feed the next input, you could realize it. Actually, these two should be, you should imagine virtually. But this is what your current state of the cell. This is the current state of the cell. All neurons itself a memory cell. Don't separate neuron and memory cell different. Your neuron itself acts as a memory cell. This is a magnified version of your every neurons. So this output of this neuron, how it is decided? This output of this neuron is nothing but this output, right? This output. That is based on the memory cell. It's not going to be fixed. That is simple RNN. This is simple RNN. Because if we use the fixed value means there is no memory, short term. So that drawback is overcome by scaling your 0.5 at different instant. I'm not using 0.5 alone there. I'm scaling at, I'm applying sig model function here, you scale it here, and you scale it a different way, you scale it different, 3 different ways you scale it. And you take the output. Not as a simple output as it is like the simple equation. So little complex output. The combination of 3 things is coming into the picture. Is that clear? Not as a fixed 0.5. That 0.5 is scaled by certain parameters. Sig model activation function, and some places it is hyperbolic tangent functions are applied. That is the mathematics behind, that is how they devise that architectures. Yeah, that's what I coming to that. By using such thing, what happens is what? Your short-term memory is overcome. That means your output is not only depend upon immediate past, because imagine this is our first sequence, record 1. Record 1 is the first word. You are going through. You are coming to the 1000th record, right? Even at the 1000th record, when you are working on, that trace will be there. That context will be remembered, because we are not using a fixed weight. So that is what is the meaning is it is a short-term memory in the sense what I am giving, still I am giving feedback to the immediate past sample only. A short characteristic is retained, it's retained for a longer duration of time. Even for the longer sequence it will. That means yeah. See, when you text is a very good example I can tell you. When you text messages and all, okay, after certain word you may be used another word that you might have used 1 month before, right? You might have used 1 month before. Even today, in between you have changed the context. When you change the context, initially it will confuse. Your model will confuse. 15 days before you have used this word after this word, but today you are using this word. That means this also it will taken into account, right? It means it's memory, right? Okay, your past 15 days before also after this word you have used some other word. That weightage also it will accounted in your model. We cannot see it physically, but in terms of cumulative summing points, that contribution is added somewhere. So it is incorporated not only your recent whatever the words you used after a particular word, it also remembers your 1 month before also whatever the words you used it. And in case if you are using these words over a period of time, you never use that word, right? Slowly that weightage it will start forget. It will forget. Your memory unit will forget that. Hereafter it will remember your recent things only. So the meaning is what? It will try to remember for the longer duration of time. That is what it's called as a long. And short-term memory is what? Based on your immediate the past sample we are feeding back. The weight change based on once you presented your input and you suppose what task you're validating your model, right? So how your model is going to learn based on the output, it compares the targets, and the same error back propagation algorithm works here, updating the weight. When its weight is updated and the next input is presented, and when the next input is presented, and this process will happen along with your error back propagation weight adjustment, and this tapping also taken into picture. Yeah, of course. obviously it will be different, it will be output. If you have no, almost RNN people are not using it. Just why I told RNN, LST has emerged from RNN. For that context I told RNN, but otherwise people are not using. You can use RNN for simple sequence. We have one exercise. LSTM model which is going to behave as a simple RNN is called as a vanilla LSTM. Have you heard about vanilla LSTM? The same spelling as like vanilla ice cream. VANNILLA. Vanilla. You can come across the term called vanilla LSTM means your LSTM is going to work as a simple RNN. If it is a mere LSTM, when we talk about a normal LSTM in the sense what? Your LSTM with memory units like this. That's the difference. Depend upon what sequence you are going to predict. If it is a very simple like the first exercise, you are going to see the character to character mapping. For example, alphabets. After A, my model, when I pass A means my model should predict B. B means C. There is not much context is needed for to understand this, right? My current pattern is sufficient, right, to predict the next character. Context is not so important for character to character prediction. For such model, a simple vanilla LSTM is sufficient. So this sophisticated LSTM is needed for the very little complex like your mobile text application and all. People use the multi-layered LSTM models. This is what the forget gate. The forget gate is working something like this. Suppose we have two contexts. Dinesh is nice person, full stop. After Charles on the other hand is evil. As soon as the first full stop after person is encountered, the forget gate realizes that there may be a chance of context in the next sentence. So after the next sentence, as a result of this, the subject of the sentence is forgotten. The subject is Dinesh is forgotten, and in this context, Charles will be remembered. How much it is remembered? RNN will say like distinct, right? Either it will remember or not. But in LSTM, you can scale that remembrance. 80% remembrance and 40% forget. Like that, you can scale it. One of the important pre-processing you should remember, particularly for LSTM model, the very popular data pre-processing is min-max normalization or standardization also, but very popular is min-max. Hope you know min-max, right? Every sample is subtracted by the minimal value divided by range, max minus minimum. Also, that is category has to be encoded. The same rule applicable for like deep learning model. Whatever we did it, one hot encoding has to be done. And coming to, because every record has different word length, right? Suppose you are solving movie review data. Movie review, the first review have 40 words and second review may have 60 words. When you encode, you have to maintain the equal length. So for maintaining the equal length, you have to do the padding, zero padding. The shorter has to be prefixed with zeros. So these are some of the pre-processing we have to keep it in mind for LSTM models. In the place of your LSTM model is something, it's going to act as a hidden layer, right? Instead of dense, you are saying your dense layer is made up of not as a simple neuron but memory units. You are going to say as a memory units. The two means the two neurons, two memory cells you are initializing in your LSTM layer, and your output layer remains same according to the number of category you specify the output. Only difference is what? How do we specify the input to the LSTM is you have to be a little carefully, you have to analyze according to the data size. So that's what we will see with the exercise better, this understanding will be better. What is time steps, what is samples, what is time step, what is features, you will understand with the examples. No specific reasons. We can also use all the exercise can be developed with functional architecture also. not for every cases. There are certain cases we can say functional could be better, but all the exercise whatever we have done, you can apply functional modeling also. More or less it will give the same results, not drastic differences. The previous residency we discussed, right? Instead of sequential, every layer you have to keep it. First, let us start with the simple case, character to character mapping. So we have generated the string A to Z. I have generated this A to Z. Here the idea is what? I have to press, whenever I present A, my model has to predict B. If B is presented, model has to predict C, next immediate character. So how do we generate the inputs? How to generate the input? What is my X, what is Y here for this problem? What is X and what is Y? Got it? Time shifted version. Time shifted version. So your X is what? Your original sequence, and Y is going to be the time shifted version. So we are going to prepare X and Y first. That is our first task. So my entire pattern is defined as a string, single string. Now I need to split what is my X and what is Y, the delayed version. First you run this first cell. As you noticed, what is the library is new to you? This is LSTM, right? LSTM is other than all things you are familiar with you. Okay. What is the first step we do? All this has to be numerically encoded, right? It has to be numerically encoded. So I need to encode this 0, 1, 2, 3 and so on. After numerical encoding, your X and Y will be looking like this, 0, 1, right? Like this. So character to integer and integer to character, that conversion we do the enumeration here. Yes. Okay, this is what the numerical encoding we do. A, B, C, D and all, it is a encoded like this fashion. Okay. Here what is the sequence length? 1, right? 1 word. 1 word is the sequence length. The next exercise, I will be increasing the sequence length to 3 characters. So here it is a 1 word. What it means that you can also build a model something like this. A, B, C, my model should predict D. When I say D, E, F, my model should predict G. When I give I, J, K, my model should predict L. This is what, what is the length of your every sequence you want to give. That is defined by here. Sequence length is 1 here. That means I am going to give this mapping first, then we will do this mapping next. Okay. Why? You need output, not it's a supervised model. How come without output? See what this function is doing. this function is just separating, according to your sequence length, it is separating the characters. So alphabet is what? To the string, complete string is stored. I to I, and here it is I plus sequence length. So that means your sequence input, if it is A, because it is string, right, it will taking A means your sequence out, it will fetch B as per this indexing. When your current I is 0, because you from alphabet of 0 plus 1 is fetched, 0 plus 1 is 1, it is going to fetch B. Here it is 0 to 0, right? 0 to 0 is 0, that means it is fetching A. So when I index is 0, it is fetching A for the input and B for the output. Similarly, it is speaking for all, and finally it is printing what is sequence in, what is sequence out. This is how we prepared the sequence pair, A, B, B, C, and so forth, so on. Yeah, when I is 0, alphabet of 0 is A, right? Alphabet of 1 is B. When I index is 0, 0 colon 0 means you start at 0 and stop at 0. That means you are fetching A. Sequence length is 1. When sequence length is 1, what is your sequence out? 0 plus 1, right? 0 plus 1 is 1. Alphabet of 1 is B. So it is taking B, sequence out. So 0 colon 1. See, in Python, when you say 0 colon 1, upper index is not inclusive, right? Upper index is not inclusive. That means it is fetching only 0, the first sample. A alone it fetches. That's what it is. 0 colon 0 plus sequence length. That means what? 0 colon 1, right? My sequence length is 1. And here there is no beginning index. Only simply it says that I plus sequence length. 0 plus 1. This time the second character is what? Simply it says 1. It is fetching 1. This is 0 colon 1. This is simply 1. Imagine if my sequence length is 3. Where? Because it is I plus sequence length, right? I is 0, sequence length is 1, so 0 plus 1, 1. But here it is I colon, from the beginning till this number. That is the meaning. Imagine if sequence length is 3, what is my sequence input? That is for the 0 index, 0 colon, I plus sequence length is 3, so 0 colon 3. What are the characters will be fetched? A, this is 0, up to 2, it won't fetch 3, 3 is not inclusive. So for ABC, what is your sequence out? 0 plus 3, 0 plus 3 is 3, which is 3, D, right? D is 3, so D is the sequence out. Which one? I plus sequence length, I plus sequence length, 0 plus 1. If you want a clarity, see. So is it clear now? See here, I put a brace here. Now it's clear for you? Okay, this is very important. This reshaping. Hope you remember for convolution layer how to present your input, right? Expand Dempsey we did, right? So same way LSTM also accepts input in a particular format. What format? It will be accept the input in terms of samples, time step and features. Sample, time steps and features. What is the samples? Total length of your records. 26, right? Total length of the record. That is length of data X. If you want to check what is there in data X, what is this one and what is this one? this is the step size. Okay, this is time steps. I taking one time step at a time. So we can control the time step. If I give time step 3, what it means? There are two ways I can fetch ABC. One is a framing. Another is in terms of time step. Is it possible to train this one using a normal multi-layer perceptron model? We can do that, right? One-to-one mapping only, no? One-to-one mapping. Still we can solve it. But there won't be any context. Contextual interest won't be there. But anyhow, for this data there is no context because your current sample single only. In that case, anyhow you are numerically encoding, right? A is numerically encoded. 0 should be mapped to 0. Sorry, 0 is mapped to 1. 1 is mapped to 2. Shall we? Because you have is a multi-class classification problem, right? It is a multi-class classification problem. Still you can apply MLP model. But when it comes to sequence of input, when you want to give sequence of input, how do you solve this in multi-class problem? You have to apply framing. Because you have a sequence of data, you apply first 3 samples, give us the input to the model. Next, windowing technique, something like a framing. You take these samples, give to the model. Next samples like this. Instead of framing, here I use a time step. When I specify time step 3, it will fetch first 3 records. That is what the time steps is. Here it is one sample at a time. And finally, feature is what? Single feature. What do you mean by single feature? Yeah, one-to-one, one-to-many, we are talking about that, right? If it is a multiple output or whatever, in that case, your input feature, but here it is a one input, one word input you are coining. For many-to-one mapping, your movie record, suppose you are solving this using LSTM, movie review. What kind of architecture it is? Many-to-one, right? That is many-to-one. So many-to-one in the sense, how many words you are going to have in the vocabulary? Because you are going to build the vocabulary. The previous rooters corpus, do you remember how many columns we used? 1000. In that case, what should be your feature length here? 1000. Understood? Here I am using just only one word, right? Only one column. This is what? Only one feature. Whereas in your movie review, you have one vocabulary things, no? Each one is one feature. So there your size should be 1000 for your, if you are maintaining your vector length is 1000, means your feature should be 1000 here, number of features. Okay, next we do the normalization, data normalization, and we do one hot encoding. And if you want to check for a sample, because we have 25 labels are there, 0 is encoded like this. How do we create the model? So first I use LSTM. This is something like how many neurons you select for the dense layer, hidden layer, the same way you decide it. There is no straightforward relationship or formula to decide this. It's a trial and error approach only. So 32 memory units we decide, and this is what you should give properly to the LSTM. Input shape. That's what you have to tell me. Already we have encoded, right? All the output labels are encoded with 26 units. We have 25 samples, so 25 cross 26. What is the X shape of 1? X shape of 1? 1. This is 1. X shape of 2 is 1. This also 1. 1 and 1. Input shape is 1 and 1. One time step, one feature. 32 neurons. 32 neurons. But here I use the term memory cell. Same as your dense layer, number of neurons. And from where it gets the input? It gets the input from one single feature with one time step. X shape of 0 is 25. But X shape of 1 is 1. X shape of 2 is 1. So what we got after reshaping? 25, 1, 1, right? I am not passing 25. 1, 1 is specified here as the input shape. And next is what? Your output layer. This is what output layer, y shape of 1. What is y shape of 1? 25. And if multi-class problem, so it's softmax. And your compile and fit as before, what you do it in the deep learning model, same as categorical cross entropy, because it's a multi-class problem. Remaining things are same. We are running it for 500 epochs. After running this for 500 epochs, so 88% is achieved for this model. Suppose I am randomly checking for one sample, because data of x4, what is data of x4? 0, 1, 2, 3, 4, that is A, B, C, D, E. I am going to check E as the input. When I am checking E as the input, how do you pass your test record? You have to reshape and pass to the prediction model. So numpy.reshape of test, you reshape this and you normalize this and you pass into the model.predict, and your prediction is this. You see which node is the highest. F, no, F, the node corresponding to F should be a highest, so that it will predict F. Okay, this is the highest, 10 to the power minus 1. All are less than, most of the things are 10 to the power minus 3, minus 5, minus 7, minus 9. Which is highest? This is highest. This is a node corresponding to 0, 1, 0, 1, 2. That is mean A, B, C, D, E, F. F, it got the high score. So I have supplied E is the input. So my model throws the output as F. But we want to see the actual numbers, right? So for that we apply argmax. When you use this argmax, it will convert back from your categorical to your original class. So I apply argmax, you get the index, and again we don't want to see as a number as an original character. I want to see as an original character. So integer to character conversion of that. So when you check result, in result you can see F when you check for E. So when you supplied E, F is predicted. And this loop is created to check for all the patterns. Okay, this loop is created to check for all the patterns. For pattern in data X, it one by one pattern it will check. Whatever we did it for one case, it is doing inside the loop, right? It is doing inside the loop and is printing. For A, it's predict B. For B, it's a wrong prediction, right? For B, it's a predicting, because it's not 100% accuracy. It is only 88%. There could be some misprediction also. For C, it's predicting D correctly. For D, E, E, F. So 88% it predicts correctly. What is the difference in the same problem with a different approach, slightly different approach? What are the changes in this code? That alone you see. Look at the LSTM to learn 3 character time step to 1 character mapping. What is the changes? All are same. Where you see the first change, sequence length is 3, right? Here the sequence length is 3. For this sequence length, first we generate the patterns. Let us see what is X and Y for this. So ABC, it will be D. Like this. We generate the pattern, your input output pattern, like this is X and here this is Y. Look at the shape now, shape of X. After reshape, because we did the reshaping here we did the reshape. Number of input. You have only one feature, right? This is what your only one feature. Mhm. Where? This is samples. This is time step. Sure, this is samples. Length of data X is the samples, and sequence length is what? The time step 3, time step of 3, and feature is 1. But ABC together it is one feature. ABC together is one feature. Something like a single word. Suppose you pass some word like, for example, what time. Suppose you want to type what time shall we meet. When you're typing what is one word, one feature. And so what time together when you type means that is many input to one output. That is for the movie reviews and all. Movie reviews, multiple words, collection of words you give as an input, and output will be single output, right? In that case, how many words comprising your features? That is what your features. We don't decide classify your review with one word, right? You classify the review with the multiple words. How many words you use to represent that review is what your features. Is that clear? Movie review. Yes, of course. Not literally, not after you build the vocabulary. Once you build the vocabulary, and what in the previous Reuters data, if you see, the first news group has only 86 length, and the second one has only 54 length, third one is 120 length. That means we have to we have to pad the sequence, fixed number of length. What is the fixed length we have used? 1000. So that is the length you have to use, because every review has different words, right? Your features will keep changing, right? For that you have to pad with zeros and maintain uniform length. That's what we use a function called pad sequence. Using that pad sequence, if the shorter one will be padded, prefixed with zeros. Even here for the next exercise we do the padding here. Next exercise, what changes I have done here? Here it is, I have given a fixed length, right? All three. We can also train with the variable length. For example, when I present A, my model has to say B. BC means my model has to say D. BCD means my model has to say E. You can decide what is the maximum length I can fix. Maximum length I am going to go up to 5. This is a variable length. Variable length, sequence length. So this is the length of single. So when I say maximum length is 5, means my feature length is, here it is, but still it is a single feature, but the length of each feature is 5, maximum length is 5. It's our user choice, no? Any size we can keep it. So I want to generate with maximum of 5, means up to 5 length you can check what is the next prediction, what is the length of the sequence. In case of
how do we define output? Let's say for a review data, we have one
only
line.
2 classes, right?
No, that is for sentiment. But for something like word prediction, next word prediction.
Okay.
We have to provide the predicted words, like set of words and all.
This is what the next word predicted. No, instead of word it is character.
Yeah. So for training the model for input, we have to give the predicted set of words.
Of course, the combination of words you have to give.
We have to give.
Yeah, that exercise also we have. We'll see. Word to word. This is character to character. Word to word also we'll see. So understood the shape now here, because the time step is 3. What is the input shape to LSTM here? This is the only one change, almost same coding. What is the shape here? X shape of 1. So here the dimension is 3, 1. 3 time step, 1 feature. 3, 1. Rest of the code is same. There is no change in the code. So when we do this, for 500 iteration, This is how model is predicting the sequence. Again, we have some prediction also. F, G, H, I, this is correct. D, E, F, G also right. Almost 100, okay. Because you can see the number of epochs is given high for this. (5,000) epoch is given. So next one, variable length input sequence. What we give is what there we have given in fixed, right, 0:i plus sequence. There we have used a random integer. So every time it will take a random integer value. My random integer may take 3 or 4, right? So the length of the sequence, you instead of passing a fixed value, you are passing the random integer value. So sometimes it will take 3, sometimes it will take 1, according to that. But you fix the maximum length is this much. Within that number only your random integer should generate the numbers. So in that case, you can generate using a random integers, we can generate the sequence mapping for the variable length. First we prepare the sequence from the data. See here, we have used the start and ending as a randint. That's the difference here. We are using this randint statement, starting index and to this ending. So here it will take, according to the start index and end index, it will take random combinations. And these are the different combinations it predicts. So your input data for maximum size is used is 5. Nowhere it is more than 5 is taken, because maximum length is defined as 5. So whatever the combinations to the maximum 5 you give as the input. What are the changes in the code? Here have you noticed this is new, right? Why we do this? Why we do this? Because every input not in the fixed length, because the variable length. When it is a variable length, we have to use this convert the list of list to array and pad sequences. So data X max length is 5. So there are certain words or only single character will come, or 2 characters will come, 3 characters will come. The remaining location it will fill with zeros. That's what pad sequence is. Now your entire will be, everything will be a unique size. So of file length, fixed file length. So that is why we need to do this pad sequences for unequal length. This you have to obviously do it for movie reviews. Correct? Which one? Individual record. Individual record. Because your individual record is represented by vectorized, right? It is vectorized. What do you want to do? Text classification. Okay. That's what I'm saying. No, you have fixed number of length for every record, right? Every record is tokenized. When you do the tokenization, every review is represented by so and so word, fixed vocabulary. Number of column in the matrices. Because there we are using tokenizer. Tokenizer is doing the job. So here we have not used the tokenizer, right? Here we are doing it we are doing with pad sequence option. There your fixed length is maintained by your tokenizer itself, because we specify the maximum size is 1000 for the root test data. So your maximum column is 1000. Not all the 1000 will be filled for every record. Yeah, individual word. Here also individual word, right? No. Individual word in the sense, what is my dat X is what are the combinations it produces, that is not my individual words. Because we are generating the combinations, right? Because we are synthesizing the input. This is not a real time data. So we are synthesizing the data. So when you are developing the data, this is one record. This is another record. This is another record. This is another record. Each one you are doing padding. When you do the padding, maximum length is 5, right? For this is 0, 0. Got it? Okay. If it is a sentence, suppose your record is sentence, you will be doing vectorization process. When you vectorize, your data is represented by fixed number of words. This is not required. This is not required. Here, this is a source data. Okay, this is my source text. Okay, I have collection of words. Using those source text, we are using the function generate sequence to generate combinations. So using the generate combinations, we generate the sequences. So for Jack and will be one combinations. After and Jill, word to word mapping, right? Jill, it is mapped to Went. Went will be mapped to up. The pairwise mapping will be taken as the generate sequence. You just run this function and see the output of data X. See what are the process we do it here. See here, first you have data and you are passing your data to the tokenizer. Why you are passing to the tokenizer? So you need to get the vocabulary from this, total vocabulary, unique words. The repeated won't be counted. If you count the total number of words, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. But the length of the vocabulary shows only 22. Because the repeated words it has skipped. My vocabulary length is 22. So we are applying this tokenization to the data, and this is what your encoded data. Like transform, like scalar. For scalar function, we do this scalar dot transform. Like tokenizer, this is how you fix. You're fitting this tokenization on the data. What is this? What does this result represents? Each of the vocabulary. Each word is, your tokenization has given some random numbers to each words, but it won't repeat it. That is the way your tokenization is given the random numbers to each word is encoded numerically, and everything is your collection of vocabulary, right? It is in the list. That is what is sequence. Your entire thing is in the form of a sequence. That is what the text to sequence. Sorry? Yeah, Jack is encoded as 2. Jack is encoded as 2. So what we do here in this, the word to word sequences. So sequence is an empty list encoded of, check your sequences. When you check sequences, 2 to 1, 2 is Jack, right? 2 is encoded, these are the all combination is created. Like A to B, B to C, ABC to D, like the mapping we did. For the sentences, before you mapping, first we encoded to the integers and then we did the mapping. So the corresponding word, if you relate it, after 10, 11, 11, 12, there are certain places 13, after 13, 2 will come. So all combinations generate. So all sequence we generate. So that's what we need, a rich corpus. So that is why this is for small 3 lines or 4 lines, but for the applications like whatever we use it in the smartphones, they have a very rich vocabulary. Like they have taken the Wikipedia vocabulary, complete rich of vocabulary. What are the combination of words will come? When you put now lakhs and lakhs, millions of combinations will come. So all combinations, for every word you search, it will give all 3 combinations, 3 or 4 combinations it shows. So that means your model is trained for all such combinations. If at all, if it is trained, that is how your model is going to pick up that. Among that, what are the frequent combination we use it? That is what you are predicted by. That is a real production, right? That is what model people have developed that model. Day-to-day production is what? It is a utilization, you are using it in the mobile phone. But day-to-day production, when you key in this word as an input, what is the model throws the output? So very frequently these words alone it is flowing it. Those words will be repeatedly showing for you. Sir, what you asked? Yeah, decoding will come last. So still we have not presented to the model. So we have encoded the data. So what we do next? We represent it in form of x and y, because the sequences, it is a list, right? 2-dimensional list. All the first entries in 0th column is what? Your x. All the entries in the first column you are mapping to y. This is what your x, this is your y. You define that mapping. Then your output is to categorical, because how many category we want to classify? Because it is each output is a category, right? It's a unique category. So you are converting to categorical, and you define your model. You are passing vocabulary size. What is vocabulary size? 22. So when you go to model, here is the model. You have passed vocabulary size 22. So additionally, what we do for more robustness, just by mapping a single number, let us say 14 mapped to 2, it is a good idea. The 14 is represented by 10-digit vector, like 1 cross 10 vector. 2 also represented by 10-digit real valued vectors. That will be more realistic. Instead of specifying one word, that is a one sequence in terms of single number, you are representing with the 10 numbers. Now, which will be more robust. Now, instead of deciding one number and say the 2 closer values now 14 and 15, and if you are comparing 10 different values, means this will be more robust, right? Instead of when you are comparing 15 and 14, how close it is, just single one unit. But 15 is represented, imagine if 15 is represented as 0.45, 0.36, 0.5, like this, and 14 is represented, and you have the difference is more. Every unit will be unique. That means each value is encoded in the form of a vectors, multidirectional vectors. It's our user choice. We can represent by 10 or 20, 30, that's what. So here we pass 10. Generally for, this is a small one single word, right? But for movie reviews and all, people use, let us say something like embeddings, 1000, 1500 you can specify. Long vector. So granularity will be better, right? It will be more, granularity will be better. Granules in the sense what, any example I could say. Which is more granular. Before encoding it will be more granular, or after encoding your value will be more granule. Granule in the sense what? You are breaking into a smaller units in the form of a vector. You can achieve granularity. That is what this embedding will be doing it. So precision will be increased. That's a simple idea. Why we need it? Because of the precision. It will increase the precision of your data. So granularity will be increased on this. This is the only additional thing we do it here. And as usual, your number of units here, LSTM 50 units, softmax, everything remains same. Okay. Additionally, we plot the model as a PNG file, architecture, it will show the architecture. And then we fit the model with 100 epochs, and after 100 epochs the model is evaluated, it's fitted, it is fitted on X and Y with 100 epochs, and you are checking, evaluating the model for the word Jack. Okay, you are evaluating the model for generate sequence for model tokenizer, because Jack has to be passed on to the tokenizer, right? Because you are passing the string, it has to pass down to the tokenizer, all the numerical conversion has to be done, embedding has to be done internally, and it will compare with which is the closest, and it has to show the, what is the 6 number, it shows that after Jack, what are the 6 next words should come. After Jack, what are the 6 next words after Jack? When you say 3, after Jack, what are the 3 next words? That is what in mobile, when you type one word, it will given for 3 options it's showing, right? 3 or 4 options. After this word, what are the options you want to display? 6 next sequence I want to see. That's what you see. So this is, I'm checking for Jack input. Yeah, 6 possible based on your independent mappings you did, right? So what are the closest to prediction for Jack? If you want to evaluate for single, that is, it will do it for multiple words, right? You want to predict a multiple in sequence. If you want to check for one single value, means you can specify your in text. What is your in text? I'm giving tumbling as my input word, and your model is going to predict for tumbling what is after the predicted word is after. It's predicting after for the input tumbling, because you are applying here. First your data is passed on to the tokenizer, and then you are doing it. You are doing the job manually here. Previously it was done automatically. This is manually you are checking for one single thing. 100 iteration, right? Actually, see, this one I have tested for 500 epochs, but 500 epochs will take long time. So I tested this for 500 epoch. I think for 500 epochs when you run, it will predict after correctly. But 500 epochs, at least it takes for me 12 to 15 minutes it took for 500 epochs. Yeah. Yeah, what are the 6 suggestions? This is for only one single value I am doing it. I am just printing for one single. Actually, see, there are 2 testing is done in this coding. One way is to check only one immediate word. Another is what? To predict the sequence. Okay, one to one and one to many. There are 2 things. If you want to check one to many, you have to call this function, generate sequence function. So what happens? Your model.predict classes is put it in the for loop. It is given in the for loop. So next 6 sequence, whatever the number of sequence you pass here, your model will check, because you are calling generate sequence function. You are passing the model. What model? Whatever the model you have designed, that model you are passing by calling this generate sequence. The same model is tested in a 2 different fashion. So one-to-one checking means I have done it in the last cell. That is what one-to-one checking. One immediate word at a time. When you are calling this function means your model.predict is called inside this 6 times, what according to the number of things you put it. So it is giving the output 6 possible next 6 in the flow sequence. Not necessarily always use the index. I am not using, I just generate the for loop just for a counter. I am not using the index, just for a counting purpose I use it, empty, it is an empty. That is how we mapped, right? How do we train the model? We have trained the model as one word to one word mapping, one word to one word mapping. Yeah. That's what is one to one mapping we did it. That's for your movie review is many to one mapping. Many words you will be having, many words will be mapped onto one output. One output will be like good or bad, sentiment, good or bad labels you will be giving it. So more or less your movie review also will be working like this. What is the only difference? Here one word input, one word output. A multi-class output, right? Actually here it is a multi-class output. For movie review, your input is multiple words input and output is going to be a single 2 classes, either 0 or 1. So that is what the assignment task for you have to do it. You have 2 choices. You can do it with the LSTM model also. You can try with DL model also. This is for the classification. But this is a sequence prediction. This is a sequence prediction. Why it is a sequence prediction? Because your output almost you can take it as like a multi-class classification also you can say, but it won't make sense, right? It won't make sense, multi-class classification. But here you have to treat this as a sequence prediction. Which one? Yeah, same. Instead of see your output is here it is a word. There you will be using your output as label, right? Zeros and ones. So all the labels you have to pass for y, either 0, 1, 0, 0, 1 like that. So here output also word. Again the word is numerically encoded, right? 14, 15 like that. Instead of 14, 15, 16 you will be having either 0 or 1, 0 or 1. That's it. Deep learning. There are, see it's impossible to touch all the models, correct? No, even in LSTM model itself, what we did is a sequence prediction, one case we did, and what we did is a classification. Classification is almost, it's like a multi-class classification. You are going to do binary classifications. You can also do, see imagine if I don't do this integer to character conversion, simply I am treating my input like this. Imagine my data is like this. Can I use LSTM for any other purpose? Numerical data prediction, right? So for stock market, for air passengers. So you'll be, this is what my x. What is your y? Delayed response, right? 15, 17, 18, 22, 46, 87. So if you train the model such like your time series data, you can model like this. That how many time steps you want to take, that you can define, right? If you want to take 3 time step means based on immediate past 3 values. See, how do we did, for example, A, B, C, D, how do we predicted D? Based on the past 3, when I give the time step 3. Similarly, your stock market data, you have so many features. Sorry, you have like this vertically, right? Day 1, day 2, day 3, day 4, day 5, day 6. And you are going to predict the 4th day based on the first 3 days. This is one mapping, right? This is one mapping. Yeah, that step size, the time step, you have to check it. So that also is, it is done as one exercise. You can just go through, it's a self-study. I think for now it is not shared with you. I'll ask program office to share it, but timing quickly I'll show that for the numerical data. Here you have to specify how many data you are looking back. LSTM model. You are looking back 3 or 4 samples or 3 samples, that you can tell in terms of time steps. So input shape you have to define, and we're doing the compilation because it is a regression problem. So instead of categorical cross entropy, I am passing mean square error. Rest other things are same. And since we are going to use this as a prediction, that is a numerical value prediction, regression, I need to do the inverse because I have standardized the data. So do the inverse transform to predict the values. Okay, this is the kind of output you get. It's a self-study, you can easily go through, not much difference. Only thing here, our data comes directly as a numeric. X you define and Y you have to define as a time step, delayed version. So X1, XY you define, and this is the data up to this we have predicted for the next month we have predicted. And also the root mean square error is given. So it is 23, the RMSE score is number of in terms of thousands of passengers. It is predicting the passengers in the thousands. Out of thousands of passengers, 22 passengers is the error of 22 passengers. Model is predicting with the error of 22 passengers. Which one? Yeah, that is the thing. They did it for the Keras classifier and Keras regressor, but in LSTM they kept it as positive. That is what the plus or minus your values. No, the blue and all your original samples and predicted samples superimposed. Original samples and predicted sample, because this difference is producing, right? This difference is producing your RMSE score. And why this color coding is separated here? This is actual and this is predicted. On top of that, you have, I can solve this using a normal regression problem. If you solve this as a normal regression problem, you do only up to prediction. But additionally, what we did, we predicted for the future samples also. So future samples also predicted, and based on the past history, this is separately color coded to show this is a future prediction. Future steps. Like future step after Jack, you wanted 6, next 6, right? Similarly, you can specify next how many samples you want to predict. That is how this is highlighted in this color. Which one? This is time series only, no? Almost right. Only the difference of 22 passengers. Sorry? No, it's not fabricated data. It's a real data. Real data. It's a real data which is used for the benchmarking. So because of the power of LSTM only, deep learning capability. If you do the same thing with the ARMA model, traditional ARMA model, you may not get this score. More error. You will get more error. Traditional time series, auto-regressive model and all, you will have more error, definitely. So if you can think of using this for stock market, it will be very interesting, right? Stock market, you can use this model for the prediction. So according to how many lags you want to make use it, just you have to look back how many data. That alone you have to specify. You just try. The same data you can work with some different data sets. If you have financial or stock market data, the market values, and you try to feed that with a delayed under, you'll get some interesting results. No, for generally any model, either machine learning or deep learning model, you should have some decent number of historical data. So that is a general rule. Then we have to see the characteristic of each model. Then accordingly you have to fine tune. Okay, this exercise I leave it for your self reading. You just go through it. So now almost all cases we have touched upon. Numerical value also we predicted. Only machine translation, many to many, is out of the context of this course. That, see, NLP itself, it's a separate field.
In today's tutorial, we have learned about natural language processing. What is natural language processing and how can you do some of the data manipulation using NLP? And what is bag of words, n-gram and naive bias. And also we have looked into sequential data, recurrent neural network and long short-term memory. And if you want to learn more all these new topics, all these advanced topics, then please go to Great Learning Academy platform where you will get almost 80 plus free courses, and after complete your course you can claim your certificate. That is also free of cost. Thank you so much to see the session.